In this paper, we're going to be looking at the proposed preparation, okay, for the mathematics paper 2 for grade 12 for the June of this year, okay. And so I have a paper that is out of 150 for 3 hours, and let's just use it for our reviewing purposes. So they're telling us that we have a total of 9 questions, and there's a special answer book, okay, which is that side. So if I'm to look at it, it has everything that is needed. Okay, it's not a big deal. Then show all calculations, diagrams, okay, answers only. It's just the usual instructions. We need to read them and understand. And then question number 1, which is data handling, or some people call it statistics. Okay, so they're telling us that a researcher observed the number of liters of fuel that were purchased by motorists on a certain Saturday. The data collected on that Saturday is represented on the histogram. Okay, so between 0 to 10 is 1 person. And then between 10 to 20 is 4, 6, 12, 18. We have 7. Okay, let me just, it's a 1, it's a 4, it's a 6, it's a 12, 18. We have 7. And then we have 2. And then 1.1, they want us to write down the total number of motorists that purchased. So by looking at all the totals, this is a 30, that's a 40, and then we're going to have 50. If you add up everything, we are getting 50 motorists. And then write down the modal class. So modal class on a histogram is the tallest bar, okay, or the class with the highest number of clients or motorists. So it's going to be 40 is less or equal to X is less 50. So that is the modal. Then 1.3, they want us to complete the frequency table that was provided. Okay, let's see what the frequency table is offered. Okay, so between 0 to 10, we said we have 1 for the frequency. And then the next one was a 4. So 4, 6, 12. And then we have 18. We have a 7, then a 2. Then we are getting cumulative. The first frequency will be the first cumulative, meaning that it's a 1. 1 and 4 is 5. 5 and 6 is 11. 11 and 12 is 23. 23 and 18 is 41. 41 and 7 is going to be 48. And then we're going to have a 50. Okay, so that is our cumulative frequency. Then 1.4, they want us to draw the ogive. Okay. Ogive, remember, it's a cumulative frequency graph. Let's see. So we have 1. We said we have 5. So 1, 5, 11. 23, 41, 48, and then 50. Okay, so whenever you're drawing the cumulative frequency graph, you look at the upper intervals. In other words, we're going to plot these 10, 20, 30, up to 70 against the cumulative values. Okay, so we're saying that 10 is going to go with the 1 because it is our first frequency. Okay, these are intervals of 2, 2, which means 1 is going to be somewhere then. And then 20 will take on the 5, 2, 4, which is somewhere there. And then 30 will take on 11, which is just slightly above there. And then we have 23. 22, this is a 23 somewhere there. And 48 minus 32, that's a 6 and 1. So it is a 16. Okay, then 1.9. 1.9. Determine the number of motorists at 75 percentile or above and calculate the total reward spent by the petrol station if each of these motorists are the 75th or above, about 60 liters each, with a reward of 0.4 rands per liter. So we need to find out how many people are above the 75th percentile mark. Now, from our graph or from our OGIF, we saw that it was how much? It was 37.5, ne? I think so. We saw it from this side. It was 37.5. So if we have a total of 50 motorists, and we're talking of 37.5, or roughly let's talk about 38. So 50 minus 38 gives us 12 people that are just above the Q3 level. So from here up to there, there's just like 12 motorists. Okay. Now the question is telling us that every motorist is going to get a 40 cents for each liter that was bought, and they bought 60 liters in total. So we can say that 12 determine the number, okay, calculate the total reward spent by the church. Okay, 12 multiplied by 60 multiplied by 0.4. I think this would make more sense now. So we are getting 2 comma. It cannot be a 2 comma because that's going to be 72 times 4, which is 8. So it's 288 rands that the petrol station would spend. All right, so that brings us to the end of question number 1. Then question number 2, they are telling us that in the diagram below, S is negative 48, T is that, and M and U lie on the same straight line. R is this much, T is that much. We also lie on another line. RV and SU intersect each other at T. M is the x-intercept of the line at negative 8. SM is the same as MU. So this is the same as that, which makes this a midpoint. Okay. And then they want us to get the gradient of RV. So 2.1. So with RV, we have R, we have T. In as much as we don't know the coordinates of V, so we can use RT. So gradient of RV will be the change in Y over the change in X. Or someone can say Y2 minus Y1 over X2 minus X1. They said calculate the gradient. Yeah. Meaning that but the question is not realistic. Why do I say that? Because they never specify whether they want the gradient in terms of age or just the gradient in general. So if we are to follow just the paper the way it is, they want the gradient, meaning that either someone can give it in terms of A, or someone can give it with just a normal number, which makes sense. Yeah? So I'll say 6 minus 4 over negative 12 minus 6. That's going to be 2 over negative 6, which becomes negative 1 over 3. If someone was using the A's, then there will be an alternative to say that it says, okay, A minus 12 minus 6, which will be A minus 18 over A plus 2 minus 12, which becomes A minus 10. So this would also be a gradient in that case. And it would be correct because we know that the point T, point V, and point R they are all lying on the same straight line. Okay, alternatively, someone would also look at the A2, A minus 12 with a T, which would also now bring another scenario to say it's A minus 16 over A minus 4. Ne? Is it minus 4 or plus 4? It's a plus, so it's A2 and that, which is a plus 8. Something like that. I believe that would also be another approach. Okay, find the length RT. So we're going to use the distance formula. So with the distance formula, we know that with the square root of x1 minus x2 squared, and then y1 minus y2 squared. When you substitute, it's going to be minus 12 minus minus 6 squared plus, that's going to be 6 minus 4 squared. Okay, so punching that into the calculator. Okay, punching it into the calculator. I'm ending up with 2 square root of 10 units. And then they want us to get the value of A. Now for the value of A, we've already seen the assumptions because we're treating these RT and V as collinear points. Meaning that if I get the negative 1 over 3 and then equate it either to this or to that, I should be able to get my answers. So I'll use A minus 18 over A minus 10. Is it 18 or 14? Nice, because it is A plus 2 minus minus 12. Is supposed to be a plus 14. Okay, so if it's a plus 14, do your cross multiplication, meaning that your negative A minus 14 is equivalent to 3A minus, that's 54. If I move this one that side, it's going to be minus 3A minus 54 plus a 14. What does it give us? Okay, so you have a minus A minus 3A is equal to minus 54 plus 14. So minus 4A gives us a minus 40. Divide both sides by minus 4, meaning that A becomes just a 10. Okay, then if SM is the same as M, you determine the coordinates of U. Remember we said M is going to be a midpoint. Ne? So if our U is XY, our M is negative 8, 0. And then what are the coordinates of S? We have negative 4 and 8. Okay. Then let's apply the midpoint formula. Meaning that if we get the negative 4 plus X divided by 2, we must get negative 8. And then if we get negative, is that negative or it's the positive 8 plus Y divided by 2, it should give us a 0. Okay, so when we cross multiply, that's going to be negative 16 plus 4, meaning that X is negative 12. Okay, if X is negative 12, and then when you look at the Y is going to be just a negative 8. So meaning that U is going to be negative 12 and negative 8. Okay, then they want us to get the equation of the line SU. So for us to get the equation, remember we need to always get the gradient first. Okay, so you can say that the gradient of SU is change in Y over change in X. We can use just these 2 points and say 8 minus 0 over minus 4 minus minus 8, which is just going to be 8 over 4 which is a positive 2. And then we can still use this negative 8 and 0 and say y minus 0 is equal to 2 into x minus 8. So y becomes 2x plus 16. Okay, and then next they want us to get the size of UTV. UTV. In other words, we must find the angle, this angle here. So what we need to know is that we found the gradient of this line to be a 2. We found the gradient of this to be negative 1/3. If we focus on this sort of triangle here, we can use the inclination method. We find this angle, then we subtract the 2. Okay, so if I call this my theta, call that your alpha, I'll say that my alpha is going to be the shift tan of negative 1/3. Is that correct? Yes. Okay, so shift tan of negative 1/3 is going to give me a negative answer. And remember, we said whenever you get a negative, you must always subtract from 180 so that you get the positive answer. So shift tan 1/3 is giving me 18, but it's negative now. So negative 18,43, and then I must plus 180. Okay. When I plus 180, I'm getting 161,57. And then my theta, it will be the shift tan of 2. Okay, shift tan of 2 gives me 63,43. Okay, then I need to subtract the 2 because we said alpha minus theta gives us the UTV because of the exterior angle. This one minus this gives us that. Okay, so it's going to be 161,57. You subtract 63,43. And that gives me a 98,14. Okay, 98,14 degrees. And then 2.7. If TV is 4RT, if TV is 4RT, okay, remember our RT was 2√10, meaning that if we multiply this by 4, which becomes 8√10. Okay. Can we determine the area of TUV? TUV. Now, since we got this angle to be the 98,14, the only thing that is missing is the distance TU. That's the only thing we need to calculate. And if we can get that distance, then we need to go with the area. Okay, so I'll write it aside and say that our distance TU, this is 2.7. Remember the coordinates of T are just -6 and 4. And then the coordinates of U, we got -8. And then there was another negative. Which number was that? -12. So it's -12 and -8. Okay, and then we just punch this into the distance formula with the calculator. So -6 minus -12 squared, 4 minus -8 squared. And then this gives us 6√65. Okay. And then when I use the area rule to say it's going to be a half TU multiplied by the distance that we got first, which was the TV or the V. Wait a minute. Oh, we need the TV, which we just got now. And then the sine of UTV. So it's a half multiplied by 6 root 65 multiplied by, we say that's going to be 8 root 10. Okay, and then the sine of 98,14. Okay, so when we punch this, I'm ending up with 168. This is units squared. All right, guys, so that brings us to the end of question number 2. Then question number 3. In the diagram, T is the center of the circle, x squared plus y squared. Okay, minus 12x minus 2y minus 8 gives us a 0. Is the equation of the circle. BC is the diameter. Okay. AB is a tangent to the circle at point B. S is the point AB. And then the equation of the line ST is given as that. The inclination is 172, this much. AC. It's very big now. If this is extended to the x-axis, this angle here is 172,875. It's almost a straight line. Okay, so, and that's what we have. Then they want us to get the coordinates of T. Remember, T is the center. And what we do, we just have to complete the squares, whereby we look at half of this, half of that. Okay, they don't want the radius in this case, so it's not a big deal for us. Okay, so it's either we express it in the form of completed squares, or we can just go ahead and get what is needed. Okay, so that's going to be x, said minus 6 squared. This is y minus 1 squared. I'm going to say is equal to, that's going to be 8 plus a 36 plus a 1. So it's x minus 6 squared plus y minus 1 squared is equal to 45. I'm squaring 6 to give me the 36. I'm squaring the 1 to give me that plus the 8. So meaning that the coordinates of T will be 6 and a positive 1. Okay, then determine the coordinates of B, which is the y-intercept of the circle. So for y-intercept, we know that x must be a 0. So from this equation, now why not use the summarized format? Okay, we're saying x minus 6 squared. This is y minus 1 squared is 45. So if x is a 0, which means we have just a 36, y minus 1 squared is equal to 45. Move the 36 that side, which makes it a 9. So y minus 1 equals a 9. Then let's find the square root here. So y minus 1 is plus or minus 3. So if I use a plus, y is going to be a 4. If I use a minus, y is going to be a negative 2. So meaning that B, since it's at the bottom, is going to be 0 and negative 2. Okay, so this 4 is just for the top part, where the graph, where the circle is touching the y-axis. Then show that ST is parallel to AC. Must round off answers to 3 decimal places. We need to prove that ST is parallel. Okay, so how would we approach this kind of question. Did they give us the equation of ST? Yes, they told us it's this, meaning that the A2y is going to be the same as negative x plus 7, divide through by 8, y is going to be negative 1 over 8x plus 7 over 8. And then let's see, if I extend this line to the x, if I get the same angle as this one, then we're good to go. So let me call this angle theta. We are seeing that our gradient is negative 1 over 8. So I'll say the arctan of negative 1 over 8 plus 180. Okay, let's punch this in the calculator and we see, so 180 plus the shift tan of negative 1 over 8. It's giving me 172,8749, which is 5. So the angles are the same, meaning that the lines are parallel. The reason is going to be corresponding angles. So that is how you would have showed that. So since the angles are the same, therefore ST must be parallel to AC. Okay. Then next we have 3.4. It is further given that ST squared is 65. In other words, if we square this distance, we must get a 65. They want us, and the coordinates of A are negative 4 and K. Okay. They want us to determine the length of AC. Now, we know that if this is, if these lines are parallel and T is a midpoint across this side, which means S should also be a midpoint. So we're going to use the midpoint theorem, which means the distance ST must be twice or must be half of AC. So AC is going to be twice ST. But we given ST squared is 65, meaning that ST alone is going to be the square root of 65. And then AC will be twice root of 65. Okay. Reason, we are saying it's a midpoint theorem. So twice root 65 because of the midpoint theorem. Then 3.4.2, they want us to get the coordinates of C. Coordinates of C. Okay, what do we notice? This line is parallel to that one. We do not have, okay. I think we can, we have this, we have that. If this is XY, then we can use the midpoint. I think that's quicker. Okay, so we're going to say x plus 0 over 2 should give us a 6, meaning that x is a 12. And then y plus minus 2 over 2 should give us a 1, meaning that y is going to be a 4. So 12 and 4 becomes the answer of interest. And then 3.4.3, they want the value of k if k is greater than 4. So we've already obtained the coordinates of C, okay, which means we can now use our distance formula to determine what is needed. Okay, so distance formula is going to be one approach. Alternatively, what we can think of is that since this is a tangent and the radius or diameter, the lines must be perpendicular. Okay, we could just find the gradient of BC And automatically we have the gradient of this together with the y-intercept. And then we substitute into that. I think that is quicker. Let's put it this side. That's 3.4.3. Okay. We're saying the gradient of BC, remember it was 0 minus 2. We have 6, 1. So 1 minus 2 is going to be 3 over 6 minus 0 is 6, which is a half. So then the gradient of the line AB is going to be negative 2. Okay. And then the equation of AB is going to be negative 2x minus 2. Y is minus 2x minus 2. Then at a point A, where x is negative 4, we're going to say k is minus 2 into minus 4 minus plus 8 minus 2, which is a 6. Okay, that's one way of also doing that. And then 3.4.4, they're telling us that equation of a circle, they want us to determine the equation of a circle that is passing through A, B, C in that form. Okay, so when you look at A, B, and C, then here there's another circle between A, B, and C. So if this is a 90, then automatically AC becomes a diameter. Okay, we've already seen the distance to be twice 65, meaning that the radius is just going to be a 65, and then that's also going to be a 65. So the only thing we need will be the midpoints. So here I have negative 4 plus 12 over 2. That's going to be 8 over 2, which is a 4. With the y, remember we got the k as a 6. So 6 plus 4 is 10, 10 over 2, which is 5. So it's going to be a 4 as well as a 5. Ne? Then my equation will be x minus 4 squared. Then y minus 5 squared is equal to, the r is square root of 65, which is just going to be a 65. So that becomes the equation. But the first things first, you need to get the radius and then you also find the midpoints. Question number 4, which is the trick. They're telling us that if the sine of 14 degrees is t, determine the values of the following in terms of t. So questions of this nature, we always advise learners to draw up a sketch. Okay, this sketch does not need to be in any quadrant. So 14 sine is opposite over hypotenuse. Then this is going to be 1 minus t squared if we use the theorem of Pythagoras. Then the one the cos 14 is adjacent over hypotenuse. So it's the square root of 1 minus t squared. Okay, I think that is correct. Or you can say over 1, but it's not a big deal. And then they want the sine of 38. So if this is 14, what angle is that going to be? It's going to be a 76. No? But we know that 38 is a half of 76. I don't know if that makes sense. It makes sense, no? So if ever I'm talking of a sine of 76, which will be the same as the sine, I think it's better I use the cos. I think cos is going to be much more quicker. If I look at the cos of 76, this is more like cos of 2/38. And then I can change this into a sine format, which is going to end up being 1 minus 2 sine squared of 38. Then I have to transpose so that I have a cos of 76 minus 1. Okay. But then I'm going to divide it again. Why don't I just shift everything to that side so that we avoid the negative parts? So it's 2 sine squared of 38 is 1 minus cos of 76. Divide both sides by 2 and then find the square root. So sine 38 will be the square root of 1 minus cos 76 divided by 2. Okay, we know that the cos of 76 is going to be t over 1. So mean that's going to be the square root 1 minus t over 2. Okay, and then the sine of 59. So how does 59 relate to any of these? Okay, it could be a special, we can create special angles from here that can connect with the 14. I think 45 and 14 will give us a 59, meaning that it's a sine of 45 plus 14. This is 4.1.3. Okay, so if I say the sine of 45 plus 14, and then I expand this, sine 45 cos 14, sine 14 cos of 45. So we know that the sine of 45 is 1 over root 2. And then the cos of 14 will be this root 1 minus t squared. And then the sine of 14, we got a t, 1 over root 2. So same denominator, so t plus 1 minus t squared over square root of 2. That is how I would have obtained that. You feel free to also rationalize and root 2 over 2, but I would leave it at that. Then 4.2, simplify into a single trig ratio. Okay, so when I look at this term, what does it give us? What is it showing us? 4.2. Okay, so I'm going to break it down into a single trig ratio of A. Let's put it aside. We have the sine. Okay, it's a sine of A multiplied by the tan over half A minus 360 minus 1. Okay, that is the question. But they want us to give it just as a single trig ratio. So what would be the options available in this case? Anybody? What would we do? Okay, I would start by changing this around so that I have a negative out. So it's a tan negative, that's 360 minus a half of 8. Then I apply my reductions. Okay. 360 minus is in the fourth quadrant and tan is negative. So this negative and the negative is going to give us just a positive. So sine A, this is going to be tan over half A minus 1. But now if I use the double angle identity of sine, because we know that a half and a half gives us just 1. Okay, so it's going to be 2 sine over half A cos over half A multiplied by, we know that tan is the same as sine over half A over cos over half A. We are subtracting a 1. Okay. Then I can cancel this and that. because this is just a product of one thing. So we're left with twice sine squared over half a minus 1. From our double angle of cos, remember we have 2 cos squared of a minus 1, or 1 minus 2 sine squared a. So it's more like in this format. So take out the negative. Do we need to take out the negative? I think we can. 1 minus 2 sine squared half of a. And what will this become? To be a cos of a. To be cos of a. So, but since the question wanted one trig ratio, I have a feeling this is a +1, not a minus. Oh Lord, so now how things are changing. It's a +1. If it's a +1, then there's nothing we can do. Because I thought it was a -1 initially. If it's a +1, then it must stay as a 1. There's nothing we can do. It's a single trig ratio or a head. Okay, so that is that with that question. And then 4.3, we're given this function. And then they want us to prove that if we reduce this, we get to the tan of 2x. Okay, so let's see. Let's see. Remember, tan 2x is the same as sine 2x over cos 2x. So top, we must have that. Bottom, we must get to that. So let's reduce and see. So that is 2 cos x. Cos of 90 minus is going to give us a sine x over, that's cos squared, and then plus 180 plus, that's going to be a negative sine. And then this is going to be a positive cos. Now we are multiplying with the tan, which is sine x over cos x. So this cancels that. We're left with minus sine. So it's 2. Okay, let's simplify the top part, which is sine 2x over cos squared minus sine squared, which gives us cos 2x. And then that becomes tan 2x. Okay, and then 4.3.2, write down the values of x in the interval where this is undefined. So the graph of tan 2x will be undefined in a few cases, okay, where we have the asymptotes. And in this case, normally it's at 45. And then we could also have one at negative 45. Okay. 45 or negative 45. Because normally it's undefined at 90, but since we have a 2, then we're going to divide it by 2. Okay, x 45, x negative 45. And then 4.4, given cos theta plus 30 is a half sine theta, they want us to find the general solution. Okay. So with the general solution here, it's either we open up and get a single trig ratio. Okay, so opening here, we're going to have the cos of theta, cos of 30, minus sine of theta, sine of 30 is equal to a half sine of theta. We know that the cos of 30 is a √3 over 2 minus a half sine theta is equal to 1 over 2 sine of theta. So we know that if I move this a half to that side, I'll have a root 3 over 2 cos of theta. Let me just move it that side so that I get a 1 sine theta. And then if I divide by cos theta and cos theta, I'll get a tan, meaning that tan theta is a root 3 over 2. And then I have to get my reference angle, shift tan of root 3 over 2 plus k times 180. But I need to look at both quadrants. So the first quadrant is going to be a 48,89 plus k times 180. K is an element of integer. So we know that tan is positive in quadrant 1, but also in quadrant number 3. So 180 plus 48, that gives us 228. Is it 228 or 2? No, man. This is a 40,89. Okay, then that's going to be 220,89 plus k times 180. K is an element of integers. Okay, so that is question number 4. And then question number 5, which is the trig functions. We are given the following. Okay, the graph of course between those intervals. Then they want us to write the period of f of x over 2. So meaning if it's the cos x over 2. We know that the period of a normal cos is 360. Then if you divide it by 1 over 2, it becomes 720. And then write down the range of this. Okay, so now since the coefficient is 1, which means it will go maximum 1, minimum 1, but they want the range after they have shifted the graph 1 unit downwards, which means it's going to be here and at a -2. So we're going to say 0 is less or equal to y, less or equal to, it's -2 actually, less or equal to y, less or equal to 0, because the smaller number first. Then draw the graph of a half sine 2x on the same set of axes. So if you use your calculator, okay, with a table and that method of drawing from the table. So mod the table, we type in our a half sine 2x. Okay. There is no gx, so we're gonna skip that. We're starting from -90. We are ending at 180. Our step is 45. Okay, so when x is -90, it's a 0. And x is -45, it's -1/2. When x is a 0, it's going to be a 0. When x is 45, it's a +1/2. And then 90 is going to be a 0. The -1/2. And then a 0. So we have something like that. Okay, so that's the kind of graph that we are getting. Okay, then 5.4, write down the minimum value of g of x minus 25. When they talk of the minimum, remember this minus 25 is a shift horizontally. Okay, it doesn't affect the maximum and the minimum, which is the vertical distance. So meaning that our minimum is still going to be -1/2. And then use the graph to determine the values of x, where sine x cos x minus this is equal to 0. So how do we relate this to what was given? Remember, the first graph was just cos x. And then the graph we were told to draw is a half sine 2x, and of which we know that half sine 2x is the same as 2 sine x cos x multiplied by a half, which gives us just the first part. Meaning that if we move this one that side, sine x cos x is the same as cos x. Graph of f is the same as the graph of g. So where do the two graphs intersect? Okay. So they are intersecting at 90. Okay. Then they are also intersecting at 90, which is positive. I think those are the only two values we have. So x is a negative 90, x is a 90. And then our question number 6, which is the 2D, 3D trick. Diagram below, Kn is a vertical tower, Lnm are points on the same horizontal plane. The angle of elevation is theta. We have the 30 and all of that. Then they want us to write down the size of MLN, this angle here. So if you get your 150 minus theta plus the 30 plus the MLN, we must get 180. So this and this is already 180. So mean that MLN is going to be a theta. Okay. MLN is just a theta. And then determine the length Ln in terms of sine theta and cos of theta. So since we're looking at sine and cos, how is that going to work? Okay. Ln. So we can use the sine rule and say that Ln, we are dividing it by the sine of 150 minus theta, should give us 24 over the sine of theta. But we know that 150 is the same as 90 plus 60. Okay, but we're going to subtract theta. I mean, that's the same as 90. Alternatively, someone would have said 180 minus 30, which would also make sense, because I really want to open this up, but I'm going to be left with no choice. Mm-hmm. 90 plus 60 minus theta. But it's fine, we can open it up here. So Ln is 24. That's going to be sine 150 cos of theta. Okay. Minus cos of 150 sine of theta. Everything is over sine of theta. We know that 150 is the same as 180 minus 30, so it's a 24. That's a sine of 30 cos theta. And then this is going to be cos of 180 minus, might be negative, with that negative, which is a plus, cos of 30 sine of theta over the sine of theta. Okay, so we know that sine of theta is a half. Okay, 24, that's a half cos of theta. We know that the cos of 30 is a root 3 over 2. sine of theta over the sine of theta. Then you introduce the 24, which means the 12 cos theta minus, let's say plus 12 root 3 sine of theta. Everything is over the sine of theta. So this is what we end up with. And then hence, otherwise, can we show that the height of the tower? Okay, this one. So we have this, we have that, so we can use the tan and say that the tan of theta is equal to Kn over Ln. We already have our Ln. So meaning Kn is going to be the Ln, which is the 12 cos theta plus 12 root 3 sine theta. Everything is over the sine of theta times, okay, times tan of theta, which tan theta is sine theta over cos. So this cancels that. And then we're going to have a 12 cos divided by the cos. 12 root 3 sine over the cos. This cancels, so it's a 12 plus 12 root 3 tan of theta. And then 6.4, they want us to get the size of theta if the elevation angle, if Kn is 46. So let's just do the substitution and say 46 is equal to 12 plus 12 root 3 tan of theta. Move the 12 that side, then we divide by 12 root 3. So that's going to be a 34. We're dividing it by 12 root 3 is equal to the tan of theta. And then you must find the arctan of this angle, which should give us 58,56. All right, question number 7. In the diagram below, O is the center. Okay. With the circle passing through ABC, BD is a tangent to the circle B. Prove the theorem which states that the angle between the tangent BD and the chord BC is equivalent to the angle in the alternate segment, which is this. So they want us to prove the tan chord theorem. Step number 1, we start with the construction. Through the center, we have the diameter. You can label this maybe a T, because we don't have any other T. And then this must be connected. So what does that mean? I'll break this down into a 1 and a 2. And then I'll also break this into a 1 and a 2. So I'll say that B1 plus B2 is going to be a 90. Okay. Reason being, this is tan perpendicular to the radius. So what does B2 become? It's a 90 minus B1. Then I'm also going to do the same thing and say A1 plus A2 is a 90 because this is a diameter. So this will be angle in a semicircle. And then what does A1 become? A1 is the same as 90 minus A2. But from our angles in the same segment, we know that B2 is the same as A2. Is that true? We're saying B2 is the same as A2. Okay, where we see B2, we're gonna no, we're supposed to show this. This is wrong. It's supposed to be B1 and B2. Okay, so if that is the case, but even that approach was gonna make sense. where we're saying B2 is the same as that. No, it's fine, no problem, no problem. Okay, so if B2 is the same as A2, we can replace that, meaning that A1 is going to be 90 minus a B2. And now A1 and B1 are just showing us the same results. Therefore, A1 is the same as B1. Okay, so that is all you have to say. Remember, we said this and this angles in the same segment. Okay, then 7.2. In the diagram, where is the center of the circle? PSQ are points on the circumference of the circle. SRQ is a 54. SR and QR are tangents the circle from a common point. Okay, so we know that tangents from a common point will be equal to each other. So meaning that Q3 and S1 are the same. They want us to get the size of Q3. If that is X, mean that twice X plus 54 should give us 180. But we were supposed to start by telling ourselves that SR is the same as QR. Tangents from a common point. And then what is 180 minus 54? That's going to be 126. And then divide by 2. Okay, so if you divide it by 2, you're going to get a 63. So I'm having that as 63, and I'm getting that also as a 63. And then they want us to get a size of P. Now, P is going to be a 63 because of the turn chord theorem. Okay, can be this to that or this to that. So if this is a 63, then they want us to get O1. O1 is the angle at the center, which must be twice that 63. So which is 126. Angle at the center is twice angle at the circumference. Okay. And then question number 8. They're telling us that in the diagram below, O is the center, BCD is a cyclic quadrilateral, BCDE, okay. G is the midpoint of the chord EC. AB is a tangent. And then they're telling us that GD to OG is 3 to 2. So GD to OG. And then ED is 2 units. Okay. And then they want us to prove that AB is parallel to EC. Okay, so number 1, for us to have parallel lines, we can use alternate, corresponding, and co-interior. So one thing we need to know is that ABD is a 90. Reason being, tangent must be perpendicular to the radius or diameter. But also, we're saying G2 or G1 should be a 90, because this is a line from the center, and bisecting the chord should be perpendicular. So line from the center, or we can say perpendicular bisector. Line from the center to the midpoint. And if that is the case, then you just draw the conclusion that the angle ABD is the same as G2 or G1. Therefore, AB will be parallel to EC because of the converse of the corresponding angles. Okay. And then 8.2, can we prove that BE is the same as BC. Can we prove that those two are the same? So what we can do, we can try to use congruency. Okay. If I look at the triangle BEG and then BCG, we see that CG is the same as GE. It's given. And then we see that BGC is the same as G1, which is a 90, because angles on a line. And then we can also see that BG is the same as BG, because that is common, meaning that BGE is congruent to BGC. Therefore, BE should be the same as BC. Okay, so we can do it that way. Or you can also just compare the angles alone. Because if this is a 90, that is a 90. Okay. And then we also, what do we see? Because B is the same as D. B is the same as BC. Yeah, I think that approach is fine. It's better. If you look at the remaining angles and all those aspects, I think it's fine. Then if it's further given that FO is parallel to EC, determine the ratio of EF is to FA. So one thing we need to know is that GD plus GO GD plus GO gives us the total radius, which is OB. Okay, which is the same thing. Eh? But then, from our proportionality theorem, if we get the HE divided by the HB, okay, it should give us just the same as someone that uses OG over OB. So meaning that HE is a 2 over 5. We are saying line is parallel to one side of a triangle. Or someone can say proportionality theorem because of the lines that are parallel. Okay, that's the first kind of aspect, and we need to bring in the EF and OR. So if we get the FE, okay, we're getting the FE, and then we are dividing it by the FA. It should give us the same thing as OG, which is the same as EH. Over the HB, which is still also 2 over 5 because of the proportionality theorem. Okay, so that is that. Then 8.4 determine the length of BC if the diameter is 20 units. The length of BC from here up to there. Okay, we say this is parallel to that, and we have a 90. Which one is the 20? BD is a 20. Okay, so we can find BE using the theorem of Pythagoras, because if the whole of this is 20, we have this as a 4, then we can find that and say that our BE squared is going to be 20 squared minus the 2 squared, because they said ED is, okay, so minus 2 squared. And then we must put this under the square root. So punching this into the calculator, it's going to be square root, oops. Okay, 20 squared minus 2 squared, which gives us 6 root 11 units. But we say BE is the same as BC, which means it's 6 root 11. Okay, then move on to question number 9. In the diagram below, O is the center of the circle, DEC are points on the circumference, and then DB is also a tangent at point D. We have a chord CD that is extended to point A, and C is also extended to point F. Okay, B2 is X, and then DE is parallel to AB. Okay, then DE bisects the angle CDB. CD, CDB, meaning that this angle is the same as that angle. All right, then the first question is asking us to prove that CDFB. Okay, prove that CDFB is a cyclic chord. So I can see an element of angles in the same segment. I think I can use that. Okay, so if this is X, I need to just prove that C2 is also X. And then if I can do that, then I'm good to go. So one thing I know for sure is that C3 is going to be X because of alternate angles. Because DE is parallel to AB. And then since this is a tangent to the circle, meaning that C2 is going to be X because of the tan chord. And then since C2 is the same as B2, which is X, therefore CDFB is a cyclic chord. Okay, because of angles the same segment. So converse of angles in the same segment. Okay, so that is how 9.1 would have been answered. And the 9.2, they want us to prove that triangle ADF, okay, that this triangle is similar to CBF, CDF. So something of that nature. Okay, so if this is a cyclic chord, simply means that C3 is going to be the same as that entire angle. Will it make sense? Okay, let's see. What we can start by saying is that the angle FBC is the same as angle D1. Okay, so this, we're equating it to the whole of this. Because remember, we said this is a cyclic quad. So it's going to be exterior angle of a cyclic quad. So exterior angle of a cyclic quad. Okay, that is 1. And then 2, we are saying that C1, this angle, which is a turn chord, because this is going to be like in a circle. C1 is the same as D4 because of the turn chord. But we say this was X. Okay, meaning that A is the same as D4. Reason being, those are corresponding angles. Because DE is parallel to AB. So we are left with one more angle to go. Then automatically it will be the remaining angles. So we're going to say that D, no, it's F3, is equivalent to F1 because of the third angle, the triangle. So therefore, ADF will be similar to CBF. The 9.3. 9.3, they want us to prove that AD is the same as that. So what's going to happen is that when we look at our proof in the previous question of the similar triangles, we could say that AD divided by CB will be the same as DF over BF. Now that's according to the sides that are corresponding to each other. So AD over the CD and so on. So when I make the AD the subject, it's going to be the DF multiplied by the CB over the BF. Okay. So that is how we would have done that, because DF over BF and then all of that. Then 9.4, I want us to prove that this is that. So still, from where we stopped, if we can also use the proportionality theorem, since we have the parallel lines, we could say that AC divided by AD is the same as CF over AE. If you make AD the subject, it's going to be AC times AE over CF. Okay. Now we are saying that this is that. And then this is what we had previously. Okay. We know that AD is the same as. Now these two are the same because it's AD and AD, which means we just have to equate. Okay, so guys, that's what we had to do in this particular paper. I wish you guys all the best in your preparations and also in your forthcoming examinations. Bye-bye.
Welcome to Thundereduc, an online learning platform powered by professional, highly skilled and qualified educators.
We deliver structured CAPS online lessons for high school subjects, including mathematics, physical sciences, life sciences, geography, business studies, history, accounting, English, Afrikaans, and others.
For the intermediate and senior phases, we offer expert teaching in natural sciences, mathematics, social sciences, English, and EMS, designed to build strong academic foundations.
Access the distinction material books by clicking join button on our YouTube channel or download Thundereduc app on Google Play Store for all our study material and past exam papers.
Thundereduc offers extra classes for rewrites, old curriculum, and other students from grade 4 to grade 12 through online and physical classes.
Subscribe to our YouTube channel, Thundereduc, for reliable curriculum-focused learning and stay updated with the latest educational content.
Please like, share, and turn on notifications so you never miss a lesson.
Visit us at www.thundereduc.com
or call 0786 636 613 or 084 833 1738 for more details.
Thundereduc, we focus on quality.
Post memorandum of the paper 2 mathematics June examination for grade 12 2025. Okay, so within this paper we have a well-structured paper whereby the answer book is also merged with the question paper. So the paper had 9 questions. We apologize for the quality of the paper today, but we shall work with it, okay? So only answers will not be given full marks, meaning that we have to show our calculations and workings, okay? Information page with the formula will be included at the end, necessary round of 2 decimals. Okay, and then candidates may not retain a question paper or remove one from the exam room. Okay, all right. Then we have a lot of instructions here, but that's not the business of the day. Question number 1. We've been told that in the diagram below, ADQC, okay, and DPB are straight lines. Okay, so this and then this are straight lines. Okay, this is a point on the y-axis. A and B are points on the x-axis. The equation of BC is given as this. And then the equation of AC is given as this. It's further given that P is that, Q is that, and then T is that. Then the distance TP is given as that. Okay, then 1.1, they want us to get the gradient of PQ. So whenever a question asks us for the gradient, we know that gradient is given as the change in y over the change in x. Alternatively, you can tell us the y2 minus y1 over x2 minus x1, okay? So what I'll do, I'll say 3 minus 1, okay, over 7 minus 6. So 3 minus 1 is a 2 over 1, which is the same as a 2. That should be 2 marks, okay? Then they're asking us, why is PQ parallel to BC? Why is this line parallel to that one? Now, since we found the gradient here to be 2, we know that when lines are parallel, the gradients must be the same. So we're going to say that the gradient of BC is a 2 from the equation, meaning that the gradient of BC is also the same as the gradient of PQ. That's the kind of explanation. We must give a reason. So we're going to say that they have the same gradients. Okay. The lines have the same gradient or equal gradients. Okay, so that is 1.2. Then 1.3. They're telling us that if Q is the midpoint of DC, we must get the coordinates of C. If Q, this line, this point, is the midpoint of DC, then we need to find the coordinates of C. So we don't know the coordinates here. So that is X and Y. We can get the coordinates here from this equation, whereby we know at D, X is a 0. If X is a 0, then Y is going to be a 2. Alternatively, what we can do is break down or rewrite this, meaning that 7Y is going to be X plus a 14. Let's divide through by 7. We have 1 over 7X plus 14 over 7, which is a 2. So meaning that D is going to be 0 and 2. Okay, with our midpoint, so we're saying that D is 0 and 2. And then we see Q is 7 and 3. We're seeing C as X and Y. Let's use the midpoint formula that talks about X1 plus X2 divided by 2 must give us the midpoint, which is a 7. Okay. Same story with Y1 plus Y2 divided by 2. We must get the Y coordinate of the midpoint. 3. So let me do the substitution. So X plus 0 divided by 2 must give me a 7. When I cross multiply, meaning that our X is a 14. And then Y plus 2, this Y and this 2. Divide by 2 must give us this 3. Cross multiply, Y plus 2 is a 6, meaning that Y is a 4. So the coordinates of C are 14 and 4. Okay, and then 1.4, they want the size of ACB. Where is ACB? So A, C, and B. So this angle here. So with that, I can use the angle of inclination, okay? I can find the size of beta since I have my gradient as 2. Then I can find the size of theta since I have my gradient as 1/7 from here. All right, so we know from that inclination method to say that M is equal to the tan of theta, okay? So for us to get theta, we said it's 1/7 equals the tan of theta, meaning that theta is the arctan of 1/7. All right, so let's punch that shift tan, 1/7, getting a small answer, which is 8,13 degrees. Then for beta, we're gonna do the same thing. M is equal to the tan of beta. So our M was a 2, because the tan of beta, meaning that beta is gonna be the shift tan of 2. Beta becomes 63,43 when I punch this into my calculator. All right, so for us to get the angle of interest, we know that this beta is an exterior angle, which must be the sum of this angle C and then that angle A. So we're saying that A plus C must give us beta. Okay, A plus C must give us beta, meaning that the C of interest will be 63,43 minus 8,13. When I do the subtraction, I'm getting 55,3 degrees. So that is what we had to do for 5 marks. But why did they give a lot of space? To give people an impression that there's a lot of work to be written. Okay, but we understand they are being generous so that if, let's say, learners make any errors and mistakes, can just cross out and write in some extra space. Okay, then 1.5, they want us to get the area of BODC. Let's see, BODC. So when you talk of B, O, D, and C, looking at this entire shape here, this quadrilateral. So there are 2 ways to it. One, we can use what we just calculated, the 55, it's 3 degrees, because that's what we got. Whereby we can get the distance CD, get the distance CB, use your area rule for this triangle, and then get the area of this right angle triangle, and then you plus them together, you're gonna get an answer. What I believe is the quickest way. Okay, I'm trying to avoid decimals. I'm going to look at this entire big triangle ABC. So if I get the area of ABC, I subtract the area of ADO. Okay, whatever I get will be the area of the quadrilateral. But this approach of mine comes with some conditions whereby I need to get the coordinates of A and I also need to get the coordinates of B. So with A, we know that this is the x-intercept and we have this. If we replace x with a 0, no, y with a 0, y is with a 0, meaning that our x is going to be negative 14. Okay, so we shall come down here and say that if y is 1 over 7x plus 2, we said y is a 0. 1 over 7x plus 2, move the 2 that side, so negative 14 is going to be x, meaning that a is negative 14 and 0. Same story with the b, coordinates of b. It was a 2x minus 4, if I'm to remember correctly. Let's not guess here. It's 2x minus 24, sorry. So 2x minus 24. So if it's a minus 24, I'll equate it to 0, move the 24 that side. 2x is 24, meaning that x is 12, meaning that our coordinates of b are going to be 12 and 0. So if that is true, I'll go back and say that if that's a 14, and then this is a 12, so the total distance for my base is going to be a 14 plus a 12, okay? And then my height is going to be the y value of the c, which we got as what? As 4. So I'll say that the area of ABC, okay, is going to be a half. The base is 20, is it 14 and 12 is a 26 multiplied by the height, which is 4. What does this give us? It gives us a 52 units squared, okay? So that is the entire big triangle. Then when I come and look at this small triangle here, it's right angled because there's this y-axis here. And since this is the y-intercept, this will be 2 units. This will be 14. So a half of 14 times 2, which gives me 14 units squared. Then I need to do the subtraction. So area of BODC is going to be my 52 minus 14. Okay, 52 minus 14, we must get something like 38 units squared. Okay, so that is how I would have approached this, né? But you can use your quick way or the shorter way of finding the distance CD, find the distance CB, and then use the area rule, and then you plus this, okay? But with that approach, you're gonna get an answer which is in decimals, but it should be very close to the 38. Okay, so that is 1.5. Okay, then 1.6, if TP is square root of 293, they want us to get the value of K. So we can use the distance formula, whereby we know that our K is bordered by which coordinates? It's K and negative 1, not so. K and negative 1. Then we have P, which is 6 and 1. 6 and 1. So P is saying is a 6 and 1, and then T is basically K and negative 1. So let's use the distance formula, whereby we know that our TP is going to be the square root of x1 plus x2 squared. It's not a plus, it's supposed to be a minus. Okay, x1 minus plus y1 minus y2, we square that. Let's do the substitution. So that's gonna be root 293 is equal to the square root. I'll say k minus 6 squared plus negative 1 minus 1 squared. Then I need to square both sides so that I get rid of the root sign. Okay, so 293 is equal to, open this, k squared minus 12k plus 36 plus, when I simplify that, I will get a 2, which is giving me a 4. So let's move everything to one side so that we get a quadratic. So minus 12k, this is a plus 40, and then 293, we're subtracting a 40, we're getting 253 negative, okay, minus 253 is equal to 0. You can use your quadratic formula or you can just use your factors. So this is gonna be plus 11, and then this is gonna be minus a 23. Okay, if I'm to really do that, but quadratic formula would make life a little bit easier, okay? Meaning that k should be a negative 1 or K should be a 23. But looking at the position of K on the Cartesian, we're seeing it on the negative side, meaning that K cannot be a 23, but rather a negative 11. So this is out. Okay, so that is what we would have done for that. Then 1.7, we must get the coordinates of E, whereby E is in the second quadrant such that ABCE is a parallelogram for 2 marks. Now, one thing we know is that whenever they ask us about a parallelogram, ABCE, and we need missing coordinates, the approach to use is going to be the midpoint. Okay, so with the midpoint, we know that the midpoint of this diagonal must be the same as the midpoint of the other diagonal. So for AC, since we say this was a 14 and a 4, 14, negative 14, meaning that the midpoint is at a 0. When you look at 0 and 4 divided by 2, so D is our midpoint. So this midpoint must be shared between B, E, and also A, C. So I'll put my X and Y here, and then apply the midpoint. So we say this was a 12 and 0. Okay, so what we're going to do is this format. Have to flip right and back and so on. So we said B is a 12 and 0. We're looking for our midpoint D is 0 and 2. And then we're looking for the coordinates of E, which is A and B. So let's apply the midpoint formula and say that 12 plus A divided by 2 must give us a 0. Cross multiply, meaning that our A is going to be a negative 12. Then if we get 0 plus B divided by 2 must give us a 2. Our B should be a 4. That's all they needed. And then at 1.8, determine the equation of the line that is perpendicular to AC and passing through this point. So the only thing that we need will be the gradient of AC. Okay, what are the coordinates of AC? Let's see. Okay, we have AC, which is this, and we have the equation, okay? So the gradient of AC is 1 over 7. Okay, so we're saying the gradient of AC is 1 over 7, meaning that the gradient of the perpendicular should be negative 7, because we know that the product of gradients of lines that are perpendicular should give us negative 1. Okay, so if we have this, we have that point, then we can just substitute y minus y1 is equal to m into x minus x1. We simplify that, we shall say y minus 3 is equal to negative 7 into x minus 7. Open that bracket and see. So y is going to be negative 7x. That's going to be a plus 49 plus 3. So it's a negative 7x plus 52. This becomes our final answer. Okay, so that is to do with question number 1, 25 marks, done. We move on to question number 2. Question number 2, they're telling us that the diagram below, in the diagram below, we have a line that is a tangent to the circle. Okay, so I always prefer rewriting this line to something that is easier to work with. Okay, I'll write it as 2x plus 1 because I'm moving the y that side. Okay, so it's a tangent. Then Q, we have M, which is A and B. We have G, which is 2 and 5. And then the center of the circle lies on this other line. X plus y is equal to 9. Okay, then what do they need? They want us to get the gradient of GM. Now we're seeing that GM is perpendicular to this line, but we know that this line is having a gradient of 2. Remember what we said was that M1, like I will say, gradient of GM multiplied by 2 should give us a negative 1. So gradient of GM must be a negative 1/2. I mean, you don't even need that working out for as long as you identify the gradient of the tangent. Okay, so that is done. Then they want the equation of GM. So we have the coordinates. Yes, let's use 2 and 5. Okay, we're using G, which is 2 and 5. So you're going to say y minus 5 is equal to negative a half into x minus 2. Open up as you transpose. So negative a half, that's going to be a plus 1 plus 5. What will this become? It's negative a half x plus 6. There we go. So that is 2.1.2. Then 2.1.3, they want us to get the coordinates of M. We know that M represents the center coordinates, okay? Now, we have the equation of this one. We said negative a half x plus 6. We have the equation of this one, which is x plus y is that, meaning that we need to solve the two simultaneously to determine the x and the y, since the two lines are meeting just at one point. So I'm going to say that from the x plus y is equal to 9. Y is negative a half x plus 6. So where there is y, I'll replace that. Okay, equation 1, equation 2, we can say substitute 1 into 2. So it's going to be x plus negative a half x plus 6 must give us a 9. Let's move the 6 that side. What's 1 minus a half? We're going to get just a half of x. Then 9 minus 6 is a 3. Cross multiply, it means that our x is what? A 6. So if x is a 6, y will definitely be a 3, because x plus y must give us 9. So 6 plus 3 should definitely give us a 9. So since they want the coordinates, we're going to say that M is going to be 6 and 3. All right, then hence or otherwise calculate the length of the radius. So with the radius, we know that we have our coordinates M, 6 and 3. We have G, which is 2 and 5. So let's get the distance, GM. Okay, I'll omit the formula and just say x minus x1, so 6 minus 2 squared plus 3 minus 5 squared. Okay, so when I punch this into the calculator, that's gonna be 4 squared plus plus 4, which gives me 2 root 5. Okay, so the radius is basically 2 root 5 units, since it is a measurement. Then write down the equation of the circle in this form. So we need to start by rewriting the general expression. So x minus a squared plus y minus b squared must give us r squared. So we know that our m was a 6 and what? 6 and 3. So it's going to be x minus 6 squared plus y minus 3 squared, and then is equal to, you said 2 root 5. This is squared. Okay, we open this up. It's going to be x squared minus 12x plus a 36. That's going to be y squared minus 6x plus a 9. It should give us 5 and 4, which is a 20. Okay. Then I'll just regroup into the format they want. So I have my x squared plus y squared minus, I have 12x. We are subtracting, oh Lord, why am I saying x here? It's supposed to be y. You have x, isn't it? So minus 6y. And then we know that 36 plus 9, that's going to be a 45. We subtract 20, it's just going to be a plus 25, should give us 0. So that is what we have to do with 2.1.5. Then 2.2, determine the equation of the inverse of the tangent to this circle at this point. Give your answer in the form of mx plus c. Hey. This question, and then they give us a full page. Our examiners. Okay, let's see. So step number 1. Okay, so we are assuming that there is a circle here. This circle has a tangent, and the tangent is at 7 and 2. So one thing we need to first of all determine the coordinates of the center, get the gradient of the radius. Okay, And then from the gradient of the radius, we can find the equation of the tangent. Then after getting the equation of the tangent, then we can proceed and look for what the question is asking for, which is the inverse. So for us to get the center coordinates, we need to complete the squares there. So it's going to be x. This is minus, né? So minus a half of, why don't I just start by, no, I don't want to lose people. Let's say x squared plus y squared minus 26x plus 12y is equal to negative 105. Let's put it that way. Okay, so with the x, I'll say x minus half of 26 is 13. I'll square that. On this side, I'll have my 105 plus, what is 13 squared? That's 169. Then plus, with the y, I'll say y, this is a plus here. A half of 12 is 6. I square that. But I know that 6 squared is going to be 36. So I'll end up with x minus 13 squared, and then y plus 6 squared is equal to, what is negative 105 plus 169 plus 36? I'm getting 100. Okay, so we know that our center coordinates, let me just call them M for the center, will be 13 and negative 6. Okay, so if it's 13 and negative 6, I have to go ahead and get the gradient. Okay, so the gradient of the radius. So change in y over change in x. So we have this and then 7 and 2. So I'll say 2 minus 6 over 7 minus 13. So that's going to be 8 over negative 6, which becomes 4 over 3, but negative. So that's the gradient of the radius. Then we know that the radius and the tangent are perpendicular. So the gradient of the tangent is going to be a 3 over 4, because negative 4 over 3 times gradient of the tangent must give us negative 1. Okay, so if we have our gradient of the tangent, let's get the equation of the tangent. Okay, equation of the tangent. Remember, we said y minus y1 is equal to m into x minus x1. So I'll say we're still using 7 and 2 as our point of interest. Is that correct? Awesome. So we're going to say 7 minus 2 is equal to 3 over 4 into x minus 7. Let's open up and see. Minus 2 is equal to 3 over 4x minus 21 over 4. Let's move the 2 to that side. So it's going to be 3 over 4x. And I look at this, we have negative 21. 21, not 12, okay? 21 over 4, we are plusing a 2, which means we have negative 13 over 4. So this is the equation of the tangent. But what is the question asking for? Equation of the inverse. Now remember, when you're looking for the equation of the inverse, you just switch. Okay, what is x is y, what is y is x. So meaning this is our x, 3 over 4y minus 13 over 4. Let's move the 13 over 4 that side. So we're going to have x plus 13 over 4 is equivalent to 3 over 4y. Okay, then divide both, or divide through by 3 over 4, or multiply through by 4. So 3y is going to be 4x plus a 13, then divide by 3. So it's 4 over 3x plus a 13 over 3. I mean, why the 7 marks? Guys, it's a lot. Yo. For 7 marks. We move on, guys. So that is question number 2. Question number 3, which is the trig. Okay. So with the trig, they are telling us that tan beta is a 3 over 4. Okay. But beta is between 180 and 270, meaning that we're focusing on quadrant number 3. Okay. 0, 90, 180, and 270. So this is our quadrant of interest. Now, if we have quadrant 3, we know that in this quadrant, tan is positive, but tan is given as the opposite over the adjacent. So our opposite is this, our adjacent is that. But now we're seeing that the 3 and the 4 are both on the negative side of the axis, okay? So if that is O, I can call this a T, and then maybe M. So the first thing I need to do is look for the hypotenuse and say that my OT is going to be negative 3 squared plus negative 4 squared and the square root. The reason, that is the Pythagoras. Okay, so meaning that our OT is just going to be 5 units. So if that's a 5, they want the sine of beta. Sine of beta is opposite of hypotenuse, which is negative 3 over 5. Then we move on. They want us to simplify 2 minus sine to beta. So it's a double angle of sine. It's going to be 2 minus 2. This is sine beta cos beta. Okay. Do we need to factorize? No, we don't need. So it's 2 minus 2 times sine of beta. We said it's a negative 3 over 5. Cos of beta. Okay, cos is adjacent of hypotenuse, so it's negative 4 over 5. Okay, let's try to simplify this and see. So it's a 2 minus, because this minus here and the minus there is going to give us a positive, né? So that's going to be 8 times 3, which is a 24, over 5 times 2, which is a 25. Okay, when I punch this, did they say without a calculator? That's what they said. But it's fine. We can just subtract this. We know that 2 times 25 is 50. Okay, 50 minus 24 is going to be a 26 over 25. But even if you punch this in the calculator, I mean, there will be no harm in that, since we've just simplified all the rest. The essence of not using a calculator is for you to find the size of beta. All right, then 3.1.3, we have cos squared beta. Cos squared of 90 minus beta minus 1. So this just looks otherwise. Okay, what I need to do is take out the negative sign so that I have 1 minus cos squared of 90 minus beta. I know that 1 minus cos squared gives me a sine squared. So I'll be left with sine squared, but of 90 minus beta. Okay, so this is still in the bracket, but now these are complementary angles, okay? So with complementary, if I'm looking for the sine of 90 minus, my result should be a cos, okay? Meaning that our answer is going to be cos squared of just beta. Then I go back to the question and look for the cos. Cos is negative 4 over 5, okay? So negative, we have negative 4 over 5. This is squared. So it's a negative 16 over 25. So that is what I'm getting, guys. Please liberate me if need arises, okay? So we move on to 3.2, evaluate. So whenever a question asks you to evaluate, they just want you to find the value. They want you to simplify that question and find the answer if possible. Okay, so we have negative 1 plus cos 180 minus theta, sine of theta minus 90, and so on and so forth, okay? So with the bottom part, I'm not seeing any problems, okay? But the top part, I feel there's some work to do. Number one, we need to take out the negative here so that it is a 90 minus theta. With this 540, 540 is just a multiple of 180, because if we get 3 180s, then we have the 540. So I'll treat this as a 180 plus. Okay, so negative 1, cos of 180 minus, in second quadrant, cos is negative. So it's going to be negative cos of theta. I'm multiplying it by, since there's this negative, it must come out. So it's going to be negative. Sine of 90 should give us cos of theta. this is all over. Cos of negative is the same as the cos of positive, so that negative has no effect. Then the sine of 90 plus should give us the cos. Okay, we're multiplying it by, we know that 180 plus is quadrant 3. In quadrant 3, tan is positive, so that's going to be tan squared of theta. All right, so let's look at the top part. It's going to be -1. This negative and negative will give us a positive cos squared theta over, this is going to be cos squared theta. We know that tan squared is the same as the sine squared theta over the cos squared theta. Ish, I'm addicted to excess. Oh, okay, so let's simplify that. One thing that I'm seeing on top, I can take out the negative sign, okay? So that I have 1 minus cos squared theta. I'm dividing it by, this is going to cancel that. I have my sine squared theta. So from our identities, I know that 1 minus cos squared must give us sine squared. So it's going to be negative sine squared theta over sine squared theta. Cancel that out. You get a beautiful -1 as your final result. For 7 marks, at least here, they are generous here. I concur with them. I agree, strongly agree. These are the marks that someone deserves. 7 marks. Okay, then 3.3, they want us to prove this identity. Now, whenever we're proving identities, we are advised to always start from a side with more items. And in this case, I believe either side would work perfectly. Okay, so I'm going to start from the left-hand side. So with the left, I need to open this square bracket, meaning that I'll have my sine squared theta minus 2 sine theta cos theta plus cos squared theta using the FOIL, over 1 minus sine squared gives us a cos squared. So I've started collecting some marks from the expanding and then applying the identities. But I know that this and this should give me a 1. Okay, that must give me a 1. So meaning that I have a 1 minus. Do we need to take this double angle? No, it's gonna be a lot of work. So let's leave it the way it is over cos squared theta. Let me split this up. So I have 1 over cos squared theta minus 2 cos theta sine theta over cos squared of theta. So this is already here. We have it. So our problem is just whatever is left. So the 2 is here. Perfect. So 1 cos goes with 1 cos. So we're left with just the sine over cos, which is a tan. Beautiful. So 1 over cos squared theta minus 2 tan of theta is equal to the right-hand side. All right. So that is how we would have also collected those 5 marks. Okay. Question number 4.1. We're given cos of A minus B is given as that. So we're given the compound angle identity. And then they want us to use the above identity to deduce this entire expression. So then the question is, how do we arrive at the sine of A plus B if we have the cos? So one thing we can say is that we need a 90 plus. So we're going to say that the cos, okay, and then I'll have 90 minus our A plus B. So if you simplify this or reduce this using your compound angles, you're going to get a positive sine of A plus B. Then I'm going to detach this A, and I have a cos, let's say, of 90 minus A. Okay, and then I'm going to subtract a B. That's how it is. I'm opening up this bracket. Now, if I treat this as one angle, then I'll have that minus. Then I'll open up this using the rule that I was given. Always use the 90 minus. So that's going to be cos of 90 minus A, and then the sine of B. Then this is going to give us, it's a minus, so we must plus, the sine of 90 minus A, and then the sine of B. Then let's use our complementary angle identities. So cos of 90 minus is giving us the sine of A, and that is the sine of B, plus sine of 90 minus gives us the cos of A, and then the sine of B. So this is what the question just wanted us to do. All right, then 4.1.2, hence or otherwise determine the general, general solution. So we're not looking for definite angles, we just need the solutions, okay? So first things first, I'm seeing a 48 and a 15, a 48 and 15. Let me move this to that other side. So that I have the sine of 2x plus 50 is equivalent to the sine of 48 cos of 15 plus sine of 15 cos of 48, meaning that our sine of 2x plus 15 is equivalent to, this is now a compound angle of sine, which means we have a 48 plus 15 because of that sine. So we know that 48 plus 15 gives us a 63. Okay, this is going to be sine of 63. Now, given the fact that we have just the same trig ratios, okay, on the right and on the left, we can just ignore the ratios and focus on the angles. So with the first angle, it's going to be 2x plus 50 should give us 63 plus 360 times k. And then we simplify this. We need to move the 50 that side. So 2x is going to be a 13 plus 360 times k, then divide through by 2. X becomes 13 over 2, which is a 6.5 degrees. Okay, the degrees, yeah, okay, plus 180 times k. Don't forget k is an element of integers. Now, this is the first quadrant, okay, where sine is positive. Then the second quadrant where sine is positive, we're going to have 180 minus that angle, okay? So 180 minus 63, it's 117, perfect. Meaning that I'm going to have 2x, okay, plus 50 is equal to 117 degrees plus 360 times k. Let's move the 50 that side. Okay, so we're saying 117 minus 50, it's giving me 67 plus 360 times k. Then let's divide through by 2. So x is going to be, what is 67 divided by 2? That's a 33.5. Okay, plus 180 times k. K is an element of integers. So basically, that's all we had to do to get those 4 marks. Then if cos of x plus 30 is equal to negative 2 sine x, can we deduce that the term of x is given as that? Okay, deduce, prove. Okay, so what we're going to do then, let's do the compound angles again, okay? Open up that. So that's going to be cos x, cos of 30, minus the sine of x, sine of 30. This one we can, it's fine, let's leave it that side, negative 2 sine x. Okay, then we need to use our special angles. Okay, so we know that cos of 30 is the same as root 3 over 2. Ne? So you're going to have a root 3 over 2 multiplied by the cos of x minus sine of 30 is a half. Sine of x is equal to negative 2. But why am I doing this? I'm just prolonging things now. Let me move this to that side since they are like terms. So root 3 over 2 cos x is equivalent to minus 2 plus a half, which becomes negative 3 over 2, but sine x. Now, one thing we know is that we have both denominators being 2, so this will cancel that. And then we're going to have, since we need a tan, we need to divide this by cos x and then by cos x. But now, since I want one tan, let me just divide by negative 3. Okay, so that this cancels that. Then I have my tan x here And then this cancels that, then I'll have a root 3 over negative 3. Okay, so that's basically what the question wanted. Okay. Now someone will say, but now it's not in the same form. Remember, this negative 1 over root 3. If you rationalize it, it's root 3 and then root 3. So that's going to be negative root 3 over 3. So this is what the question wanted. So therefore, we're saying tan x is negative 1 over square root of 3. Okay, so that is that. Then 4.3, we're given this expression. They want us to simplify it into a single trig ratio. Okay, so what do we do here? A single trig ratio. What do we see? What do we see? I'm seeing a double angle identity on top, same as at the bottom. Okay, so if I look at 2 multiplied by 2 sine x cos x, I'm going to take out the negative, and then I'll have 1 minus 2 sine squared x. Is that correct? If I'm to follow my, let's look at the formula page, which I hardly use anyway. So it's saying it's 1 minus 2 sine. Okay. 1 minus 2 sine. Where are we? We are here. So it must be 1 minus 2 sine. Okay. So that's going to be our first part. So it's going to be 2 multiplied by the sine of 2x over, it's going to be negative. This is going to be a cos of 2x. Simplifying that, we're going to end up with just negative 2, but tan x. Okay. And then for which values of x, okay, in the interval between negative 90 and the 90, will the above expression be undefined? So it's a two-way thing, okay? You can look at this bottom part, which is the cos 2x. Where do we find cos 2x to be undefined? Okay, so if I'm looking at a 90, we know that the cos of 90 gives us a 0. So meaning that it's not going to make sense. Let's see the cos of 180. It's going to be negative 1. So let me focus on the tan. So if I have a graph of tan, okay, this graph, if it is to be drawn, when x is negative 90, the graph is going to be undefined, okay? And then when x is a 90, the graph is also undefined. In other words, it will not touch those points. Those points will be basically asymptotes. Now they're asking us for which values of x within this interval. Now, the fact that we're focusing on intervals that are not inclusive, we can just draw a conclusion that no values of x. That's what I'm thinking, because it is only undefined at this and that. But when you talk of the intervals in between, then there are no values. There are no values at all. Okay, then 4.3.3, without using a calculator, simplify this. These questions. But this one looks more or less the same as what we just dealt with. So it's going to be 2 multiplied by 2 sine 15 cos 15 over negative, we said 1 minus 2 sine squared 15. Okay, so we said this is going to be 2, but I was supposed to use the tan directly. Oops, okay. So let's say 2, this is going to be sine of what? Sine of 30 over, this is going to be cos of 30. It was supposed to be just a direct part, whereby we just substitute into this 2 negative 2 tan something. Okay, so that's a negative. So we know that the tan of 30 is opposite, which is 1, over the adjacent, which is a root 3. So meaning that our answer should be a root negative 2 over root 3. Okay, so that is what we would have obtained for 2 marks. Then question number 5, which is the trig functions. Okay. So with the trig functions, they're asking in the diagram below, the graphs f of x are that, g of x is that. Now pay attention to the brackets. There are brackets here, there are no brackets there. Okay. Then they're asking us, okay, we have the turning points and they're telling us that A is the x-intercept of f, which is 6, 10, 0. Okay, makes sense. Can we determine the values of m and n? Now with m, okay, so this m is just a shift. A normal course graph must be passing at 1 for as long as the amplitude is 1, must be passing here. But now there's a drop by a half to down. So meaning that our m is going to be negative a half, or someone can say negative 0.5. And then with the n, we know that a normal sine graph, which is the g, must be passing through the origin here. But then in this case, it's not happening. There's a 30-degree gap in between, okay? So meaning that this graph was shifted 30 degrees to the right, ne? 30 degrees, is it to the right or to the left? To the left, 30 degrees to the left, meaning that our n is going to be a positive 30. Okay, so if that is true, then they want us to write the amplitude of f. So with f, remember for us to get the amplitude, we can just get it from the graph itself. What is the coefficient? Of course, it's just a 1. Okay, so the amplitude is a 1. Alternatively, get the maximum minus the minimum divided by 2. So our maximum is 0.5. Our minimum is negative 1.5. Okay, divide by 2, you're still going to get a 1. Okay, then 5.3. If h of x is the same as g2 of x, can we write down the period? Now, initially, okay, when you look at the g of x, this x is having a coefficient of 1. Now we are introducing a 2. So this 2 will affect the period. So initially the period was 360, but now it's going to be 360 divided by 2, which becomes 180. Okay, then 5.4, for which values of x will f of x, g of x be less or equal to 0? So two scenarios, positive, negative, negative, positive. So one graph should be above while the other one is below. So let's start with the G. G is above while F is below, around this area. Okay, around this area. This one is above while the other one is basically below. So in that case, our interest will be the 60 and this value here, which is 150. Okay, is there a scenario whereby F is above and G is below? F is above, G is below, but it is on the left-hand side, which is not part of the solution set of interest. So what we're going to say here is that 60 degrees should be less or equal to x, less or equal to 150 degrees for 2 marks. Then 5.5, describe the transformation Z. Okay, so it's more than one transformation that is taking place. For the graph to undergo to form P of X, which is this. So it's G that we are playing around with. Initially, it was the sine of X plus 13. Now, step number 1, how do we change this graph into a cos? That should be the first transformation. So number 1, we need to plus a 60 here so that it is a 90 plus X. If that is true, then we're going to get our cos what? Our cos X. Now, if that is happening, we're shifting the graph 60 units or 60 degrees to the left. Okay, then after getting our cos of X, then we can flip it around. We reflect it around the x-axis. Then we have the negative aspect of it. So number 1, we're going to shift the graph 60 degrees to the left, and then reflect it about the x-axis. So those are the two transformations that they wanted. We move on to question number 6, which is the application of the trig or the 2D trig. In the diagram below, ABD is a horizontal plane, okay? We have a vertical pole, the angle of elevation, A to the top, is equal to X. And then this angle is 2X, that's a 90, and then those two sides are equal. Can we prove? How many marks is 6 marks? Okay, it's what? It's what? Okay, so step number 1. Since our focus is AD, which means the triangle of interest is this one. We know that this is the same as that. So we need to find what AB is. So let's start by expressing AB in terms of H and X. So we can use tan and say that the tan of X is going to be the opposite over AB, meaning that our AB is going to be H over the tan of X. Okay, so that is equation number 1. Then we can use the second triangle to say that the angle DAB is also the same as DBA, which is going to be, reason is going to be angles opposite equal sides. So for me to get that, I'll get my 180 minus 2x divided by 2, which is just a 90 minus x. Okay, so this is a 90 minus x. This is also 90 minus x. Then let me use the sine rule. So the sine rule is going to be AB over the sine of 2x is equivalent to AD that I need over the sine of 90 minus x. So let's make AD the subject. So AD is going to be AB, the sine of 90 minus x divided by the sine of 2x. Okay, let me just simplify this. So we have our AB as h over tan x. Okay, so that's going to be h over tan x. This sine of 90 minus is going to be a cos x. Let's split the sine 2x, which is going to be 2 sine x cos x. Then let's cancel what needs to be cancelled. So this cos cancels the cos, and then that's what we have. So it's going to be h over 2 sine x, and then the tan of x. So that is our AD. Isn't that what the question wanted? 2 sine x, tan x. Perfect. Question number 7. 7.1, PQRS and T. All of them are lying on a circle with center O. PR is perpendicular to OQ. And then these two lines intersect F. Port is a straight line. P1 is a 42. Must give reasons for R1. So what is R1? So this is a 90 because this is a diameter. Ne? So you're going to say that our R1 is a 90 angle in a semicircle. Angle in a semicircle. All right, so if that's a 90, we need to look for S. Where is S? S is here. So I can look at PRST as a cyclic quad. So meaning that our S is going to be 180 minus a 42. So 180 minus 42 gives me 132. The reason is going to be the opposite angles of a cyclic quadrilateral. Okay, so opposite angles of a cyclic quad. Okay, so having obtained the 138 here, are we going to need it? Not really. Just answer the question. Okay, then we need to move on to the next one. We need to find PQR. So they're saying P, Q, and R. This entire angle down here. So what we need to do there, we need to start by looking at PQRT as a cyclic quad of its own as well. So in that case, I need to find the angle T2. So how do I get T2? Focus on this triangle here and then get the T2. So I'm going to say that T2 is going to be a 90 minus 42, which gives me a 40, I think it's a 48. No? Yeah, T2 is a 48. Reason angles in a triangle, or remaining angle of that triangle. So if that's a 48, meaning that our PQR is going to be 180 minus 48, which becomes a 132. Reason, opposite angles of a cyclic quad. Okay, we have plenty of cyclic quads there. Then if PR is a 7 and QR is a 4, you need us to find QF. If PR, okay, meaning that from here up to here is a 7, and then this is a 4. So if this is a 90, we know that this is also a 90. But now we need to start by saying that RF is the same as PF, which is going to be like 3,5, a half of 7. So 3,5, 3,5. Reason, line from a center or the perpendicular bisector of a chord from a center must bisect the chord. Then we can focus on the theorem of Pythagoras there and then look for our QF. So we're going to say that QF is going to be the QR squared, okay, minus the FR squared. So that is 4 squared minus 3,5 squared. Oh, must be under square root. Ne? So when I put that under the square root sign, what am I getting? 1,94 units, because I got root 15 over 2. I don't know if that makes sense. Root 15 over 2, which is 1,94. Okay, so that is to do with that question. Then we move on to 7.2. By telling us the diagram below, B, D, and C lie on the circle with center O. AB, AD, they are tangent to the circle at B and D respectively. We have a 59. Wow. They want us to get B1. So before we get the B1, we need to remember that if these are tangents from a common point, these tangents are going to be equal to each other. And if they're equal, this angle B1 must be the same as D1 because that's an isosceles triangle. So we're going to say that B1 is equal to D1. Angles opposite, equal sides. Ne? Then we're going to say 180 minus 59. 180 minus 59 gives us 121. Divide this by 2, we get a 60,5. So that is what the question wanted. But now for 4 marks, someone can still say that AD is equal to AB. Okay, AB is equal to AD. Tangents from a common point. Tangents from a common point. And then we can write that down. I think we are good to go. All right, then they want us to get O1. O1. So he's saying this is a 60,5. That's a 60,5. They want us to find this O1. So I know if that's a 60,5, even C is going to be a 60,5 because that is a tan chord. So I'll start by saying that C is a 60,5 is because of the tan chord theorem. Okay, if that is true, we know that O1 is the angle at the center and then C is the angle at the circumference. So O1 is going to be twice of C, which is 2 times 60,5, which gives us 121. Reason, angle at the center must be twice angle at the circumference. Forgive my handwriting. Forgive my handwriting. Okay, so that is that. Then we move on to question number 8. In the diagram below, A, B, C are points on the circle with center O. They want us to prove the angle at the center theorem. Okay, how many marks is this? 5 marks. Not bad. So step number 1, okay, you construct. Okay, please do your construction neatly and nicely. T. So you can tell us that construct the line BT or extend the line B2, no problem. Then label this as 1 and 2. This is 1 and 2 as well. Then you're going to start with, let's say, triangle. I'm saying from OBC. I know that O2, this angle here, is going to be B2 plus this angle C. Reason, those are exterior angles of a triangle. But we know that B2 is the same as C. Angles opposite equal sides, né? Because this is a radius and that's also a radius. So those two must be equal, meaning that our O2 is going to be twice of B2. Call that equation number 1. We move on to the triangle. So it's saying from triangle BOA or AOB, we can say that O1 is going to be, let me not do that. Stop being too forward. Say B1 plus A, exterior angles. And then we're saying that B1 is the same as A, angles opposite, equal sides, okay? So meaning that our O1 is twice of B1. Call this equation number 2. Then you need to plus the 2. O1 plus O2 is going to be the same as twice B1 plus twice B2. But O1 and O2 is the same as AOC is equal to twice B1 plus B2. Therefore, AOC is the same as twice B. All right, so that is what was meant to be done for those 5 marks. Then question 8.2 in the diagram below, BC. Where is the BC? This one is parallel to this line. C3 is X, this is our X, and then these ones are other lines that are drawn. You can't just say other lines that are drawn. Be specific. They look like tangents as much as they say other lines are drawn. Anyway, the fact that they are coming from one common point and they are touching the circle at one point, I'm going to presume that these are tangents. Okay, because the question seems vague if they just say lines are drawn and then they look like tangents. Okay, so what I can do to get the 4 angles of interest, I can see that, remember, I'm assuming that these are tangents, né? So this angle is going to be the same as this angle B. So B is X, and I'm saying is the tan chord. Okay, so if that is X, it simply means that even F2 is going to be X. The reason being, those are corresponding angles because FD is parallel to BC. We have two to go. If this is X, meaning that E is also going to be X, this one. Reason it can be a tan chord, okay? Or we can use the bow tie, angles in the same segment. So is X, we're saying it's a tan chord, or angles in the same segment. Remember, you can just use one reason. Then if that is true, that this is X, then we have A3 to also be X. Angles opposite, equal sides. Why are they opposite equal sides? Remember, this is a tangent, this is also a tangent from a common point, so they have to be equal, and if that's X, this must also be X. All right. Or you can use the tan chord using this and that, no problem. Then can we prove that AFCD is a cyclic chord? So with this, we don't have any angles that are dealing with numbers, so we need to focus on the properties. AFCD. So AFCD. So what we can see is that this is forming our bow tie again. Okay, so this angle is the same as that. That's enough. We draw the conclusion. So it's saying F2, okay, is the same as C3. Therefore, AFCD is a cyclic chord. Reason is going to be the converse of angles in the same segment. Okay, that's one other proof for the cyclic quadrilaterals. Then 8.3, in the diagram below, AC is a diameter, The circle with O as a center, AC is produced to P. B1 and B2 is 127, P16. Can we prove that BP is a tangent? So for us to get BP as a tangent, okay, we just need to make sure that our B2 is the same as A. That is the trick of this question. If we can prove that B2 and A are just the same, we are good to go. Okay, so I'll start by looking at the big triangle and find the size of A. Okay, so I'll say that my A plus 127 plus 16 must give us 180 degrees. Those are angles in a triangle. Then now A is going to be 180 minus, what's 127 plus 16? That's 143. Okay, so 180 minus 143 gives me a 37. So this is a 37. So if A is 37, I need to say that B1 is a 90. Okay, angle in a semicircle. Then for us to get the B2, it's going to be 127 minus 90, which is also a 37. And then we're going to say that since A is the same as B2, therefore BP is a tangent. The reason is going to be the converse of the tan chord. All right, so that is that with question 8. Question 9, remember the paper had 9 questions, eh? So this is question 9, the last one. The diagram below, PQ is the same as QR, same as RS, but VR is parallel to TS. So let's determine the value of TV over VP. So one thing we need to know is that TV over VP is going to be the same as RS over RP. So if this was X, okay, just assuming that was X, this simply means that our TV over VP is going to be RS, which is 1X, over RP, which is like 2Xs, meaning that that is going to be a half. That's what I'm getting. Then for the next one, determine the value of the area of that. So we're looking for the areas. Now with this, I'll say that the area of PQV, okay, PQ and V. Now I'm also looking at the area of PST, P, S, and T. So let me assume that that is my height or my base and so on and so forth. How are we going to deal with this? Okay, so it's a PQV and a PST. Okay, so I'll say a half multiplied by my base, multiplied by the height over half a base and also the height. So the only thing that is changing will be the bases, that our PQV is just X, then same height. And then this other one is going to be 3Xs, then the height is that. Is that really for 5 marks? Okay. So half cancels a half, the H cancels H, and then I'm just going to be left with a third. I'm not so confident with my answer there. Okay, but we move on. Question 9.2. In the diagram below, B, C, D are points on the circle. ADC is a straight line. AD is a tangent. Can we prove that the two triangles are similar? Okay, so for us to prove similarity, one thing we know is that this angle here, B1, is the same as this angle C. That's a tan chord, okay? But we know that A is the same as A, which is common, okay? Meaning that our D1 should be the same as B1 plus B2. That is basically the remaining angle of a triangle, remaining angles of a triangle. So if we have the three statements, therefore, CBA is similar to BDA. Angle, angle, and angle. Okay, so that is done. Then 9.2.2, they want us to prove this. Now, I'll just start by kind of sketching. I'm sorry, but I love sketching. So if this is our small triangle, which is A, we're saying a B1 and then a D1. And then we have our big triangle, which is A together with a B and then a C. And what about the size? Ne? Sometimes the size is misleading. Just want to see which sides or which angles are in proportion. Okay, so meaning that if I have this AB over the AC, it should give me the same as AD over the AB, which must also give me the BD over the BC. But with our question, we don't have BC, we don't have BD. So I'm going to cross that out and just focus on these two. Okay, so I'll start by writing this statement and then I'll give the reason that our CB, it was a CB what? It was CBA. CBA being similar to CBA being similar to BDA. Okay, then let me cross multiply. So I'll have my AB squared is equal to AC multiplied by AD. But the question still doesn't have AC, okay? But when we look at the big triangle, we're saying that this AC is a combination of the two. So AC is AD plus DC. So I'm going to replace AC with that. Okay, so it's gonna be AB squared is equal to, I'll say AD into, we said AC is going to be AD plus DC. Open that up. So ABC squared is going to be AD squared plus our AD times the DC. Let's move this one that side. So AB squared minus the AD squared should give us the AD times the DC. Isn't that what the question wanted? AD DC should be equivalent to AB squared minus AD squared. Perfect. So this is what the question wanted. And that is where we stop. Additional space, we don't need it. All right, guys, thank you very much for listening and watching. Please, if any issues, please, you can slot them in the comment section. If you've not subscribed, please go ahead and subscribe, like, share, comment, and we appreciate your feedback that you give. Proposed memorandum for mathematics paper 2. Grade 12 for November 2024. All right, so paper is 3 hours, 150. The instructions, we have 11 questions. We're going to use a special answer book. Answers only will not be awarded marks, so we shall break down that calculator. If necessary, we must round off our answers to 2 decimal places unless stated otherwise. Okay. All right, then question number 1, which is always the statistics, are telling us that at the beginning of a season, the coach of the junior boys rugby team recorded the weight in kilograms of the 15 players, okay, in his team, and then the number of push-ups that each one was able to do in just 1 minute. Okay. The data is represented in the table and then the scatter plot below. The least square regression has been drawn for us. All right, so we can see that the weight is in kilograms, good. And the number of push-ups will be the Y. We have all those details. Then 1.1, they're asking us to determine the equation of the least square regression line for the data. So we know that that equation is given as y is equal to a plus bx. Some people would choose to write it as a plus capital B x. It does not matter. All we need to do is use our calculators and look for the mode of the two var. Okay, and then punch in these values. So having done that, the answers or the values that I obtained for A was, let me put it aside in the answer book. So it's saying that A is 39,456, which I'll maybe round off to 46. Okay. And then my B is a negative 0.59 if I round it off to 2 decimals. Okay, then this is number of push. Okay. So which means our equation will be 39,46 minus 0.59x. So a mark for A, a mark for B, and then a mark for the equation. Then 1.2, they want us to write the correlation coefficient. So that is the value of R. So from my calculator, when I punch that, I'm getting negative 0.799 something, which I round off to negative 0.80, or just negative 0.8, okay? Then 1.3, they're telling us that the coach uses the least square regression line to set the target for the minimum number of push-ups by each team member according to their weight. Can we predict the number of push-ups that the member of the team who weighs 29 kilograms should do to meet the target? So we've been given the weight, and the weight is representing the X. So we must look for the Y using the regression equation. So Y is going to be 39,46 minus 0.59. We are multiplying this by 29. Okay. So when I punch that into my calculator, that's 39,46 minus 0.59 times 29. That is giving me 22,35. We can just round off this. Maybe someone must do 23 push-ups. Okay, since push-ups are just a countable quantity and not necessarily measurable. All right, then 1.4, they want us to get the mean number of push-ups for the given data. Mean number of push-ups, which means we're looking at the Y values, okay? So we know that for us to get the mean, we shall just add that, and then the answer we get, we divide it by 15, or you can just directly punch that into your calculator. So I'll say the mean for the push-ups, which is X bar, will be the summation, which is 537 divided by 15. This is giving me 35,8. If you round that off, you'll get to 36 push-ups, okay? Then 1.5. The players trained hard during the session. At the end of the session, the coach reported that each player was able to do 5 extra push-ups. Okay, each player, in other words, all the players had something to be added, which was the same per minute than they did at the beginning of the session. How does the increase in the number of push-ups influence the standard deviation for 1 mark? So in normal cases, for as long as there's an addition or subtraction that is uniformly done across the data pieces, it does not affect the standard deviation, okay? It will only affect the mean. So we can say that SD is not affected, okay? Or we can alternatively say that SD remains the same. It remains the same. So that is for standard deviation. Had it been that it was the mean, then the mean was going to increase by 5. All right, then now 1.6. At the beginning of the season, the coach used the least square regression line as a minimum target for a player to aim for. Okay. In other words, there was a target that was set that for every player that is what you must reach. Determine the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target. Okay. So what we're going to do in this case, okay, so initially in 1.4, we saw that the mean or the average that we're looking at was a 35,8 push-ups, okay? But then from our regression line, if we are to look at the y-intercept of this graph, remember from our equation, we found it to be a 39, or something, okay? So y-intercept, okay, we're saying the y-intercept is a 39,46. But then currently the average is a 35,8. What is the question asking for? Question is asking to determine the maximum possible increase in the number of push-ups. So for us to get a target of 39,46, how many extras can we add? So I'm just going to say 39,46 minus 35,8. Okay, 39,46 minus 35,8. That gives me around about 3,66, which is approximately 4 push-ups that must be increased, or that will be the increase for them to get the target from the mean or the average. All right, so that is what I would have done with question number 1. Okay. Then question number 2, we are given the frequency graph, the cumulative frequency graph, the ogive, and then we need to answer questions. Okay, so number 1, they want us to estimate the mean. So remember, we are estimating. So our answers might be slightly different by just decimals or just a few numbers. So for us to get the median, what we need to do, there is that formula that we normally use to say that Q2 will be a half of n plus 1. That is, if we are looking for the position. Okay. Then if we do the substitution, we know that our n is 60, because the question told us that we're dealing with 60 employees, okay, that travel to work each morning. So that's going to be a half of 61, which gives me 30,5. So that is just the position. But now the Q2 value from the ogive will be, let me see, 30,5 is round about that point. When I drop it down, I'm getting something like within this line. So if that is 10, which means each block is 2, so that is going to be like 66 minutes. Okay. There are people that might use a half of 60, which is a 30, and the 30 will give you something like a 65. Okay, so I'll go with 66. 65, they might give you also. Then estimate the lower quartile, that is the Q1. So with the Q1, we know that it's going to be a quarter of n plus 1. So that will be a quarter of 60 plus 1, which is 61. And that gives me 15,25 as the position, which means the Q1 value, if it is 15,25, the answer I'm getting is a 44. 15, something. Yeah, it's somewhere there. Because I'm taking it from here, just slightly above 15, or just within the line of 15. So we're getting 44. If you're using just a quarter of 60, which will be exactly on 15, that might give you something like a 43, okay? And then 2.3. 2.3, they want us to get the interquartile range. So we know that interquartile range is given as the Q3. We subtract the Q1. We already have the Q1. What is shorting is the Q3. Let's get the position of Q3, which is 3 over 4 into n plus 1, which is 3 over 4 of 61. That gives me 47,75, okay? So from our graph, 40, did I say 47 or 45? 45,75, yes. So 45,75 is just more like close to 46. And we can have that value at this point. Okay, it can be between 80, it's 8 what? Remember, it's a 45, not yet a 46, so slightly below, which is somewhere there like 80, is it 86, 85? My graph is not. Okay, so if I look at 45,75, which is more like 46, round about that value, I'm getting 84 as my Q3, okay? So which means my Q3 is going to be 84. Then when I get the IQR, I'm answering the question now, it's gonna be 84 minus a 44, which gives me a 40. 84 minus 44, it's giving me a 40. So that is how I would have gone about with that question, 2.3. And then 2.4. 2.4, they're asking us, or they're telling us that the minimum and the maximum times taken for an employee to travel to work are 5 and 120 minutes, respectively. So on a scaled line, the answer book, can we draw a box and whisker diagram for the data, okay? So one thing we know about the box and whisker, it represents the 5-number summary, whereby we shall have the minimum, the Q1, the Q2, the Q3, as well as the maximum. So our minimum, they told us is a 5. So that will be our 5. Our maximum is going to be 120. We say that the Q1 is 44. So 44 is just slightly before that middle line. And then our Q2, we got it as 66. So slightly after that line. And then the Q3, we're seeing 84, which is slightly before that line of 85. And then just draw your box with your ruler. Okay, connect that. Connect this to the end, and then connect this to the start. So that becomes our box and whisker plot, something like that. Okay, so then 2.5, they're telling us that the company manager decided that all employees who travel for an hour or more will be allowed to work from home for part of the day. What percentage of employees will be allowed to work from home for part of the day? Okay, so when they talk about an hour, so that's basically 60 minutes. So we want to see how many employees are using more than an hour to get to work. Okay, so 60 minutes, we have this line. Follow that line of 60 up until it meets the ogive, and then we take the reading from this side. So that should be around about 26, okay, around about 26. So we know that at 60, we have the cumulative frequency of 26. So the employees that traveled more than 60 minutes will be 60 minus 26, because we remember we're looking at a total of 60 employees. So 60 minus 26, that is a 30 what? It is a 34. Then 2.6, employees will work 8 hours in a normal working day. The manager decided on the following rule for time to work from home. Okay, so an employee is allowed to work half an hour from home for each interval of 20 minutes or part thereof above an hour taken to travel. So for people that are using more than 60 minutes to travel, okay, from 60 upwards, they will be given half an hour to work from home for every interval, which means that from 60 to 80, you'll have half an hour. From 80 to 100, that's half an hour. From 100 to 120, that's also another half an hour. Then the question is asking us that on a certain day, there's an employee that takes 110 minutes to travel to work. Calculate the number of minutes that this employee will be allowed to work from home on that particular day. So 110 falls within this category of 100 to 120, okay? The section of thereof, part thereof, simply means even if it's not a full 20 minutes, but just part of the 20 minutes, you still qualify for the half an hour. So how many hours or how many minutes? So we're going to say we have half an hour, which is like 30 minutes. That's another 30, and then that is also going to be another 30. So we can say we have 30 times 3, which gives us 90 minutes. Okay, so that is question number 2. Question 3. Question 3. Did we answer question 2.5? Something is not making sure. 2.5, we're saying what percentage are allowed to work from home. We just got the number. Okay, so it's going to be 34 over 60 times 100, which is 56.67%. Okay, let's move on to question 3. They're telling us that on the diagram below, ACD has vertices A, we have D, C, where A is the point in the second quadrant. And then they're telling us that B is -1 and K, which lies on the side of DC. 3.1, they want us to get the gradient of CD or DC. Let me put it aside. So we know that gradient is change in Y over the change in X. So I'll say 0 minus 9 over -9 minus 3. That will give me 9 over -12, which is going to be -3 over 4. So that is the gradient of DC. Then 3.2, I want us to get the equation of DC. So I can use point C and say that Y minus 0 is equal to -3 over 4 into X minus -9. So Y is going to be -3 over 4X. That's going to be a plus, and then now a minus 27 over 4. That's 3.2. And then 3.3, they want us to show that K is -6. So since we already have the equation, all we can do is just do the substitution, okay? Where there is X, we put a -1 into this equation, and then we solve. So which means Y is going to be -3 over 4 times -1 minus 27 over 4. So that gives us 3 over 4 minus 27 over 4. That's going to be -24 over 4, which is a -6. All right, then 3.4. Can we calculate the length DC? So with DC, we have to use the distance formula, okay? So that will be X minus X1 squared, then Y minus Y1 squared. If you do your substitutions, that's going to be -9 minus 3 squared plus 0 minus -9 squared. This must be under the root sign. So when I punch that into my calculator, okay, -9, and then that is a 12, I'm ending up with 15 units, okay? So that is 15 units. All right, then 3.5, they want us to get the ratio of dB over dC. So what we're going to do, since they're talking about the ratio, dB simply represents the length, okay? But we know that that's a -1, this is a -6. So let's use, again, the distance formula to find the distance dB, okay? So dB is going to be the square root. Okay, from the distance formula, we shall have 3 minus -1 squared plus -9 minus -6 squared. So when I punch that into the calculator, that's gonna give me a 5, okay? And then for me to represent the units, gonna be 5 units over 15 units, which is just 1/3. So that becomes the ratio. Then 3.6, M is a point on AD such that AC is parallel to MB. Calculate the ratio of area of MBD over the area of ACD. Now, if I'm to just imagine of a line, something like that, if that is our imaginary line, and maybe this is our point M, okay? So for us to get the area, okay, let me just put it this side. Okay, so it's saying this is our line. We say this is a 5. All of that is 15. This is a point M. So that these lines are parallel. So if we have that, then we shall have similar triangles, okay? So if we have similar triangles, I can create a 90 or a perpendicular height. So if let's say I have this as my perpendicular height. So for me to get the area of MDB, it's going to be a half multiplied by this height that I created, multiplied by the base, which is BD. Then if I look for the area of the big triangle, which is ACD, which means I'm going to use the same height for this case, okay? Which is a half times the entire distance, which is our base, which is DC, multiplied by the same height. So if I'm to compare the two, which means I'll have a half times DC times H. So a half and a half will cancel, the H and the H will cancel, which means I'll be left with just a BD over a DC. So my BD is 5, that is 15, which means the ratio of the area will also be in that format, 1/3. All right, so that is 3.6. Then 3.7, they're telling us that if it is further given that AD or the gradient of AD is -4. Okay, so here we have the gradient as -4. Then the distance or the length of AD is 612. Okay, AD is 612. What do they want us to do? We need to find the coordinates of A. Okay. So our point of M is not going to be of relevance, okay? Because all we need to know is we need A, which I'm just going to name as X and Y. We already have the coordinates of D, which are 3 and -9. Okay, so our gradient is -4, and then our distance is square root of, they said 6 what? So 612. Okay. How many marks is it? It's 6 marks. Okay, so I'm going to use the gradient formula. And then I'm also going to use the distance formula in both scenarios, and then I'll solve the equations simultaneously. So let's start with the gradient formula. So we know that the gradient of AD is going to be the change in Y over change in X. So that's going to be y minus 9 over x minus 3. This must give us -4. You can cross multiply. So y plus 9 is going to be -4 into x minus 3. We open that up, -4x. That's going to be a plus 12. Let's move the 9 that side. So -4x plus a 3. Let me call that equation number 1. Then I look at the distance formula and say that my AD is going to be the square root of x minus x1 squared, and then y minus y1 squared. So root 612 is equal to the square root of x minus 3 squared plus y minus 9 squared. Now, since we have root signs on either sides, I can square both sides. Okay, so I have 612 is equal to, that's going to be x squared. I'm opening the brackets, 6x plus 9. That's going to be y squared. Remember, this is now a plus. So plus 18y, and then plus 81. But remember our y, okay, if this is equation number 2, let's substitute this y into this equation. So 612 is equal to x squared minus 6x. This and this is going to give us a 90. We have -4x plus 3. We're squaring that. Plus 18 to -4x plus 3. We said plus a 19. Let's move everything to one side as we simplify. So x squared minus 6x, opening this up, I'll have 16x squared. This is 12 times 2. I'm going to get 24x. Okay. After getting the 24x, I'll have a plus 9. Open that up. I have -72x. 18 and 3 is going to give me a positive 54. And then plus 90. And then I'm subtracting 612. Should give me a 0. So I know that x squared and that, I'll get 17x squared. Minus 6 minus that, that's minus 30. And then if I subtract that, I have minus 102x. Okay. Then the 9, the 54, the 90, and the 612, I'm just getting a positive 459 is equal to 0. Then all I'll do is divide through by 17, okay? That will give me x squared minus 6x minus 27 is equal to 0. I'll factor this out. So I will use the quadratic formula. So x and x, let me make this a 9, a 3. I'll make this a negative and a positive. Okay. So which means our x can be -3 or x is going to be a 9. But since the a, okay, is in the second quadrant, which means the x is going to be -3. Okay. So which means the y values in this case, we substitute into that equation was -4x plus 3. So -4 and then -3 plus 3, that is going to give us what? Because this is going to be 12 and then 3, which is 15, which means the coordinates of A are -3 and then 15. So that is how this question was meant to be approached. All right, that is question number 3. Question 4. In the diagram, M is 1, 3, is the center of the circle. Okay. And then the circle cuts the x-axis at N, we can see that. And then ST is given as a tangent to the circle, with P being that R is DN1, where D is greater than 0, which means it's positive. L lies on the circle. O and V are x-intercepts. O and V are x-intercepts. PL and RL, okay, those ones are drawn, okay. And they want us to get the coordinates of L. the quickest approach to use in this case was the midpoint method, because we know that this M is the center, which is the midpoint of this and this. So we know that if we have x1 and x2 divided by 2, and then we have y1 plus y2 divided by 2, this is the midpoint formula. So if I get x, okay, we're saying L is x and y. So x plus the 3 divided by 2, I should get my x value, which is a 1. Cross multiply, x plus 3 should be a 2, which means x is a negative 1. I'll do the same with the y and say that if I have y plus 9 divided by 2, I must get a 3. Cross multiply, y plus 9 is going to give me a 6, which means y is negative 3. So coordinates of L are negative 1 and negative 3. So it's in the fourth quadrant there. Sorry, the third quadrant. Then 4.2, they want us to get the equation of the tangent, ST. So for us to get the equation of this tangent, we know the coordinates of M, we know the coordinates of P. And we know that the tangent and the radius, or tangent and diameter, will be perpendicular. Okay, which means that ST is perpendicular to PL. This is tan radius, or tan perpendicular to diameter. So if we get the gradient of PM, okay, we say change in y over change in x. So that's going to be 9 minus 3 over 3 minus 1. So 6 over 2, which gives us a 3. Then which means that the gradient of the tangent, remember for perpendicular lines, M1 times M2 must give us negative 1. Now we already have our M1 as a 3, which means M2 is going to be negative a third. So this is the gradient of the tangent. So the equation, I'm going to say using P, okay, using P, y minus 9 is equal to negative 1 over 3 into x minus 3. Let's open that up. Y minus 9 is negative a third plus 1. When I move this 9 to that side, which means it's negative a third x plus 10. So that is the equation of the tangent that I'm getting for 4.2. All right, then 4.3, can we show that this equation of the circle is given as this? So we have the equation, we just have to move towards that. So we have the center coordinates, which is beautiful. What is shorting is just the radius. So let's calculate the radius. So PM, the distance PM, this is 4.3. Okay, so PM, remember, we have 1 and 3. Then we have 3 and 9. All right, so I will say R squared is going to be 3 minus 1 squared plus 9 minus 3 squared. So that is going to be 2 squared, which is a 4, plus 6 squared, which is a 36, which gives me 40. So my R squared is a 40. Then we know that for equation of a line, so a circle is given as x minus that, y minus that is equal to R squared, which is x minus 1 squared, and then y minus 3 squared. Our R squared is a 40. If you found the square root there, you can square it again and get back that. Let's open this up. That's going to be x squared minus 2x plus 1. Open this up. It's y squared minus 6y plus 9. Let's move the 40 that side. Minus 40 is 0. So we have x squared plus y squared. We have the minus 2x. Why am I saying 26? We said 2x. Okay. Minus 6y. This and this is a 10. Minus 40 plus 10 is giving me minus 30 is equal to 0. All right, so that is how we would have proved this equation. Then 4.4, can we show that D is a 7? Where is D? D is on point R, okay? So what we can do, we can use the equation of a circle since D is lying on the circle, okay? Where there is Y, let's put 1, and then let's look for X. x. Would that be the easiest and quickest? I guess so. That is one approach, if we can use the equation of the circle. Alternatively, we can, we know that this is a diameter, which means the angle here will be 90. We have these coordinates, so we can try the gradient. Gradient of this times gradient of that must give us -1. Let's see if we shall get the same answers. So substitute y as a 1. So we shall have x squared plus 1 squared minus 2x minus 6 and 1 minus 30 is a 0. Collect the like terms, x squared minus 2x. This is going to be minus 36 plus 1, which is minus 35 is 0. Vector this out. That is x and a 7, x and a 5. Make this a minus and a plus. So x is either 7 or x is going to be a -5. But we're looking at d on the positive axis. Therefore, d is going to be a 7. For people that were using the gradient, how are we going to go about that? Let's use something else here. Okay. So we're saying 1 minus -3 over d minus -1 multiplied by 9 minus 1 over 3 minus d should give us -1. So that will be 4 over d minus 1. You're multiplying it by 8 over 3 minus d should give us a -1. So this is anyway going to give us also a quadratic, which must take us around about that. But substitution was going to be the quickest. Okay. Was going to be the quickest. All right. Then 4.5. 4.5, they want us to calculate the size of L for 5 marks. All right. So what I'm going to do here. Okay. What I'm going to do. I need to know, 1, the gradient of this line, which we got as a 3. Okay, that is the gradient. Then if I can get this angle of inclination, okay, I already know that this is my 90. I need to find this angle here, P. And how am I going to do that? I need to locate the angle of inclination of this line also. So I'm just going to extend this and call this maybe a point Q. Let me find this inclination angle. Okay, then I focus on P.2. Will that make sense? So that I know that this angle is going to be a sum of this angle and this angle here from this triangle that I'm calling pink. Okay, let's start with triangle pink. All right, so let me call this, no, I don't need to call it theta or what. Let me just call it P.O.X. Yeah, that's fair, that's better. Okay, so I'm going to say that M is equal to the tan of P.O.X. But our M is a 3, which means 3 is equal to the tan of P.O.X. Then for us to get the P.O.X, is going to be the arctan of 3. So arctan of 3 is giving me 71.57 degrees. Okay. So we're saying this is a 71.57. Then do we know the gradient of this line? We can find it. We can find it. So saying gradient of PQ. Remember the coordinates up there with 3 and 9. Okay. Let me just put them here. 3 and 9, and then we have 7 and 1. let's do the magic. So it's going to be 9 minus 1 over 3 minus 7. That's 8 over negative 4, which gives us negative 2. Which means PQX, same story. So PQX is going to be the arctan of negative 2. Okay, punching that, I'll get a negative answer, and then I have to plus the 180. I can focus on the positive and then subtract the 180 or subtract from 180. So arctan of negative 2 is giving me negative 63 plus that. When I add the 180, I'm getting 116,57. Okay, so 116,57. Then OPR, okay, saying OPR is going to be 116,57 minus 71,57. Okay, 116,57 minus 71,57, which gives me a 45. Okay, so if this is a 45, but we're saying that PRL, okay, PRL is a 90, that is angle in a semicircle, which means that L is also going to be 45 angles in a triangle, because 45, 90, then this must also be a 45. All right, that is how I would have approached 4.5. Then TR is a tangent. This one is now crowded. Let's use this side. They're telling us that TR is a tangent. Okay, let's just sketch it that way. Okay, so if TR is a tangent at R, can we prove that PT is perpendicular to RT? Can we prove that PT is perpendicular to RT? In other words, we must prove that there is a 90-degree there. Okay, now what we just proved was that this is a 45. Okay, so if that is a 45, this is a tangent. So what we're going to use will be the theorems, okay, because we're having a circle there, so we can use the circle theorems. Let's read the question again. Can we prove that the sides are perpendicular? So what I'm going to do, I'm going to say this angle is a 45, because this and this will be equal, tan chord. Okay, so I'm saying TPR is 45 degrees. That is tan chord. Then I can also now, since I have this as a 45, I can declare TRP as a 45 also. I can either give the tangents from a common point are equal, okay, or we can still use our tan chord because it still holds in this case. Then if that is true, if that's a 45 and that is also 45, then we can say that angle T or PTR is going to be 90 because those are angles in a triangle. And since it's a 90, therefore PT is perpendicular to TR. All right, so that is how we would have gone about with question number 4. Question number 5, which is trig. They are telling us that in the diagram, okay, there's a line OP, which is given with P being -3 and -4. Then KOP is A without using a calculator. It's in bold. You must find the value of cos A. So step number 1, complete this triangle. Okay, let's use red. Let's complete it. And let's have a 90 there. Now this is the -3. This is the -4 because it's X and Y. Then we need to find OP. So OP is going to be the square root of -3 squared plus -4 squared. Reason, we're using the Pythagoras. Okay, so which means our OP is going to be a 5. Now remember, when you're finding the hypotenuse, we can never have a negative. It's always a positive value. So if our triangle is finished, I think that's where we're going to get the first mark for completing the triangle. Then now to get the cos, we know that cos from our trig ratios is adjacent over hypotenuse. So if the all of this is A, it's as good as just focusing on that inside part as A. Okay, so adjacent is -3, hypotenuse is a 5. So it's -3 over 5. All right, then 5.1.2, they want the cos of 2A. So this is a double angle. And then from our formula page, we know that the cos 2A can be the same as 2 cos squared A minus 1. And then we just have to substitute this. So that will be 2. We got the cos as -3 over 5. We square that, and then we subtract 1. So 3 squared is going to be 9 over 25. 9 times 2 is going to be 18 over 25 minus 1, which is giving me -7 over 25. Okay, so that is that. Now, even if you use a different format of cos 2A, we must still arrive at the same answer, which is -7 over 25. Then 5.1.3, they want us to calculate this if it's further given that sine B is this. All right, so what we're seeing is that we have something extra now. Sine B is 4 over 5, but B is between 90 and 360. So from this point, because this is our 90, 180, 270, and then 360. So what's going to happen is this ratio is positive. So in these 3 quadrants, we know that sine is positive just in the second. So which means I need to draw something like that. Why don't I use a different color? Okay, just draw something for B in this sort of format. Makes a 90, then the whole of that is a B. But they told us sine. We know that sine is the opposite, which is 4 over the hypotenuse, which is 5. Now, if you apply your theorem of Pythagoras, we know that this adjacent is still going to be a 3, which is on the negative side, which is the same as a -3. So both triangles are using a -3. Okay, so let's break this down using the compound angles. So sine A, that is going to be the same as sine A cos of B minus sine B cos of A. Yeah, whichever format it is, but it is like that. Then sine of A, we said it's going to be opposite over hypotenuse. So -4 over 5 times the cos of B is adjacent over hypotenuse, which is -3 over 5. Now we are subtracting the sine of B. Sine of B, we have it as a 4 over 5 already, no? Which is 4 over 5. And then the cos of A, we calculated it as -3 over 5. So simplify that, that's 12 over 25. Negative, I'm getting a plus now, 12 also over 25. So 12 over 25, 12 over 25, we shall end up with 24 over 25. So that is what I'm getting for 5.1.3. Then 5.2, which is a bit separate from our diagrams up there, they're telling us that if cos alpha is a P, can we express the following expression in terms of P? Now, there's something that we need to see or to understand with this expression, that there's something funny, okay? We have cos sine, okay? This is more like the identity of the double angle of sine, okay? Let me say we have the sine 2 alpha. No, let me not use alpha because I'll end up confusing people. I'll say sine 2a. It's given as 2 sine A cos A. Okay, so I'm going to take this entire bracket to represent my A. So I have my cos and then my sine. What am I shorting with? I'm shorting with this 2. So divide both sides by 2, eliminate that 2, which means that this sine A cos A is equivalent to a half sine of 2a, okay? So I'm replacing this with a half sine 2, but my a is alpha over 2 minus a 45. I'm dividing this by 2. Okay, so a half divided by 2, I'm gonna end up with a quarter, okay? This is the sine of, let me open this up. So alpha over 2 times 2, I'll be left with just alpha, 2 and 45, that's 90. Let's factor out the negative sign. So sine negative, that's gonna be 90 minus alpha. Take the negative that side. You shall have the sine of 90 minus alpha. So from our reduction, we know that sine of 90 minus alpha will give us a cos of alpha. So this is gonna be negative a quarter cos of alpha. But the cos of alpha is a p, which means our final answer should be negative a quarter p. So that is question number 5. Question number 6. Question number 6. Given the identity, cos of x minus y is equal to cos x cos y plus sin x sin y. Use the compound angle identity given above to derive the formula for that. So we can use the 90 sort of approach, but we can also use something extra, okay? So I'm gonna replace, okay, positive y with the negative y, okay, into this expression. Okay, that's gonna be my first step. Let y be equal to negative y. So that then I'm gonna have cos of x minus, now with the minus y, is equal to the cos of x and then the cos of negative y, okay, plus I have the sine of x and then the sine of negative y. I know that this negative and negative will give me the positive, so I'll end up with the cos of x plus y is equal to, that's gonna be cos of x. We know that the cos of a negative angle is the same as the cos of a positive angle. So that is a cos y. Then the sine of a negative angle, we have to take the sine out. So that's gonna be like negative sine y, okay? Negative or positive, we'll get a negative sine x and then sine y. So I have proved, or I have derived just from that. So some people would choose to use the 90 minus, 90 plus, well and good, okay? I'm using this. So that is how I would have gone about that. And then hence, or otherwise, hence. So hence simply means that with what we have, with this sort of identity, remember we have the identity of cos x plus y is given as this. So where there is x plus y, cos of x plus y, we can replace it with all of that. Either way, okay? So we need to simplify that. We need to simplify that. So let's see what we have this side. That is 6.1.2. Let me write the question out. We have the cos of 90 minus x. Okay, we're multiplying by the cos y plus sine of negative y. Okay, times the cos of 180 plus x over cos x. Okay, that is cos x, and then cos of 360 plus y, and then plus sine of 360 minus x, and then sine of y. All right, so they're telling us this is equal to the tan of x plus y. All right, let me start from the left-hand side, okay? Left-hand side. So 90 minus will give me sine of x using the reductions because it's a compound angle. Then that's cos y, we can't do anything about that. Then the negative sine of an angle, it will be negative sine cos of 180 plus, this is quadrant 3, where cos is negative. Okay, so negative cos of x. This is sine y. Okay, over, that's cos x, 360 plus, that is in quadrant 1, where the cos is positive, the cos y. 360 minus, that is in the fourth quadrant, where the sign is negative, and then sine y. All right, let me simplify that. So that's going to be sine x cos y, that and that will have a plus. Sine y cos x over, that's going to give me cos x cos y minus. Is that a minus or it's a plus? We say this is a positive. 360 minus the die. Let me just go back and see. 360 plus. This is quadrant 1, which is cos y. 360 minus, that's going to be negative. Am I on the right track? Because this is sine x. Okay. Right, it's fine. Let's move on. So that is going to be sine x and then sine y. All right. Then because now these are compound angles, let's move backwards. So this is sine cos, which means it's the same as the sine of x plus y. Okay. Over, this is cos, sine, and we have a minus. So that is the cos of x plus y. But previously we said, okay, that's what we did actually, from there, back here, from there, back there. All right, perfect. But we know that sine over cos must give us the tan. Okay, identity of sine over cos, that must give us the tan of x plus y, which is equal to the right-hand side. All right, so that is how 6.1.2 would have been approached. Then 6.2, we are given f of x at the square root of that. Okay, they want us to solve for x in the interval 0 to 360 if f of x is 2. So what I'm going to do, let me jot it this side and say that f of x is the square root. Okay, that is the square root of 6 sine squared x plus 11 sine x plus 7. But they said f of x is 2. So I'm going to replace this with a 2. Okay, that is 6 sine squared x plus 11 sine x plus 7. Let's square both sides to get rid of the square root. So I have a 4 is equal to 6 sine squared x plus 11 sine x plus 7. Move the 4 that side. Okay, which means I'm going to be left with a 3. So 6 sine squared x plus 11 sine x plus a 3 is equal to 0. Let me factor this out, or you can let sine x be a y or something, okay? So this can be 3 sine x. This can be a 2 sine x. How do I get a 3? It's 1 and 3. Let me call this a 3. Let me put here the 1. All of them are plus since it's just addition. All right. So if that is that, which means that my sine x here, if I equate this to 0, okay, I get 3 sine x plus 1 is equal to 0, which means the sine x is going to be negative a third. Or the sine x is going to be negative 3 over 2. Then I can use, remember, it is more like general solutions, okay? All I can do I need to use general solutions, really? Not really. Let me just find the reference angles, okay? So if the sign is negative, which means I'm dealing with quadrant 3 and then quadrant number 4. So what is the arc sign of 1 over 3? And that is giving me 19,47. That is my reference angle. Okay. Then I know that in quadrant number 3, it's going to be 180 plus. Okay, so 180 plus 19,47, that's going to give me 199. Okay, 0.47. And then the other quadrant is quadrant number 4, where I'm having 360 minus 19,47. This must also give me 340,53 degrees. So these are the solutions that I'm getting there. When I look at this bracket, we don't have solutions in this case, okay, because our sign should never be smaller than -1 or bigger than +1. Okay, so that is this and that, okay? That's what the question needed. Then if you got the root of general solutions and then you substitute, you should be getting the same kind of thing. All right, then 6.3. Consider the function. Okay. Can we calculate the maximum value? So we know that maximum value relates more like to the amplitude. So the question is asking for the amplitude of this question. Okay, so what I have is sine squared of x. Okay, but we can't plot such graphs. So I know that sine squared can only relate to a cos 2x. So from the formula page, the cos 2x can be given as 1 minus 2 sine squared x. That is if I'm not mistaken. Let's go there and see. Okay, 1 minus 2 sine squared. Now, if that is true, okay, if that is true, which means that I need to make, or I need to bring in the cos 2x into the picture, where there is sine squared, so which means I need to move this one that side, okay, which is going to be 2 sine squared x is equal to 1 minus cos 2x. Then I can divide by 2 so that I have just sine squared x alone, okay? So where there is this, I'm going to replace it with all of that. Okay, so that's going to be 4 minus 8 into 1 minus cos 2x over 2. This whole thing is over 3. Then these 2 can reduce the 8. So by 2 is 1, by 2 I have a 4. Open up that. 4 minus 4. Then this negative from that, I'll have a positive 4 cos 2x. Everything is over 3. Then we know that this is going to cancel that. So which means it's just 4 cos 2x over 3. So this is our amplitude, and that is the maximum displacement of the graph about the rest positions. So which means that the maximum is 4 over 3. Okay, so that is how I would have gone about with that. That's the maximum value. Then 6.3. Write down the smallest possible value of x for which g will have a maximum value. So they're asking us, where do we find the graph to be maximum? What x value is it? So we know that the graph of cos 2x between 360 and 0 should be something like that, round about that. Okay, so at this point, that's where we're getting our maximum of 4 over 3. Then at this point also, we shall have 4 over 3 as our maximum. But remember, they're asking for the smallest possible value of x. So at this point, x is a 0. This should be maybe a 90. This should be probably 180. And so we need the smallest. So x is going to be 0 degrees. All right, so that is question number 6. Question 7, which is the tan graph. They're asking us that the diagram below the graph of f of x is equal to tan of x. It's given the interval between -180 and a positive 180. Can we write down the equation of the asymptote of f between 0 and 180? So asymptote is just that line. where the graph does not touch. Okay, 7.1, we're going to say that x is equal to 90 degrees. 7.2, they want us to write down the values of x in the interval between negative 180 and 0. Okay, where the graph is below or equal to 0. So we can see that the graph is below from here up to this point within this interval. Okay, is below 0 or equal to 0. Then at this point here, the graph is just equal to 0 because it's still the same interval. So what I'm going to say is that x is negative 180 degrees, and then negative 90 is less x is less or equal to 0. That's my approach for 7.2. Okay, so we have this interval for this section here because this graph should never touch this asymptote. That's why there's no equal sign there. And then the fact that there is an equal sign equal to 0, it's equal to 0 at negative 180. All right, then 7.3. 7.3. If we are given g of x, which is 2x plus 1, g of x is 2x plus 1, can we write down the period? So this 2 will affect the period. So that a normal course graph will have a period of 360. If we have anything extra there, we just have to divide. It's a 3 divided by 3. Now it's a 2 divided by 2, which means our period is going to be 180 degrees. Then 7.3.2, I'm just going to plot it there. Okay. On the grid in the answer book, they want us to draw this graph, okay, using the same interval. Must show the intercepts as well as the coordinates of turning points. So just follow the same criteria of how you plot your graphs with the calculator, okay? Mod, and then table, and then punch in everything, okay? So what I did, because these intervals of 99 are so big, I used 45 as my step, okay? So this helps me in quickly having a smooth graph thereof. Okay, so when I punch everything into the calculator, we say table, and then is it table that we're using? Yes, we're using the table. So mod table f of x, they told us it's cos 2x, then plus 1. So g of x we don't have, we're starting from negative 180, we're ending at positive 180. We said I'm using steps of 45. Okay, so negative 180, I'm having a positive 2. Okay, and then negative 135, I'm having a 1, which is there. 90 is 0. Negative that, I'm having a 1. 0, I'm having a 2. That, I'm having a 1. That's a 0. Then that's a 1. And then that's a 2. Somewhere there. And then all I have to do is connect this with my free hand. Okay, remember those are turning points, so they should be relatively smooth, not very sharp. Okay, so we have something like that. Okay, so that is g of x. That's what they wanted. And then 7.4, they want us to use the graphs to determine the general solution of this. So how many points is the graph meeting or the graphs meeting? So we're meeting at this point and then meeting at that point. General solution. Okay, so let's see. Step number 1, is it possible for us to express this entire thing in the form of cos 2x plus 1 as well as the tan x? That should be the first target. Okay, if we can do that, then we can get our answers. So step number 1, I'm going to divide both sides by the, okay, let me not divide. Let me isolate. So 2 cos cubed x is equal to the sine of x. divide by just the cos, divide by a cos. So I'll have 2 cos squared x is equivalent to just a tan x, okay? But we know from our formula page that cos 2x is given as 2 cos squared plus 1, okay? Now we only have 2 cos, this one. So let me move this one that side. Will that make sense? No, I think I made a mistake here. This is supposed to be minus 2 cos squared x minus 1. We can confirm that. 2 cos squared x minus 1. Perfect. Then if we move the one that side, it's going to give us the cos 2x plus 1 is equal to 2 cos squared x. So I'm replacing this whole thing by the cos 2x plus 1 is equal to the tan of x. Now we can see that f and g, they're equal, okay? So the point where f is equal to the point, or the point where f is equal to g, we see that it's between negative 180 and negative 90. So intervals of 45, this is equal. Then that is a 45, this is a negative 135. So I'm going to say that x must be positive 45, then x must be negative 135. All right, so that is question number 7. Question 8, which is the trig rules. Okay, in the diagram, sees the foot of a vertical building D. Then at top, same building, the height of the building CD 16, okay. 2 observers are standing 19 meters apart at points A and B, where A, B, and C lie in the same horizontal or right. Painter is working at E, and so on and so forth. Okay. 8.1. They want us to get the length of AC, which is the distance between A and the foot, okay? So we can use this triangle, okay, CAD. From CAD, we have this angle. We're looking for this. So we have the opposite, we're looking for adjacent. We can use tan. So the tan of 46,85 is given as the opposite, which is 16, over the adjacent, which is AC, which means AC, if I cross multiply, is 16 over the tan of 46,85. When I punch that into the calculator, that is 16 over the tan of 46.85. That gives me 14,9987, which is, I'll take it as 15 units. Okay, so this is a 15. If we are to round it off decimals. Now, if that is a 15, 8.1 is answered. 8.2. 8.2. They want us to calculate how far the painter E is from the top. In other words, we need to find this distance here. So for me to get that distance, I need to find what CE is. For me to get CE, I can find this angle. Okay, let me start with that and say that BEC, and I'm going to use it somewhere. 180 minus that, there's that a 58 angles on a line. This is 7 max. Okay, that's 58. Then for me to get this, I'll need BC. For me to get BC, I'll need this angle here. for me to get this angle, I need this angle first. Yo. All right, guys, let me use the sine rule and say that from BCA, okay, if I'm going to use the sine rule, I'm going to say, I'm looking for a side, which is now BC over the sine of BAC should be equivalent to AB over the sine of BCA. Substitute BC is going to be AB, the sine of BAC, over the sine of BCA. So my AB is 19. I'm multiplying it by the sine of BAC. Aibo, what are you doing, bruh? BC, that's not going to make sense. Where are you going, my man? Where am I going? Where are you going? Because I know I have this, I don't know BAC. I cannot find those angles at the same time. Okay, so let's do this. Let's do this. I'm sorry for that. I'm gonna use the same triangle, but let me use AC. No, I'm gonna say the sine of CBA over AC should be equal to the sine of BCA over AB. Okay, which means the sine of CBA or ABC should be AC, the sine of BCA over AB. Okay, so my AC is a 15. We're saying the sine of 105,61 over AB, which is 19. Okay, for me to get my CBA, I'm gonna use the arc sine. Okay, shift sign of this entire thing. Let me punch this so that I see if we have the same answer. So that is 15. Sine of 105,61. Close that bracket over 19. Close that. So I'm getting 49,495, which is 49,5. Okay, so which means this angle here is a 49,5. Okay, then I can find this angle using the angles in the triangle. So BAC is going to be 180 minus this minus that. Let's do that. So 180 minus a 49,5 minus 105,61. That gives me 24,89. 24,89 degrees. So if this is a 24,89, then I can use either the sine rule and find what BC is now. Okay. So I'll say BC over the sine of 24,89. It should give me the AB. Let me just substitute it. AB, which is 19 over the sine of 105,61. So BC over the sine of BAC is equal to AB over the sine of BCA. Okay, sine rule. Okay, let's make BC the subject, which means the BC is going to be 19, the sine of 24,89 over the sine of 105,61. Okay, 19, the sine of 24,89. Okay, we're dividing it by the sine of 105,61. That gives us 8,3. units or meters. It's meters. So if that is 8,3, then we can use this angle and then the tan. Is it tan? Yes, because this is now the adjacent. This is the opposite of 58. So I'll say the tan of 58 is equal to the opposite, which is 8,3 over EC. Let's look for EC alone. EC is going to be 8,3 over the tan of 58. Let's do that. Let's do that. That's tan of 58. That gives me 5,19. Now the distance that they want is ED. Is it ED? No. They want us to get the distance from the top to the paint. Yes, they want ED. So ED is going to be the 16 meters minus the 5,19. Okay, which gives me 10,81 meters. All right, yo. So this, then that, and 7 marks, it's worth it. All right, question number 9, okay? In the diagram, ABCD is a cyclic chord, beautiful. BC is produced to E, AC is drawn, A1 is a half of B, A2 is 46, and C1 is 86. 9.1. Can we give reasons and find the value of A1? Okay. So we know that if this is 86, which means the whole of this must also be 86 because this is an exterior angle. This is the opposite interior. So I'm going to say that A1 plus a 46 must give us 86. Reason, exterior angle of a cyclic chord. Then let's move the 46 that side, which means A1 is a 40. All right. So if A1 is a 40, they want us to prove that AD, okay, this one is the same as DC. For us to prove that, we just need to make sure that C2 is a 40. That's the only thing we have to do. So what are we going to do? Let's use this. So for us to get B is going to be twice A1, which means that our B is going to be 80 degrees. Okay, that is 80. And then angle D is going to be 100 reason. That is the opposite angles of a cyclic chord. Okay, so this is 100. If that's 100, that's 40, we can find C2, which means C2 is going to be 40 angles in a triangle, because 40, 100, and 40 must give us 180. Now we can say that since C2 is the same as A1, which is 40, therefore AD is the same as CD or DC. Reason will be the sides opposite equal angles, or the converse of angles opposite equal sides. So that is how we would have gone about with 9.2. All right, question 10. In the diagram, RS is drawn. Line AB intersects RS and RT at point A and B, respectively. Then AB is parallel to that. Okay. They want us to prove the theorem that states that a line drawn parallel with one side of a triangle must be proportional to the other two sides. In other words, you must prove that RA over AS is equal to that. So what we need to do here, it's just a construction. Let's go this side. We said it's just a construction. So in this construction, I can have this, and then I can have that. Let me also construct, maybe I'll call this my perpendicular, which is height 1. And then let me have another height this side. And then I call that height 2. Okay. So I'll start by using the areas and say that the area or ratios of area of RAB over the area of SAB. RAB, SAB. So that's going to be a half times RAB, I'm using H2, multiplied by AR or RA, over half times the same H2 multiplied by AS. You cancel the half on the H2, which means AR over AS, or RA over AS. Then go down and look for the area of still RAB over the area of TAB. Okay, so this and then that. So that's going to be a half. We're using now H1. Okay, that's H1 multiplied by RB, that's our base. Then a half multiplied by the height, which is H1, and then BT or TB as our base. So that cancels that, which means RB over BT. But we know that the areas of RAB in both triangles are basically the same. So let's equate those ratios and say that therefore AR over AS should be the same as RB over BT. Okay, we said the ratios are equal and we have similar triangles, which means the ratio of RAB is in proportion to the bigger triangle. All right, guys, that is the hint of how that question should have been worked out. Then 10.2. In the diagram, O is the center of the circle. PWS is drawn with P. WS on the circle, OR is perpendicular to PS, is produced to T. SW and OT intersect at V. OV, okay, and OT. That's 4, which means that's a 3. Okay. Can we prove with reasons why the ratio of OR to WS is 1:2? Now, this question is, in other words, asking us to prove the midpoint theorem. For us to prove the midpoint theorem, we just need to make sure that this line is parallel to that one. That's the hint. We can prove that. The rest will be history. Okay. So what I'm going to do, I'm going to say that PSW is going to be 90 degrees. Reason, angle in a semicircle. Okay, so if that is a 90, what does it make these two lines? It simply means that those two lines are going to be parallel. So I'm going to say that PRO is also 90, which is equal to PSW. Therefore, OR is parallel to WS. Now, if these lines are parallel, okay, there's something extra we need to also add. Then we can see that O is the midpoint of PW, since O is the center of the circle. Then we know that from the midpoint theorem, okay, what did that theorem tell us? That a line drawn parallel to one side of triangle divides the other two sides proportionally. Okay, in other words, if this is a midpoint, which means even this is going to be a midpoint. Okay, so we're saying that OR is parallel to that. Reason we said will be corresponding angles, or the converse of corresponding angles. Okay, if since then O is the midpoint, therefore R will be the midpoint. R is going to be the midpoint of which line? Of PS. Of PS. That is from the midpoint theorem, or from the proportionality theorem. Then we're saying that from the midpoint theorem, we know that OR must be a half Why am I saying, okay, OR must be a half of SW. When you divide both sides, then you're going to have OR over SW is equal to 1 over 2, which means OR to SW should be 1:2. Okay, so that is all they needed. Prove the 90 degrees here. Okay, give a reason. Then go on to conclude that these lines are parallel. Then bring in the midpoint aspect and then use the midpoint theorem for the distance. Okay. Then 10.2.2. 10.2.2. They want us to calculate the length PT. So we proved that this and that are parallel. They want the distance PT. If ST is 15. Now we say this is the same as that. Just like that is the same as that. All right, so let's see. So if I use triangle, okay, I'm going to use TOR. Okay, so I'll have my RS over my RT. Let me call this. Okay, it should be equal to RS, which means it's OV over OT. Reason is going to be the proportionality theorem because OR is parallel to WS. Let's do the substitution. So X over X plus 15 should give us the ratio of OV to OT, which is 1 over 4. Cross multiply. 4X is going to be X plus 15. Move the X that side. 3X is a 15, which means X is a 5. So then if this is a 5, okay, we said, but PR is equal to RS, which is equal to 5. Then PT is going to be 5 plus 5 plus 15, which gives me 25 units. So that is how the 4 marks would be obtained. So that is 10.2.2. Question 11. Question 11. In the diagram, A, B, G, F lie on a larger circle. A smaller circle is drawn to touch the larger circle internally at A. A is common tangent to both circles. That's a tangent, the smaller circle that is produced, and all of that, they are drawn. Can we determine with reasons for other angles? Sweet 6 marks. Let's see. So EAG, in other words, the whole of this is X. So for other angles, so since this is a tangent, which means the whole of this must also be X. Okay, so I'll say AFG is equal to X. That is the tan chord. Okay. Then the other one I'll see is that D1 is also X. Since that is X, this must also be X. D1 is X. That is also a tan chord. Then if this is X, which means this C1 is also going to be X. We can also use tan chord. Or since this is a tangent, that's also a tangent, we can use tangents from a common point. Okay. Tan chord or tangents from a common point. One of the two. Then the third angle is going to be C4. This angle here. Because this and this will be vertically opposite angles. All right, so we have our 4 angles as per the question required. Okay, so we say that is X, 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 and U are also X. Even this one, X. Okay. Then can we prove that AG times AD is equal to that and that and that and that? So what we need to know is that since D1 is X, okay, let me put it here. That says that since D1 is X, which is the same as AFG, simply means that these two lines are going to be parallel. So CD will be parallel to GF. That will be the converse of the corresponding angles. And if that is true, then we can see that this small triangle is similar to the bigger triangle, okay? So therefore, we're saying that ACD is similar to AGF. Then let me compare the sides. So I'm going to say AG over AC is equal to AF over AD, and then just cross multiply. So that's going to be AG times AD should give me AF times AC. So that is what the question wanted in 11.2. Then 11.3, they want us to prove that some triangles are similar, okay? AGF, the Makulu triangle, okay, this big triangle, that it is similar to ABC. Let me use this. All right, so what I can spot from the word go is I have this X here, and then I already have the X there. So what I'm going to say, I'll say that AFG is the same as ACB, which is X. We've proved that, okay? Because initially they told us to show that that's okay. So that is proved or proven. Then if that is true, we can also see that G and B2, because of the bow tie, okay, we can see this bow tie here. So G is the same as B2, that is angles in the same segment or angles subtended by the same chord AF. Then lastly, we know that A2 is going to be the same as A3. That's going to be the remaining angle of the triangle, or the third angle of a triangle. Now we have the prefix, therefore, our AGF is similar to ABC because of angle, angle, and angle. So that is how we will have obtained the formats. Then lastly, 11.4, they want us to prove that GF squared is given as that. So my first approach is to compare the two triangles, okay? So what I'll do is just sketch the two triangles here. Just, okay? So I have A, this is B, this is C, this is A, this is F, this is G. That is X, that is the dotted that I had. This is the A2 and A3. All right, then let me compare the sides. So if I get the AB, should I start from there? Yeah, I'll say AB or AG. Let me start with the big one. So AG over AB should give me BC over GF, which must also be the same as AC over AF. I mean, those sides are in proportion because these two triangles are similar. But my point of interest is these two triangles. You see, triangle ABC is also similar to triangle, this one, because they are, okay? If they are similar, why are they similar? Because this and that, okay? And then this angle here, and then this angle here as well. Then this one, and then that one, vertically opposite. So they are similar. So which means that if I consider that, I'll have my AC. Okay, where's the AC? This is AC over the FC. Okay, so I'll have from triangle ABC, which is similar to triangle FCG. So I'm having AC over FG. Sorry, FC is equal to AB over FG. I can make AC the subject at this level. And then I'll have AB times FC over FG. I can call this my equation number 1, okay, or just the starting step. Then 11.2, we had this. Let's also generate something from this. So from here, let me make AC the subject, which means it's going to be AG multiplied by AD over AF. Then I'm going to equate the two, okay, because it's AC and AC. So I have AG times AD over AF is equal to AB multiplied by FC over FG. Okay. So what I can see, I need to bring out something weird. And that something that I need will be the AG over AB. I need this to come out of this. So AG, so it means I need to take this one that side and bring this one down. So I have AG over AB. If I bring this one down, I'll have my AF multiplied by FC over FG multiplied by AD. Okay, we're not yet there, we're almost. Call that probably equation number 2. And then lastly, we're saying, but we know that AG over AB is going to be the same as FG over BC. Saying AB, no, it's AG. Okay, this whole big side over AB should be the same as FG over BC. So which means I'm going to replace this with that. So that I have my FG over BC is equal to AF times FC over FG times AD. Then multiply this that side and multiply the other side. So I'll have my FG squared, because if I get, let's say, times FG on either sides, okay, times FG times FG. So this cancels that. And then I multiply both sides by BC times BC, and then times BC. This cancels that. So I'll have my AF, my FC, and then my BC over the AD, which is down there. Isn't that what the question wanted? BC, we have it. FC, we have it. AF, we have it over AD. So that is how those 6 marks would also have been claimed. All right, guys, we've come to the end of the question paper, paper 2. And on average, we can say this paper was fair enough compared to other paper 2s that we've seen in the previous years, okay? It was fair enough. Remember, this is just the proposed memorandum. It's not the exact one, okay? So if there are any issues where we're not getting along, feel free to slot that under the comment section and we shall rectify that further, okay? Thank you very much. And then all the best in your remaining examinations. Bye-bye. Hello and welcome to yet another episode where we shall be looking at the suggested proposed memorandum for mathematics paper 2, virtual for November 2024. All right, number 1, which is the statistics that most people call data handling. Okay, so question 1, they're telling us that an insurance broker signed contracts with 15 people. The monthly premium in rands payable on each contract is given as below. Okay, so we have these amounts which are already arranged for us in order. Beautiful. Then they ask us to calculate the mean. So when you punch everything in the calculator, okay, which means the mean is going to be the sum, which is 58554 divided by 15. And this gives me 570.27. Okay, so if you follow the procedure of punching this in the calculator using the mod and the start kind of direction. Then 1.2, they're asking us for the standard deviation. So the standard deviation that I'm having is a 29, it's 291, not a 29. Okay, so it's 291.03. That is still runs, but the units are not really relevant in this case, okay? Whether you put them or not, you'll still get your marks. Then 1.3, they're asking us to calculate the monthly premiums within one standard deviation, meaning that we must get the mean minus the standard deviation, and then we must get the mean plus the standard deviation. So if I get the mean, which is the 570.27 minus 291.03, my upper limit is 570.27 plus 291.03. This gives me a limit of 294.24. And then the upper limit is going to be 861.3. Okay, so how many data pieces are within this interval? Okay, so when I count between 294, that's from here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, okay, below 100. So which means we have 10 premiums, okay? So that is what we have for 1.3. All right, then. Okay, so 1.4, they're telling us that the insurance company decided to increase the monthly premiums, okay? The monthly premiums that were less than 500, they were increased by 18%, and then those ones above or equal to 500, they were increased by a certain percentage, which is K. After the increments in the data, a new mean was determined as 686.44. They want us to get the value of K. All right, so what we're going to do there. So I know very many people might have different opinions on how to work this out, but I'm just going to use my format for as long as we get to the correct answer. So I need to add up all the amounts that are less than 500. So 134, 215, all these ones. So how many are they? 1, 2, 3, 4, 5, and 6. So these 6 amounts, when I add them up, I'm going to get 1,791. Then I'm going to multiply this by 118 over 100 so that I get the new total for those 6 amounts, okay? So when I do that, I'm getting 2113.38. Alternatively, somebody would have said 18% of this and then you plus again, okay? So we have this as our first total. Then the amount above 500, okay, that's below 500. And then above 500, I can just subtract the total that we had, 8554, minus this total of ours, okay? So that gives me, I can do that. I can subtract this from that, but that would be suicidal. Let me rather add up. Okay, subtract 8554 minus 1791. Okay, this gives me 6763. Okay, so if I have a 6763, and then I'm gonna multiply it. Okay, plus 6763 times K%. Okay, this must give me the other total. Okay, which means I'm gonna have this. Alternatively, if this 1K, I don't want to say 1K, but you'll have 100 plus K, and then you multiply this with this entire thing, you'll end up still with the same thing. Okay, then after getting this, I need to plus the 2 and try to find the mean, okay? So I'll have 2113.38 plus the 6763 plus the 6763K%, okay? And then I'm going to divide this by 15 and then equate it to the new mean, which is 686,44. Okay. Then I'll multiply both sides by 15 so that I get rid of the 15. So times 15, then times 15. So this cancels 2113,38 plus, that's going to be 6763 plus the 6763K, the percentage should give me, what answer do I have there when I multiply? Boom, 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 boom. Okay, so when I multiply that, I'm ending up with a 10296,6. Okay, let's just confirm that 686,44 multiplied by 15. 10296,6. Okay, let's plus this together. We're gonna get 8876,38 plus the 6763K% is equal to 10296,6. Let's move this that side. It will be a subtraction. 6763K% should give us, when you do your subtraction, I'm ending up with a 1420,22 divided by 6763. Okay, so meaning that our K% is something like a 0.20998. Multiplied through by 100, K is approximately 21%. Okay, so that's what I'm getting. Okay, you can use your short method that is quick and still get the same answer. But this is how I would have approached it in the longest format. Okay, then question number 2. Question number 2, they're telling us that the manager of a supermarket decided to do a survey on the number of items that a customer ordered online and the time in minutes that the packer took to have the order ready for delivery. So they have 10 online orders on a certain day, and then the information is for those 10 orders. Okay, so we have the bivariant type of data. Okay, they want us to draw a scatter plot. Can I draw it here? Okay, so let me just put it down here. Okay, so that's your Y, and that is your X. We don't have any negative numbers in this case, okay? So you guys had a graph book or graph page. So yours was kind of neater and slightly quicker. So with mine, what I'm going to do is, let me use X, okay? Because this X is representing the number of items. I believe that's what it was. And then this time we shall have the time. So if I have this as a 5, I can have a 10, a 15, a 20, and then lastly, I have a 25. Then up here, the highest value I'm getting, I think, is it's a 12. So meaning that I'll have a 2, a 4, a 6, 8, 10, and probably a 12 somewhere there. So what we need is just the trend of how things are happening, okay? So 10 is going with 5. 10 is there, 5 is somewhere there. Then we have 3 is going with 5 again, 3 is somewhere there. 5 is more or less around there. Then 20 is going with 9. 9 is slightly before 10, okay? Then 14 is with 7. 14 is there. 7 is slightly between 6 and 8. And then 17 and 6. 17 is somewhere there. 6 is somewhere here. And then 9 and 6. 9 is there. 6 is somewhere there. Then 12 and 8. So 12 could be here. And then 8 should be somewhere there. Then 18 and 11. 18 and then 11 is somewhere there. Up. And then we have 15 and 10. And then we have it somewhere there. And then 19 and 12. 19 and then the last point, which is 12. So we must have this kind of shape that is having a positive sort of relationship, okay? So that is done. And then 2.2, they want us to get the equation of the least square regression line. So we know that that equation should be in the form of A plus BX. So my A that I have is a 3,079, or you can round it off to 3,08. And then the B, okay, the B I'm having is a 0,351, which is the same also as a 0,35. So Y is going to be 3,079 plus 0,351x. I'll use just 3 decimals. 2 decimals, perfect, well and good. Okay, then I need to find the correlation. So after punching all these numbers into the calculator, yes, that's how I obtain my A's and my B. So my correlation coefficient is 0,74 to 2 decimals. And then 2.4, they're telling us that the supermarket received 13 orders or an order of 13 items. Okay, can we predict how long in minutes? So we have to use this equation of ours, the regression equation, meaning that is 3,079 plus 0,351 multiplied by 13. If I were to use, let's say, that other one with just the 2 decimals, what would be my answer? So the answer I'm getting is 7,64 minutes if I use the 3 decimals. If I use just 2 decimals of the equation, I should be having something like 7,63, which is approximately 8 minutes. Okay, that's if I'm to round it off. Then 2.5, it's not a must to round off. Even these decimals are perfect. Then explain why the y-intercept of this line does not make sense. So meaning that the y-intercept, which is a 3,07 something, why doesn't it make any sense? Simply means that if we have an order with no items, that is going to take us 3, something minutes or 3 minutes to arrange that order. So that basically doesn't make sense because whenever an order is placed, there are items that have to be there, okay? So in other words, an order must have at least 1 or more items. You cannot make an order and then you don't, order. It's like calling pizza people and you're like, oh, I need a pizza. How many? 0 pizzas. Doesn't make sense. So the explanation should be around that. Okay, then question number 3. In the diagram below, this triangle is drawn where R lies on the x-axis, okay, and S lies on the left of R. Okay, T lies on the y-axis, coordinates of that. The equation of RT is this, meaning that this equation is also the same as 2x plus 10. Okay, let's have it in a simplified version there. Then they want us to get the coordinates of R. So we know that R is the x-intercept, and then at this x-intercept, y is always a 0. So I'll come down and say that 0 is equivalent to x plus 10. Move the 2 that side, negative 2x is a 10, meaning that x is a negative 5. So R is going to be negative 5 and 0. Okay, that's how I get the 2 marks. And then 3.2, they want me to get the coordinate, sorry, the length of RT. I leave my answer in a sad form. Now, given that the equation of RT is 2x plus 10, we know that this 10 is the y-intercept, simply telling us that the coordinates there are 0 and 10. Okay, they want us to find the length of RT. Since we've proved that this is a negative 5, and we know that this is a 90, we can use the Pythagoras, or you can use your distance formula. There is no problem with that, okay? So if I use the Pythagoras, that's a 10, that's a 5, meaning that my RT is going to be the square root of 10 squared plus 5 squared. Okay, say square root of 10 squared plus 5 squared gives me 5 root 5. Okay, 5 root 5 units. That is what we would have done to get that. Alternatively, use your distance formula. Okay, you still get the same answer. All right, then 3.3. Question 3.3. What do they need? They're asking us to determine the value of M if 2RT squared, okay, twice the RT squared, meaning that the 5 root 5, and then we square that, should give us 5 SR squared. So what is our SR? we don't know what SR is, but we're going to use the coordinate or the distance formula to determine that. Okay, so where can I do this? Okay, I can write it here. Okay, so where we have the left-hand side, we shall have 2 into 5 root 5 squared should give us the SR, I'll say it is M minus 5, which is a plus 5 squared, plus, this is 1 minus 0 squared. This is our SR squared, okay, from the distance formula. So I'll replace that is, so M plus 5 squared plus the 1. I'll open up this bracket and also simplify this side. So the 250 here is going to be M squared plus 10M plus 25 plus 1. Let's move everything to one side of the equals. No, there's something I missed out. There's a 5 here. Okay, so we don't need to leave that 5 out. So meaning that this must be multiplied by the 5. Okay, so 250 is going to be 5M squared plus 50M, and then 26 times 5. What do we get? 26 times 5 gives me a 130. Then let me get the standard equation. So 5M squared plus 50M. So 130 minus 250 gives me a 120. I can divide through by 5, okay? So M squared plus 10M minus, what's 120 divided by 5? I'm getting a 24. Gives us a 0. Which two numbers can we look at? Factorize that. I'll have M minus 12. No, it's plus 12. And then M minus 2. Yeah, makes sense. Mean that either M is a negative 12 or M is a positive 2. But looking at the position of M, it's on the negative side, which means that our M should be a negative 12. Okay, so that is how we would have obtained those values, okay? We move on to the next one. Question 3.4. Okay, so 3.4, they're telling us if it's further given that V lies on the line ST, okay, such that VR is perpendicular to ST, can we determine the equation of VR in this form? So one thing we know is that for as long as lines are perpendicular, the product of their gradients must always be a negative 1. So we're saying this is a negative 12 and 1. Okay, that's a 0 and 10. So we can find the gradient of this line, ST. Okay, let me put it aside. So we said S is negative 12 and 1. T is 0 and 10. So gradient of ST is going to be 10 minus 1 over 0 minus 12. Okay, gradient is change in Y over change in X, meaning that we have a 9 over 12, which becomes a 3 over 4. Okay, that's the gradient of the line ST. Now, if they are perpendicular, meaning that the 3 over 4 multiplied by the gradient of V, is it VS? No, it's VR. Okay, gradient of VR must give us a negative 1. So the gradient of VR becomes negative 4 over 3. But VR is passing through negative 5 and 0. So for us to get the equation, y minus y1 is equal to m into x minus x1 is what I'm going to use. Okay, meaning that I have y minus 0 is equal to negative 4 over 3 into x minus minus, which gives me a plus 5. I open this up, I have a minus 4 over 3x minus 20 over 3. So that is the equation that the question wanted. Okay. Then 3.5, can we show, hence, can we show that the coordinates of V are negative 8 and 4? Okay, how do we prove that that's negative 4 negative 8 and 4. So what I'm going to do, 2 marks. What would people have done in this kind of scenario? Because the approach I have is kind of lengthy for 2 marks. Okay, because what I need is just more like the equation of this line, and then I'll solve the 2 simultaneously. Okay, that's the option that I have currently. Okay, so we know that the equation of this line, since we say that the gradient is gradient of ST, we got it as a 3/4. Yes, 3/4. Okay, so it's a 3/4 with x. The y-intercept is a 10. This is our equation. Okay, then we already have the equation of this other line that we found. So I'm just going to solve them simultaneously there. This is question number 3.5, okay? So we're saying 3.5. We're saying y is a 3/4x plus 10. And then the other equation for the VR, we said it's a negative 4/3 x minus 20/3. Let's equate the two. 3/4x plus 10 should give us negative 4/3x minus 20/3. So I'm going to multiply through by 12 because I want to get rid of the denominators. So by 12, by 12, by 12, and then by 12. So that's going to give me a 9x plus a 120 is equivalent to negative 16x. That and that is going to give me minus 80. Okay, then I'll collect the like terms. I'll move the 16 that side. I have a 25x. And then 120 moving it that side, I'll have a negative 200, meaning that our x is a negative 8. Then get this negative 8, then I'll replace it into this equation. I mean, for 2 marks, something is fishy here. No? But we have the answer. Okay, there's no need to stress. We have the answer. So this is going to give us a negative 6 plus 10, which is a 4. Okay, so y becomes a 4. So that is how I would have proved it, okay? If you have a shorter way, please feel free to share with us in the comment section. All right, then 3.6. They're telling us that R prime is a reflection of R about the line x is equal to 0. Now, this line is the same as the y-axis. Okay, because along the y-axis, x is a 0. So where is R? Okay, let me just use a different color. Okay, so if we are reflecting it about the y-axis, which means instead of it being a negative 5, it's going to end up being a positive 5. Okay, rather let me erase this out. So if it's a positive 5, the question now wants us to determine the area. Are we looking for the area? I suppose. Okay, they want us now to find the area of the quadrilateral. Okay, this T, that point, this, that, and there we go, something like that. Okay, they want us to find the area of that quadrilateral. Okay, so for 5 marks. So the trick here is for us to understand that we have two triangles. I'll call this triangle A, and then I'll call this triangle B if I split it into 2. Okay, both of them are right angled because I already have a height here, because my height is going to be 10, because from here up to here is a 10, and then here up to here is also a 10. Okay, this one is automatically right angled. The only thing I need to find is the distance. Okay, find VT, and then I also find VR. If I do that, I'm good to go. All right, so let's get VT. Okay, so we said V is going to be negative 8 and 4. T is 0 and 10. Okay, so meaning that our VT, what is our VT? People with calculators, okay, is a 10 minus 4 squared. If we use the distance formula, 0 minus 8 squared under the square root. So 10 minus 4, that is a 6 and 8, meaning that this is 10 units. Okay. Then we said we also need which other distance? We need the distance VR. Okay. So VR, we know that our R is going to be a negative 5 and 0, meaning that it's going to be the square root of negative 8 minus 5 squared, then plus 4 minus 0 squared. Okay, when we punch this into the calculator, we have the square root of, that's going to be 3, which is a 9, plus a 16, meaning that it is 5 units. Okay, so I need to find the area of this. So this is a 5, this is a 10. We have this as a 10, we have that as a 10. So let's get the area of A plus the area of B. Okay, area of A plus the area of B. So that is a half. The base, let me have this as my base, which is a 10, and then let this be a height because these two are perpendicular. Okay, so it's 10 times 5, then plus a half. We said the base of B is this total distance, which is a 10. The height is also 10. Okay, 10 times 10. Okay, so when we simplify the first part, that's going to be a 25. And then this is going to be 100 divided by 2, which is 50, meaning that our answer is 75 units squared. So that is how we would have obtained those 5 marks. All right, then question number 4. In the diagram, M is the center of the circle having this equation, okay, meaning that the coordinates of M here are 3 and 0. Okay, and then the radius is 5 based on this. Okay, so if that's a 5, meaning that this one is also a 5. Okay. Then E is negative 1, 3 tier points on the circle. EC is a tangent. Okay, so if it's a tangent, okay, there's something we're gonna see. E cuts at D, that's perfect. And then they're telling us the distance ED is 15 over 4. Then MT is produced to get point C. Perfect. They want the size of CEM. So CEM, this angle here. So we know that that angle is a 90. Why? Because it's a tangent perpendicular to the radius. Okay, tangent and the radius will be perpendicular. And then they want the equation of the tangent EC in the form of mx plus c. So what we need to know is that whenever they ask us for the equation of the tangent, we need to first of all get the gradient, okay, of the radius to the tangent. So gradient of the radius is going to be change in y over change in x, meaning that I'll get my 3 minus 0 over negative 1 minus 3. So this gives me a negative 3 over 4. Yeah? That is for the radius. Then we know that gradient of the radius times the gradient of the tangent must give us a negative 1, meaning that the gradient of the tangent is going to be a 4 over 3. Okay, so we have our gradient as a 4 over 3. Then we need to write down the equation using this point E. Okay, so I'll say y minus y1 is equal to m into x minus x1. So y minus 3, I'm using point E, is equal to 4 over 3 into x minus minus 1, which gives me a plus. Okay, open this up as you transpose. So it's a 4 over 3x. That's going to be a plus 4 over 3. When I move this 3 that side, becomes a positive 3. So it's a 4 over 3x. This is going to be 9, which is a 13 over 3. This is the equation that the question wanted. Okay. Then they want the length dm. Okay. The length dm. Now, since we've proved that this is a 90, we know that the radius is 5. We can find this using the theorem of Pythagoras. Okay. Meaning that our dm is the longest side, is opposite 19. It's going to be the square root of 5 squared plus the 15 over 4 squared. You punch that in the calculator. How many marks is it? It's 3 marks. Okay. When I punch that in the calculator, I'm getting 25 over 4 units. Okay, alternatively, one would have started, since we already have this equation, you start by getting the coordinate of D, okay? And if you look for the coordinates of D, because at D, the Y is 0, you're gonna end up with a negative 13 over 4. And then you just plus this together. So it's gonna be 13 or 3 minus 13 over 4. So that should give you a 25 over 4 as that. Okay, so that is 4.3. And then can we show that P is negative 5? So we already have the equation here. And we already have the X value. So let's replace the X with a negative 7 and see. So 4 over 3 into negative 7 plus 13 over 3. When I punch that into the calculator, that's negative 28 over 3. Okay, plus 13 over 3. So perfect, it comes out as a negative 1. Then 4.5, can we calculate the coordinates of S? Okay, where SEMC is a parallelogram and the X coordinate of S is negative. Okay, it's less than 0. So they're telling us that there is a parallelogram, okay? In other words, there is some extra coordinate. So I'll just put that coordinate around here. I don't know, anyway. I'll call that S. And then I have my X and then my Y. So if I connect that and then connect that, I'll have some sort of a parallelogram. I know it's weird, it's ramshackle, but it's no big deal. Ne? What we need at the end of it is for us to come up with the correct answers, okay? So what I'm going to do there, okay, because I know the position is off, it might also be misleading. Let me just have it drawn somewhere, maybe here, so that it looks like a real parallelogram, okay? So that is X and Y. Okay, so X is on the other side. Now, whenever we have a parallelogram, the trick of determining the opposite sides or the missing, not sides, but the missing coordinates is for us to use what we call the midpoint formula. Okay, so we need to use the midpoint formula. So we need to get the midpoint of each C, which must also be the same midpoint as SM. Okay, so midpoint of EC. So it's saying the midpoint of EC, whereby we know that E is negative what? Negative 1 and 3. And then C, they said negative 7 and 5. Is that correct? Okay. So let's plus that and we see. So negative 1, also midpoint is x1 plus x2, divide by 2, y1 plus y2, divide by 2. So that's the formula, okay? So you're going to have a negative 1 plus a negative 7 divided by 2. 3 plus 5 divided by 2, meaning that our midpoint coordinates are going to be negative 4, as well as there's something wrong. This is a negative 5. I don't know why I'm using a positive. So negative 4 and negative 1. Okay, so those are the coordinates of the midpoint. Then we know that our S, which is xy, must also have the same midpoint as M with the 3, 0. SM must have the same midpoint. Okay, so if I use the midpoint formula again, I'll have X plus 3 over 2 should give me negative 4. And then when I cross multiply, that's going to be a negative 8. Move the 3 that side. X is a negative 11. Then Y plus 0 over 2 must give me this Y value of the midpoint. Then that our Y is going to be a negative 2. So that is how I would have gone about answering that question. So they want the coordinates. Okay, so we said negative 11 and then negative 2. All right. And then 4.6. Okay. 4.6, they're telling us that if the radius of the circle that is centered at M is increased by 7. Okay. Now, if this radius is increased by 7, meaning that the new radius is going to have 12 what? 12 units. Good. Now, they're asking us, determine whether S lies inside or outside of the new circle. Support your answer with the necessary calculations. So when I look at the center, okay, so I'm going to look at this center and this coordinate A and see what distance is here. So if the distance between S and M is smaller than 12, then it lies within. If the distance is bigger, then it lies outside. Okay, so we shall say that our S, which is -11 and -2, our M, which is 3 and 0. Okay, so we're going to say that the distance SM will be the square root of 3 minus -11 squared plus 0 minus -2 squared. Guys, I apologize for not writing the formulas, okay? But you know what we're doing, eh? Good. So this is going to be 14 squared plus F4. Okay, 14 squared plus 4 gives me 200. Then square root of 200, okay? So 14 squared and that gives me 200. And then square root of 200 gives me 14,14. Okay, alternatively, somebody would just compare the 200 and then the square root of, because the new radius, we said it is 5 plus 7, which is 12, which is a 12. And then 12 squared gives us 144. So we can see that the 200 is greater than the 144. Alternatively, you can say this one is still greater than the 12. Therefore, the point S lies outside of the circle. Okay, so whichever format you want, you can compare it using the 200 and the 144, or compare it using the actual values. Okay, so that is how we would have gone about with question number 4.6. All right, 4.7 for 5 marks. This question. Let's see if it makes sense. Okay, because me looking at it, I'm gonna do still a longer approach to get to the answer, which might annoy some people. Eh? But let's give it a try. So if we have a line that is being drawn for us, and then that line is being called P.2. They want us to find the equation, or they want us to find the angle, okay? Which angle is ETM, this angle here. So the only thing I know, okay, is that this is a 5. If that is a 5, how do we find this angle here for 5 marks? Do we have the equation of CM? Because I'm thinking of finding the equation of CM, but is it gonna help? Because we know this is a 90, which is fine, but does it help here? Guys, help, please. If I use the okay, I could use the distance formula. So like I said, I'm just gonna go the longer route and try to establish, okay? So what I need is to get the coordinates of T. That's gonna make life a bit easier for me from my point of view, okay? So for me to get that, I need to find the gradient. Okay, let me just erase this and find the gradient of CM. Guys that worked out this thing in a shorter way, please help us. Ne? So that's gonna be -5 minus 0, which is a -5 over -7 minus 3, which gives us a positive 1/2, okay? So if it's positive 1/2, and then we use this point, it's gonna be y minus 0 is equal to 1/2 into x minus 3, meaning that our equation is 1/2 of x minus 3. Now let me solve this equation together with the equation of the circle for me to get these points of intersection. Does it make sense? It should make sense. That's okay. Let me give it a try that way. Let me give it a try. So we're saying that the equation of the circle is x minus 3 squared plus y squared gives us a 25. But our y is a half of x minus 3. No, it's a, yeah, it's a minus 3. Let me not, yes, minus 3. Okay, so where there is y, I'm going to put that, and then we see what happens. Okay, so x squared, no, let's say x minus 3 squared plus this is a half of x minus 3 squared gives us a 25. Okay, let's open it up. So that's x squared minus 6x plus 9 plus, that's going to be a quarter of x squared minus, that's going to be 3x because I multiply this and then times 2. And then this is going to be a plus 9 minus 25 becomes a 0. Okay, let me just collect my like terms quickly. So this becomes a 5 over 4 x squared. This and that is minus 9x. This and that is 18. What's 18 minus 25? That gives me negative 7 is equal to 0. Let's multiply through by 4. Yeah, which means it's 5x squared minus 36x minus 28 is 0. Okay, so if, let's say we are to solve this, this is lengthy. Let's hope we don't get lost with this. Okay, we're saying it's equal. So you can use the quadratic formula here to do the solving. Getting big answers here. Okay, so I'm getting something like a 7,9. I don't know what that is. Okay, and then I'm also getting a negative 0,71. Wow, why so big answers and funny answers? So the x of interest is this side, which is negative. But why is it a small value? Negative 0,71. Okay, so if it's a negative 0,71, let me punch it into that equation of the line. We said a half of x minus 3. So a half times 0,71 minus 3. Let's see. 0,71 minus 3, which is a negative 2,65. Okay. So let me get my, what do we call it? Because that is 5. This is also 5. Okay, so I'm saying, let me get my angle or my distance of ET. There's a shorter way, guys. No, man. For 5 marks. So ET, we're saying negative 0,71. This is a negative 2,65. Our E was negative 1 and 3. Okay. So the distance there is the square root of. Okay, so it's going to be x, which is negative 1 plus 0,71 squared plus 3 minus minus, so that's a plus. We square that. I'm having doubts with this answer of mine. So negative 1 plus 0,71 squared plus we're having a 3 plus 2,65 squared. That gives me a 5,66 units. Okay. So now if our triangle is in this format, this is 5,66, that's a 5, and that is also a 5. What do you think is going to be done? Because we know that this angle must be also the same as that. Something is off here, but it's fine, I'll find it out. So then I'm going to use the cosine rule to find this angle. So that is A, B, and C. We know that from the formula page, we know that the cos of A should be A squared. Okay. It's b squared plus c squared minus a squared over twice, something like that. Okay, let me just write it down the way it is on the formula page. Something is off here, but it's okay. So we're saying a squared, in this case, our a squared is equal to b squared minus, no, it's a plus, c squared minus 2bc cos of a, okay? So if this is our a, it's going to be 5 squared is equal to the 5,66 squared plus 5 squared minus 2 times 5,66 multiplied by 5. And then we're saying the cos of a. So this can cancel that. Okay, I'm going to move the 5,66 to that side. So 5,66 squared becomes 32,0356 negative is equal to 2 times 5,66 times 5, which becomes a 56,6 cos of A. It's also negative 56,6 over negative 56,6. My approach that I'm taking is worth 8 marks, not just 5, okay? When I simplify this, so I have a 32,0356. I'm dividing it by 56,6, which is a 0,566. And then I must find the arc cos of 0,566. Sure. So shift cos of 0,566. The answer I'm getting is a 55,53. Wow. What a lengthy approach. Okay, so alternatively, okay, the quicker way would have been to use the gradients. Okay, I think I'm getting back to my senses. For you to get the gradients. And how would that have worked? We know that this is a 5. This is also a 5. This angle will be the same as this angle here. Okay. If we can find this angle and find this angle, whatever is left, we need to subtract it from 180. Okay, then we divide it by 2. So what is the gradient here? Okay, let's just confirm, guys, and we see. I'm sorry for boring you guys with my long method, but we could also use this, okay? So the gradient of EM, remember we said it is 3 minus 0 over negative 1 minus 3, which is basically 3 over 4 negative. No? That's the first question we started with. And then the shift tan, okay? The arc tan of negative 3 over 4 gives us a negative 36, 87. So meaning that this answer here, or the angle here, is a 36,87. You could find also the outside part, no stress. Then if we find the gradient of this, okay, so gradient of CP, which is going to be 0 minus 5 over 3 minus 7, which we also found as what? A half. Okay, so the shift tan of a half gives us a 26,57. I'll have it as a 57 there. So meaning that this angle here is a 26,57. Even this one will be a 26,57. Then if you plus the 2, let's just confirm. Let's hope my answer with the longest method is correct. Okay, so we're saying that 26,57 plus the other one was 36,87. This we must subtract from 180. Then the answer we get, we divide by 2. Okay, so 180 minus the 26,57 plus the 36,87. Okay, I'm getting 116,56. We divide this by 2. Okay, I'm getting a 58. Hey, there's trouble in paradise. 58,28. This case, we had a 55. Okay, so I would vouch for the 58, guys. I would vouch for the 58 because it makes quite a lot of sense, because we know that this angle must be the same as that angle because those are angles that are opposite equal sides. Okay, then that is 4.7. Then question 5. They're telling us that the cos of theta is -5/13 within this. So if I'm to look at the quadrants, if this is negative, no, it's positive 180, this is a 360. Okay, where do we find cos to be negative within these two quadrants? Is the third quadrant. So I need to draw my sketch nicely and warmly. Okay, so cos is adjacent, which is a 5, of the hypotenuse, which is 13. So that's going to be a negative. Then I need to find my missing side using the theorem of Pythagoras. So 13 squared minus 5 squared. Okay, under square root. So when I do that, what do we end up with? So that's going to give us a 12 plus minus 12. But since the side is below the y-axis, so it's going to be a negative 12. So the triangle is complete. We go to the sine. So sine is opposite over hypotenuse. So -12/13, we square that, which is 144 divided by 169. Opposite over hypotenuse. So 169, no, 144 over 169. Okay, so that is that. And then tan 360 minus theta, which quadrant is this? That is the fourth quadrant. And the tan, because we know that the tan is negative in the fourth quadrant, so it's a negative tan theta, which is a negative. Our tan is opposite over adjacent, -12 over 5. That's going to be the answer. Because the negative and negative will be a positive, but this negative makes the answer more negative. And then the cos of theta minus 135. Let's expand using the compound angles. So that's going to be cos theta cos 135 plus the sine of theta and then the sine of 135. So we know that 135 is in quadrant 2, which will be 180 minus a 45. Okay. So we're going to reduce that, and it's going to be cos theta multiplied by the second quadrant. The cos is negative, so it's going to be negative cos 45. And then we are adding, okay, sine of theta and then the sine of 45. So we know that the cos of 45 is 1/√2. Is that correct? It's 1/√2. But then our theta from here, our cos theta is -5/13. Okay, -5/13. We're multiplying it by the -1/√2. Plus the sine is going to be opposite over hypotenuse, which is -12/13. We're multiplying it by 1/√2. Simplify this, that's going to be a 5/13√2. Okay. 5/13√2. And then I'm adding, no, I'm not adding, I'm subtracting. Okay, subtracting 12/13√2. So 7 minus 12, sorry, 5 minus 12, I'm going to get -7/13 square root of 2. So guys, that is what I'm getting as my final answer. Okay, so that is 5.1.3. Then 5.2. Let's see. 5.2. We've been told that if we have two cos, okay, this is 180 minus x multiplied by the sine of -x, and then we are dividing this by the 1 minus 2 cos squared 90 minus x. Okay, so to answer this question very fast, we need to do the reduction. There's 2. This is second quadrant, the cos is negative, okay? So that's going to be a negative cos x. And then that's also going to be a negative sine x over, this is a manipulated format of the double angle of cos. So if I introduce a negative, it's going to be 2 cos squared 90 minus x, okay, minus 1, something like that. Meaning that I'm just going to write it as negative cos twice of 90 minus x, something like that. Then I know that in the top, it's going to change to 2 cos x sine x over, this is going to be the cos of 180 minus 2x. Okay, so that is a positive. We have a negative down there. Then if we move on further, what we are observing is that we're just going to reduce this to a sine 2 theta or sine 2x. And then this cos is negative in the second quadrant, which is going to give us a positive. So negative and negative, we get a positive, so cos 2x. Simplify sine over cos, we get a tan 2x. Please, you'll help me identify this, because I'm not sure whether I left out a negative sign or because this negative here is what I'm carrying over to this point. But I already know that this and this is a positive. And if it's a 180 minus, then the negative will give me a positive. So that's what I have, guys. Let's confirm with the negative signs. Then 5.3. They want us to calculate the value of the following expression without necessarily getting a calculator. So what I'm going to do is when you look at this pattern, I'm going to look at the first and then the last, okay? So what is 92 plus 178? This is 178 and then 92. Okay, so 178 plus 92, we have a 270. Now this 270, if you're looking for the tan, okay, let's say we have the tan of 270. How many 45s are in 270? So 270 divided by 45, we have 6 of them. So it would be the same as tan of 6 times 45s. And we know that the tan of 45 is just a 1, okay? Look at 94 and 176. So 176 plus 94, we still get a 270. 96 and whatever comes there, which is supposedly 174, you get a 270. Meaning that if we multiply these ones together, we're just going to end up with an answer of just a 1. Okay, so 6.1, can we prove that this is the same as that? So what I'm going to do, I'll just use the compound angles and open that up. So it's 2 into, we have cos 45, cos x, minus sine 45, sine of x, but this must be squared. Okay, we're starting with the left-hand side. Then we can change this, or let's open it up further. Does it make sense? Let's change that 2 into 1 over root 2 cos of x minus 1 over root 2 sine of x. This is squared. We can't factorize yet. Let's open that. That's going to be a half cos squared x minus, we know that a half and 1 over root 2 and 1 over root 2, we get a half. When you multiply by 2, you end up with 1. So I'm just going to have cos x and then the sine of x. And then this last part will give me a half sine squared of x. Okay. And then when I open this up, I'll have a cos squared x. That's going to be negative 2 cos x sine x. And then that is a sine squared x. So I know that sine squared and cos squared will give me 1. And then I'm subtracting. This is a double angle of sine. So sine 2x, which is equal to the right-hand side. Okay, so that is question 6.1. 6.2, they want us to prove. We are given sine of this and that. Can we prove that it is equal to that? So still, we're going to do the same thing. The left-hand side first. Okay, so we have the sine of a minus b. minus the sine of, is it a minus first or a plus? It's a minus, and then we have a plus. This must give us 2 cos A sine B. Let's open up this. So you're going to have the sine of A cos of B minus sine of B cos of A, and then minus, okay, it's going to be sine of A cos of B plus sine of B cos of A. Let's open up here. Sine of A cos of B minus the sine of B cos of A. Open up this further, minus sine of A cos B minus sine of A cos of A. Okay, so this, let's see what we cancel out. We have sine A cos B positive, sine A cos B positive. So this cancels that. This is a sine B. Oh, why is this? This is a B and A. Okay, this sine B cos A, sine B cos A. So we're going to have a negative 2 cos A sine B, just the same thing, which is equal to the right-hand side. Okay, that we've proved. Then 6.2.3, we need to simplify. Now, the fact that this question is under what we're having here. So I'm going to let my 4x to be A minus B. And then this is going to be A plus B. So it's saying that A plus B is 4x. And then A minus B is a 6x. If I add these two equations, meaning that twice A is, are those numbers correct? We said 4 and 10. 4 and 10. Why am I saying 6? At the 2, we have 14x, which means that A is going to be a 7x. And then B is definitely going to be a 3x. Then what this means is that where I see the sine of 4x minus the sine of 10x, I'm just going to equate it to this whole thing and say that it's going to end up with negative 2, the cos of A, which is 7x, and then the sine of B, which is 3x. So that is what I would have done for that part. And then hence so determine the general solution, or the solution. They want the solution. Okay, so with the solution, we need to get the definite values of x between 0 and 30. So we're saying that where there is sine of x, okay, sine 4x minus sine of 10x should be equivalent to sine 3x. Okay, so let's replace this with that. So meaning that negative 2 cos 7x sine 3x is equivalent to the sine of 3x. Let's transpose and move it that side. Meaning that's a negative 2 cos 7x sine 3x minus the sine of 3x is equal to 0. Okay, take out the sine 3x. Let's take out the negative. We're going to be left with a negative 2 cos of 7x minus 1 is equal to 0. Okay, then either the sine 3x is 0, and we know that the reference angle shift cos of 0 is going to be 0. Then we're going to have also an 8 and probably 360, but we're focusing on 30. So the first solution is going to be 0 plus k times 360. K is an element of integers. Will that help us? 180 plus k times 360, k is an element of integers. So this may not really help. Gives me a 60. Okay, meaning that 7x is going to be a 60 plus k times 360. K is an element of integers. Divide through by 7. I'll just leave it as a 60 over, yeah, I can just change it. What is 60 divided by 7? That gives me 8,57 plus k times 360, k is an element of integers. So this is not going to help us because this is a quadrant 1 angle. We're focusing on quadrant 2, which is the 120. Okay, 7x is going to be a 120 plus k times 360, divide through by 7. So 120 divided by 7, we're getting 17,14 plus K. That is going to be 360 360 divided by 7, which gives us a 51,43. K is an element of integers. So if I replace K with 0, I'm going to have a 17,14. If I replace K with a negative, it's going to give me a negative, which I don't want. So this is more or less the solution that I'm getting, 17,14. Okay. Okay, so we have that 17,14, but we can also include the 0 one that we had here, because these equations were giving us a 0 plus K. So if K is a 0, which means 0 will be a solution. So the best solutions will be 0 and then 17,14. All right, so we move on to question number 7. We have two graphs, F and G, okay? Then they want us to write down the range of F. So one thing we need to know is that initially, okay, if we have a 2 cos, the range was supposed to be -2 and +2. But now since we are adding a 1, it's more like +1, then +1. So it's a 3 and then -1. So meaning that Y is between -1 and the +3. That is it 7.1? Yes, that is 7.1. Then 7.2, they want the period of G. So when you look at G, how many graphs can we see? This is one graph. Those are 2 graphs, okay, in a space of just 360, meaning that our period is just 180. So it takes us just 180 degrees to get a full graph. Alternatively, get the 360 divided by this coefficient of X. We must get the same thing. And then 7.3, they want us to get the values of X in the interval for which F is increasing. So F is increasing from this point up to this point here. It's just increasing. So we're going to say that -180 is less X and then it's less 0. So we do not put the equal signs because at -180 and at 0, the graph is typically just changing the direction. All right. Then we have next 7.4. Use the graphs, okay, to determine values of X in which G of X times F prime of X is less than 0. So F prime is more like the first derivative or the gradient, okay, in this case. So if I have this as a plus and this as a minus, or if I have this as a minus and that's a plus, so where do I find the G to be above while F is decreasing? Above and decreasing. So it's decreasing in this area and it's above somewhere here, okay? Then the other section is where do I find the G below while this one is increasing? So G is below here while the other one is decreasing. So we can see the region of interest, this one and this one. But we know that if this is -180, this is supposed to be, this is the graph of G, which one is equivalent to 0, which is a 90. So this is going to be like a -90, and then this is going to be like a +90. So the answers for that is going to be -90 is less X is less +90. So that is how we would have answered that 7.4.1. Then 7.4.2, where do we find the cos of X to be less or equal to -1/2? Now, we're looking at the graph of cos, which is the F. So if this is a 1, -1, F should be somewhere here. Okay, we just want the X values. So when you punch that into your calculator, the shift cos of -1/2 okay, it's going to give us a 120. So if that's a 120, even this side, it must be a negative 120. So the region of interest is below, okay, below a half. So this area and this area. So the answers for that will be negative 180 is less or equal to x, less or equal to negative 120. And then that side, we shall have a 120 is less or equal to x, less or equal to positive 180. So that is how I would have obtained that. Then 7.5, the graph of G is shifted 45 degrees to the right. Can we determine the new graph of H in a simplified form? So what this means, we shifting G. And G is what? The sine 2x. So it's going to be the sine of 2 into x minus 45. Change this or simplify that, we're going to have the sine of 2x minus 90. When you take out the negative, it's going to be 90 minus 2x. Then it's going to be negative sine of 90 minus 2x. This is a complementary angle, meaning that our h of x should be negative cos of 2x. And then this is what the question wanted for that part. All right, then question number 8, in the diagram, A, B, C lie in the same horizontal plane with AB being the same as AC. D is directly above A such that twice AD, okay? So in other words, if we have 2P is the same as a BC, then they want us to express AB in terms of P and Y. This is AP, but we're seeing that this is a right angle triangle, so we can use our trig ratios. And the ratio that combines adjacent and the opposite is the tan. So I would say that the tan of Y is equivalent to the opposite, which is P, over the adjacent, which is AB. Let's make AB the subject. AB is going to be P over the tan of Y. That is 8.1. Then 8.2, they're asking us to show that cos of X is equivalent to the tan of Y. So cos of X being equivalent to the tan of Y, meaning that I'm going to use AB, okay? Because I know that this is X, this must also be X, meaning that this entire thing should be the same as 180 minus 2X. So we're gonna say that BAC is 180 minus 2X, angles in a triangle, okay? So if I use BC over BAC, it should give me the same as AB over ACB. This is the sign. I'm using the sign rule, guys, forgive me. Okay, so our BC, they told us is twice what? P. So twice P over the sine of 180 minus 2X is equivalent to AB, which we found as a P over the tan of Y. You're dividing it by the sine of X. Okay, let's simplify this. So 2P is going to be equal to the sine 2X is equal to P over the tan of Y and then the sine of X. We can cancel this P and that P. We can do the cross multiplication, meaning that twice tan Y sine X is the same as sine 2X. Let's break down the sine 2X, which is going to be 2 sine X cos X. Okay, then from that point, we can see that the 2 cancels the 2. This sine X cancels the sine X. We have the tan Y being equal to the cos of X. That's what we had to do. Then 8.3, they want us to get the size of Y if X is 60. So meaning that the tan of Y is equal to the cos of 60. So tan Y gives us a half, okay? Then for us to get Y, it must be the arc tan. Okay, shift tan over half. Okay, so shift tan over half, which is 26, that's gonna be 57 degrees. Okay, so that is what I'm getting for 8.3. All right, then we move on to the last question 9, okay? Provide reasons for the statements. For question 9, and 10. Where is question 10? These people, where did they get this paper from? Same for question 9 and 10. Hey, did we miss out a question? But the page numbers are just in order. We move on. So in the diagram, DEF is drawn, line GH, okay, is parallel and intersects that, blah, blah, blah. They are parallel, perfect. DG is 2 to 5, okay? Then they want us to write down the ratio with reasons of HF to EF. So we know that if we have GF over DG must be the same as HF over EH, proportionality theorem. So that's also going to be the same as 2 over 5. Okay, so proportionality theorem, because these lines are parallel. Then they want us to find EH if EF is 21. So we're saying if the whole of this is a 21, can we find EH? So there are two ways of doing this, but let me choose the longer way, or the shorter way, sorry. So I'm going to say we're looking for EH. So I'll say 5 over this entire thing, which is a 7. So 5 over 7 is equal to our EH over 21. So EH becomes 5 over 7 times 21, and that becomes 15 centimeters. Okay, so that is how I would have approached it. Alternatively, people would have said this is X, and then that is 21 minus X, and then you solve it. You're still gonna end up with the same thing. Then write down the triangle, which is similar to FGH. So this big triangle, the Makul one, because this is common, this is the same as that, that is the same as that. So since they started with F, I will also start with F. G must go with D, and then H must go with E. So that is the triangle because of angles. Then hence, I'll calculate the value of GH over DE. GH over DE. So we're looking at the shorter side over the longer side. So we're comparing the triangles. Okay, so what I can do, I can look at this and say that if I have 2 over 7, okay, just looking at 2 divided by entire side, which is 7, should be equivalent to the shorter side, which is GH, over the longer side, which is DE. So the ratio that they want is 2 over 7. Okay, so that is 9.1.4. Then 9.2. Okay, the diagram POL is a diameter of a larger circle with center O. TMR is the diameter of the smaller circle with center M. The two circles intersect at L and R. PLK is a tangent, okay. The smaller circle, and TR is a tangent to the larger circle. Okay, the larger circle is having this tangent. Okay, and then the other one is having a tangent at this point. Then the question is, can we prove that LT is parallel to PR? LT, okay, let me just highlight this. LT is parallel to PR. Okay, so for us to have parallel lines, remember what we need to look out for. We need to look for corresponding angles, alternating angles, as well as the cointerior. But in this case, the cointerior will not apply. So let me use the tan code, because I know that this angle is going to be the same as that. Okay, so I'll say that L1 is the same as R1. Reason, that's a tan code. Then if I look at the bigger circle, we're saying that R1 is going to be the same as P. That's also a tan code theorem. And then we can say that since L1 is the same as P, therefore LR must be parallel, no, it's LT. Okay, so LT must be parallel to PR. Reason is the converse of the corresponding angles. So that is what we had to do with 9.2.1. And then 9.2.2, okay, 9.2.2, they are telling us that LORM is a cyclic chord. We must prove that L, O, R, and M. Okay, so if I connect this, so the only thing I need to do in this case is that I need to prove either this angle is the same as this, or this angle is the same as that. So whichever one that I prove, I should be able to get that. I don't know why they're giving it 5 marks. They're telling us that this line is LT, okay, is parallel to OM. So these lines are parallel. So if they are parallel, what do we see? So you're gonna say that this angle here is also gonna be the same as O1. Okay, so what I'm saying is that P, okay, P is the same as O1. Reason those are corresponding angles because OM is parallel to PR. Okay, so if this angle is the same as that, we can also see, or we proved that R1 was the same as P. Okay, but R1 is the same as P. We proved that earlier on. And if that is true, simply means that this angle, that since R1 is the same as O1, because we have this kind of a bow tie, okay? Therefore, L, O, R, M is a cyclic chord. And the reason is the converse of angles in the same segment. Angles in the same segment, or angles subtended the same whatever. So that is what we were supposed to do in that case. So guys, I'm not seeing question 10. Let's see with this, because the instructions said we have 10 questions, and then I'm not seeing that. So unfortunately, I'll have to stop at that and then wish you all guys the best. So in this paper, I can write it as yeah, 90. It's fairer compared to paper 1. All the best, guys, in your remaining examinations. I sign. Yes, hello. Welcome to yet another episode where we shall be looking at the proposed memorandum. Have 10 questions that need to be looked at. We have to answer all of them. So there's a special answer book, but it's not a big deal, that one. We shall see what we can do. Okay, so question number 1. They're telling us that the data below shows the marks of 10, no, out of 100 obtained by 16 learners in the maths test. And then they want us to calculate the mean mark for the test. So this is straightforward. We just need to get our calculators and do the right thing in the correct mode and get the answer straight away. So the answer I got for my mean, is 61.38. I'm gonna round off just 2 decimal places. Then my standard deviation that I'm having after punching out this information in the calculator is 19.63. Then 1.1.3, they want us to get the number of learners whose marks are outside 1 standard deviation of the mean. So what this means is that we need to determine the interval for within and outside, which can be obtained by getting the mean. We subtract the standard deviation, that will be the lower limit, and then the mean plus the standard deviation. That is going to be the upper limit. So if I get my 61,38, I subtract the 19,63, and then 61,38 plus the 19,63. I'm going to get an interval of 41,75, and then I'll end up with an interval of 81. So what this means is that I need to find out how many learners got marks below 41,5, and then how many learners got marks above 81, because it's 0.005. Okay, below 41, I'm having a 26, I'm having a 38, and I'm having a 32. So it's 3 learners below. And then above 81, I have the 94, I have the 83, and then I have the 92. So those are 3 also. So in total, I have 6 learners. So that's how 1.1.3 should be worked out. And then 1.2, the 16 learners referred to wrote the second test, which was test 2, and then the information was represented in a box and whisker to show the distribution. Okay, so test 1 is being represented using the first box and whisker, then test 2 is by the second. Describe the skewness for test 1. So when you talk about the skewness, we can see that the mean is next to the Q3. It's closer to the Q3 than the Q1. Okay, so in this case, the skewness is to the left. So we can say skewed to the left. Or alternatively, we can just say it's negatively skewed. Okay, the marks are negatively skewed. All right, then 1.2.2, which test was easier? Okay, so we can see that in as much as this data for the first test is skewed to the left, let's just do the interpretation that Q1 represents 25%, Q2 represents 50%, and then 75%. So I'm going to use the median, which is a 50%. We can see that 50% of the learners got above 62 for test 1. Okay, and 50% got below, so which means 8 learners got more than 62 marks. And then when I look at test 2, 8 learners got more than 66, either 66 or more than 66 of the marks. So the fact that more learners are getting higher marks in test 2, then we can draw a conclusion and say that test 2 was easier. Okay, reason is going to be 50% of the learners. Okay, 50% of the learners got 66 or higher. They got 66 or higher. This is 66%. Same happens to the last one. Okay, we can look at this. This is 25% of the learners. They have 75 marks or above. Here, the last 25% is having 84 and above, which is still the easier test. I mean, for something to be easy, most of the people should be able to get a lot of marks. Then 1.2.3, how many learners scored more than 84% in the second test? So where is the 84? 84 is at Q3. Okay, since they're talking about more than 84, which means it's the Q3 and above, okay, which represents a percentage of 25%. So I'll just say 25 over 100 multiplied by 16. This should give me 4 learners. Okay, so 4 learners got above 84. Okay, scored 84 or above. Okay, so that is question number 1. Question number 2. Question number 2 is fine. It's not that clear, but I'll deal with it. Okay. So in the survey, a group of people, we asked about the total distance they traveled from their homes in the last week of December of 2023 that are collected, represented in the table. Okay, there we go. And then the question 2.1.1. How many people participated in the survey? The question told us. No? Did they? No, they didn't. But when I look at the cumulative frequency, okay, the distance, the total distance traveled, or the last distance was 400. If I look at the question paper, it's a 400, and then this 400 is plotted against the 400. So remember, with the cumulative frequency, the last cumulative that you have will represent the total number of people. So I'm going to say that's 400. Then 2.1.2, determine the values of A and B. So A, remember when you're plotting a cumulative, we use the upper class intervals. So 100 goes with the 20, which is there. And then 150 will go with the 30, which is somewhere there. So that when you add 20 plus 30, you get a 50. So that's why we have this 50 there. So what's going to happen is that for me to get these frequencies, like maybe to find the value of A, I need to find, let me write this as a 20, this is as 50. Then for me to get this, I need to find the cumulative at 200. So at 200, I'm seeing the cumulative to be 100. Okay, 200 goes with 100. So if the cumulative here is 100, I have to just subtract these two. So 50 and 100 subtracted, I'm gonna get A as my 50. Same story will happen with a B. B is at 250. The cumulative at 250 is 200. Okay, so the difference between the two, they told me this is 200. The difference between 100 and 200 will give me my B, which is 100. So that is how we obtain that. And then 2.1.3, they want us to determine, they want us to estimate the number of people who traveled between 100 and 300 kilometers. So let me do this with this. I can use my ogive to determine that, or I can just complete this cumulative. Okay, so for 300, I'm seeing that's 280, and then this is 350, and then I'm having a 400. So when they talk about 100 kilometers and 300, so which means we're starting from here, they said up to 300, up to somewhere there, the interval in between. Okay, so if we do the subtraction, what's going to happen? Oh, we can probably look at it this way, that at 100 the cumulative was a 20. Okay, and then at 300, what is our cumulative? It is round about a 280 somewhere there. Okay, it's a 280. Then I just need to subtract these two. So I'll have my 280 minus 20, and then I end up with 260 learners, or 260 people. And then 2.1.4, if all the people who traveled more than 350 kilometers were removed from the survey, how will this affect the median? It's 1 mark. Now, median is a measure of central tendency. Okay. Now, let's take the people that traveled 350 and above to be outliers. Outliers do not affect the median. Removing any piece of data in most cases has nothing or no effect on the median, but it would affect the mean and probably the mode. Okay, so let's see. Let's just test this and see that if the people that traveled more than 350, so if we take this 50 away, which means our total is now gonna rest at 350. And what is a half of 350? That's gonna give me 175. So if I'm to locate 175, it would be somewhere there, which means my median would be around about that point. Then initially it was a 400, and a half of 400 is 200, which probably means that the median is round about 250. So the question is asking, if all the people who traveled more than 350 were removed from the survey, how would this affect the median? So the median would reduce. Okay, then 2.2, if the estimated mean of this data is given as 16,4, what is the value of t? So how do we determine the estimated mean? Remember, it's the summation of f of x over summation of f. So it's like you get the midpoint of these class intervals. So between 0 and 10, the midpoint is 5. That's going to be 15. It's going to be 25. And it's going to be 35. Then if we can multiply this x and the frequency, and then divide by the total frequency, then we shall be able to get our estimated mean. So I know that 13 plus 12 is 25 plus 4, which is a 29. So my total of the frequency is going to be 29, but plus a t. And then summation of fx, I'm going to have 13 times 5 plus the 15 times t plus the 25 times 12 plus the 35 times 4. Okay, and then I'm dividing this by the total of 29 plus t. This must be equated to 16,4. Okay, so I'll still have 16,4 is equal to the total I'm having is 505 plus 15t. I can multiply this side by the 29 plus t, so that I have a 29 plus t. I'll open this up. I'll have a 475,6 plus a 16,40 is equal to 505 plus 15t. I'll do the transposing. I have my 1,64. If I bring the 15 this side, I get 1, no, it's 1,4, not 1,64. It's 1,40 is equal to 29,4. Divide both sides by 1,4, t becomes a 21. So that's how the 4 marks would be obtained. So that is question number 2. Question number 3. In the diagram below, the equation of the line AD is given as this. Let me just rewrite this. So that is negative x over 2 plus 11 over 2. M is a midpoint of that line. Okay, the angles of inclination of AD and that are alpha and beta, E and F are the y-intercepts. All right. Okay, so that is the drawing. Then first question, they want us to get the coordinates of A and B. So you can use the midpoint formula. This is 3.1.1, whereby if I get A plus 3 divided by 2 must give me a 1. When I cross multiply, a plus 3 gives me a 2, which means a is -1, which is all right. And then b plus 4 divided by 2 must give me -1. Cross multiply, b plus 4 gives us -2, b is a -6. So the coordinates are -1 and -6. All right, then 3.2. So 3.2, they want us to get the gradient of BC. So with the gradient, we know that is the change in y over the change in x. Okay, I can just use c and m. So I can say 4 minus 1 over 3 minus 1, which gives me 5/2. 3.3, they want the theta to 1 decimal place. So for me to get theta, I can find the alpha and also determine the beta. So that my theta is going to be the same as alpha minus beta. But now, since we know the gradient of BC, which means we can determine our beta. So I'm going to say beta is the arctan of 5/2. Okay, let's see, shift tan of 5/2. That gives me 68,2. Then I need to find the alpha. With the alpha, I already know the equation of AD, which is this. And I've obtained the gradient to be -1/2. So I'm going to say the shift tan of -1/2. And then I have to plus 180 since it's the negative angle. So shift tan of -1/2. I'm getting -26,57. And then when I plus the 180, I end up with 153,4 degrees. So I have beta, I have theta, I have alpha. So which means my theta is 153,4 minus 68,2. Okay, that gives me 85,2 degrees. 153,4 minus 68,2. 85,2 degrees. Perfect. Then we move on. They want the equation of the line BC. So since we already have the gradient as 5/2, then we can determine the equation. So I'm going to say y minus y1 is equal to m into x minus x1. I'm going to use 1 and -1. So it's a y minus minus, which is a +1, is equal to m, which is 5/2 into x minus 1. Open that up and transpose. So that's going to be a 5/2x minus 5/2 minus 1. Okay. So the equation becomes 5/2x minus 7/2. Oh, it's 2,5x minus 3,5. So that is 3.4. Now 3.5, they want us to determine the area of CEF. Okay. So the area of this triangle here. So what I'm going to do, since this is a triangle and I can just use a half base height. So let me take this to be my base. And then if I drop, or if I do that, so that this is perpendicular, this distance here is 3 units. That's going to be my height. And this is going to be my base. Now from the equation that I just calculated, I'm seeing my y to be a 7/2 negative. But what is E from this equation? E is 11/2. So which means my base is going to be 11 over 2 plus 7 over 2. Okay, so 11 over 2 plus 7 over 2, that gives me 9 units. We're saying the height is 3, so the area is going to be a half base height, which is a half times 9 times 3. So that is 27 divided by 2. I get 13,5 units squared. Okay, so remember, we agreed that our base is going to be EF. So you can also write it as a half times EF, then multiplied by the height, which is now the 3. Okay, so that is 3.5. That is how question 3 would have been approached. All right, then question number 4. Question number 4. Diagram below shows a circle with center P, and the equation is given as such. The circle cuts the y-axis at R and S. RT is a tangent to the circle and cuts the x-axis at T, and then there's an angle theta as indicated. They want us to determine the coordinates of P as well as the radius. So what happens here is that we need to complete the squares. Okay, so I'll just open my 2 brackets is equal to 12. That's going to be x, that's y. So a half of -6 is -3, and then I must plus 3 squared. Okay, which gives me a 9. Then half of -4 is -2, so I must plus a 4 since it is 2 squared. Okay, so this is going to be the same as x minus 3 squared plus y minus 2 squared is equal to 25. So this means that P is a 3 and a 2, and then the radius is 5 units. So that's what was needed with 4.1. Then 4.2, can we show that R is 0 and 6? So we know that R is the y-intercept. So I can just get this equation. Okay, where there is x, I replace a 0. So I'm only going to be left with y squared minus 4y is equal to 12. Then I can transpose this. Y squared minus 4y minus 12 is 0. The two numbers are going to be, which factors are those? I think it's 6 and 2. 6 and 2. I'll make this a negative and a positive. Okay, so y is a 6 or y is -2. Okay, but we know that R is on the positive y, therefore R is going to be a 0 and 6. Okay, then 4.3, they want the equation of the tangent. Now when you're determining the equation of the tangent, if I draw a radius here, okay, we say this is a 3 and a 2. Now we've obtained this to be a 0 and 6. What I need to know is that the radius and the tangent are always perpendicular. And if that is true, I'll need to find the gradient of this radius, and then concurrently I'll get the gradient of the tangent. Okay, so I'll say gradient of the radius. You say change in y over change in x. So 6 minus 2 over 0 minus 3, which gives me 4 over 3 negative. And then the gradient of the tangent is going to be positive 3 over 4, because I know that gradient 1 times gradient 2 must give us -1, since the lines are perpendicular. Having obtained this as our gradient, we already know the y-intercept to be a 6. So y is going to be 3 over 4x plus a 6. So that's how I'm getting that equation of mine. Okay. Then they want us to get theta. Now theta Theta. How do we get theta? So what I can see is that, how am I going to approach this? Let me look at this theta as an exterior angle to this angle, which is a 90, we know this, and then this angle here, which I can call alpha. Okay, P.2. We need to get this angle first. And then we add the 90, then we have our theta. So since I have the gradient of this line, which is 3/4, I can start by finding the angle alpha. Okay, so I'm saying alpha will be the arctan of 3/4. Okay, shift tan of 3/4 is giving me 36,87. Now I just need to get the alpha plus the 90, which gives us the theta, because that is an exterior angle of a triangle. So which means it's 36,87 plus a 90. And that gives us 126,87 degrees. All right, so that is answered. Said it's 126,87. Then 4.5, they're telling us there's a vertical line that is drawn to the circle at Q, where A is greater than 0. Write down the coordinates of Q. Now, if it's a vertical line, which means it needs to be parallel to the y-axis. And if that line is indeed a tangent, which means it must touch the circle at one point. And this can only happen if we have this kind of thing. So I know that the distance from there up to there is 5 units, since the radius is 5. Okay. Now, if the x is 3 here, what is 3 plus 5? It's going to be 8. And then the y will be maintained as a 2. So the coordinates there are going to be 8 and 2. All right, then question 4.6. I've been asked, like, for which values of k will this equation be a secant to the circle? So currently it's a tangent. For it to be a secant, it must be cutting the circle at 2 points. Okay, with a tangent, it cuts the circle at 1 point. So the values have to be below 6. Okay, but then what if this line is shifted some number of units so that it is in this sort of direction? What will be the y value here? Because that's what we also need to know. Okay, so what I'm going to do, if this was my 3 and 2, this is my 0 and 6. Let me just extend this to this point. Okay, so that I have like 2 tangents that are parallel. Okay, so if I call this x and y, I'll have x plus 0 over 2 must give us that, which means x must be a 6 here. And then y plus 6 divided by 2 must give us a 2. When you cross multiply, y is a negative. Is it a negative 4? No, that's a 4 minus 6, which is a negative 2. Okay, so I have 3, then I have negative 2 for these 2 points. Okay, 3 and negative 2. Now let me try to get the equation, but with the same gradient, which is 3/4. So we're saying it's 3 and negative 2. Okay, I'm having 3 and negative 2 with a gradient of 3/4. So I'm going to say y minus 2 is equal to 3/4 into x minus 3. Then y plus 2 is equal to 3 over 4x minus 9 over 4. Move the 2 that side. It's 3 over 4x minus 9 over 4 minus 2, which is like 17 over 4. 3 over 4x minus 17 over 4. Let's just confirm that. Wait a minute. We said 9 over 4 plus a 2, 17 over 4. All right, perfect. So which means that this is a negative 17 over 4. Now, for as long as, remember, this k is a y-intercept, for which values of the y must that be a second? So if it starts exactly negative 17 over 4, it's a tangent. If it has exactly 6, it's also a tangent. So I'm going to say negative 17 over 4 must be less k, and then must also be less than 6. So in between these values, this line will be a secant. All right. Then 4.7. Another circle M with this equation is drawn. Will the circle touch, cut? Will it touch or cut, or will it neither touch nor cut P? Okay. So for the two circles, I know that originally with the equation that we had a 3, 2 as the center coordinates. Now here we're having negative 3 and negative 2. Okay, if we obtain them from there. And then the radius originally, radius of P was 5. Now radius of M is a 6. So I'll start by getting the sum of the radii, which is 5 plus 6, which gives me 11. Okay, and let me also get the distance PM using my distance formula. So I can say 3 minus minus 3 squared plus 2 minus minus 2 squared. Okay, distance formula, x minus x1 squared plus y minus y1 squared. Okay. When you do the substitution, that's going to be a 6 squared plus a 4 squared. 6 squared plus 4 squared, I'm getting 2 root 13. Let's just confirm that 6 squared plus 4 squared is 52, which is 2 root 13. Now, remember, if the two circles are touching, the distance we got here should be the same as this distance. Okay, that's if they are touching at one point. Both circles are tangents. Okay, now let me call this scenario number 1. Then scenario number 2. What if we have this kind of case? This is a P, this is M. We expect the distance PM to be bigger. Okay, distance PM must be bigger than the radius of that and then radius of that. This is 11. 2 root 13 is the same as 7,21. Okay, so we're seeing that the distance in between is bigger. Now the other scenario that we have where the circles are touching is whereby the distance PM is smaller than RP plus RM. So now with the scenario that we have, we're having PM to be smaller. Okay, so our PM is smaller compared to the total distance. So what's going to happen? We're going to draw a conclusion and say that the circles do touch. What were the options? They must be cutting. The circles touch or cut. Or will it neither touch nor cut? So it will touch or cut. Touch and cut, because they are cutting there at 2 points. All right, so that is question number 4. Then question number 5, the trigonometry. They want us to simplify this without a calculator. How long can it take for me to do this, and how much space do I need? So I know that tan negative is going to be the same as the negative tan x. The sine of 90 plus is going to give me the cos of x. Plus, I can expand this. It's an identity, which is 2 sine x cos x. I'm dividing it by 2 cos 36. 360 plus x is in the fourth quadrant, where cos is positive. So it's going to be 2 cos x. Then I go down and break this tan into sine and cos. It's going to be negative sine x over cos x. I'm multiplying by cos x. This 2 cancels that, this cos cancels that. I'm having just the sine x left. Now this cos is also going to cancel that, so that I have negative sine x plus a sine x. I'm getting a 0 as my answer. So marker location starts with just probably the reductions. 5.2. Given that the sine of 27 is predetermined without a calculator, each of the following. So let me just draw some bit of a sketch. Whenever I see such questions, I'll be required to have a sketch. This is a 27, that's a 90. This needs to be a 53. Does that make sense? Because I know, no, it's not 50, 63. It's a 63, so that I can have a 90 there. Okay, so they say the sine of 27, which is the opposite of a hypotenuse. Then I need to find this adjacent of mine, which must be 1 minus p squared under the root. All right, then let's answer this. Cos 27 is adjacent, which is going to be just 1 minus p squared. And then sine squared of 63. So I've flipped it around. I'm avoiding using the 90. So the sine of 63 is going to be the opposite over that. So it's going to be 1 minus p squared. And then everything is squared, which becomes 1 minus p squared. And then they want us to get the cos of 13,5. Let me just do this side. So cos of 13,5. We know that 13,5 is a half of 27. So if I take 27 to be my double angle, then 13,5 is going to be like the half angle, something of the sort. So if I use the double angle of cos, let me just use this. I'll have 2 cos squared theta minus 1. Okay. And then I'm going to take this to be my theta. 27 is going to be my 2 theta. So it's going to be cos 2 theta plus 1 over 2 under the square root, so that I get cos theta alone. So when I do the substitution, it's going to be cos 27 plus 1 over 2 under the square root. So we were told that the cos 27 is square root of 1 minus p squared. Okay, 1 minus p squared under the root sign. Yeah. We are adding a 1, then we're dividing by 2. So we can just leave it like that. We can leave it like that. This is the only approach that I'm seeing that I can use to obtain the cos theta alone. Okay, so that is 5.2. Then 5.3, we're given cos x plus sin x is k. Okay, cos x plus sin x is a k. What do they want us to simplify? Cos x minus 45. Okay, so just expand this using your compound angles. So that's going to be cos x cos 45 plus the sine x sine 45. I know that the cos of 45 is root 2 over 2, which is the same as 1 over root 2. So question never said without a calculator. So you can still use the calculator and still end up with the same thing. Okay, so take out the 1 over root 2. I'll have cos x plus sine x. We know that this is a k, so that's going to be k over root 2. Or you can have root 2 over 2 with a k. That's if you use the calculator straight away. Alright, so that is how that question would be done. Then 5.4, they want us to prove this identity. How do we prove this identity? So I can start from the left hand side because I'm seeing we have quite a lot of terms on the left hand side. Let me just jot it this side. It's cos 2 theta plus a 1 over sine 2 theta. Okay, then we are adding the tan theta. It must give us 1 over sine theta cos theta. Alright, so first things first, I need to break down the identities and see. So I know that cos 2 theta, I can break it down in terms of sine. So that's going to be 1 minus 2 sine squared theta plus a 1 over, this is going to be 2 sine theta cos theta plus, break that down, sine theta over cos theta. Sorry guys, we're starting from the left hand side. Okay, then you can simplify that or crisscross with the fractions. So that's going to be cos theta minus 2 sine squared theta cos theta plus a cos theta plus 2 sine squared theta cos theta over the 2 sine theta cos theta squared. Alternatively, you can find your LCM, which will be 2 sine theta cos theta. So when I look at this, now before I even go there, using something simple for me to cross out. So this is going to cancel with this last part because they are identical but the signs are opposite. So which means I'm left with 2 cos theta on top over 2 sine theta cos squared theta. The 2 cancels the 2, 1 cos cancels 1 cos, and then I'm left with 1 over sine theta cos theta, which is the right hand side. So that's how that proof was done or was meant to be done. Then 5.5, determine the general solution. Okay, so on the left it's just 1 trig ratio sine squared, which is fine, but on the right hand side I'm seeing a double angle there, and then a complementary angles as well. So I'm going to start by reducing that. So I have 4 sine squared theta is the same as sine 2 theta. Then I'm going to move everything to one side since I'm having one single trig ratio. So it's 4 sine squared theta minus, let me expand this to 2 sine theta cos theta is equal to 0. Then take out what is common, which is the 2 sine theta. I'll be left with sine theta minus, no, there is a 2 missing, so it's a 2 sine theta minus cos theta is equal to 0. Okay, so either 2 sine theta is a 0 or 2 sine theta minus cos theta is 0. So I'll just do that. Okay, so if I use the first approach, the reference angle that I have is going to be 0 and 180. So which means my theta is going to be 0 plus k times, so I'll just say k times 360. K is an element of integers. And then the other will be 180 plus k times 360. K is an element of integers. So these are the two solutions for the first part. Then with the second part, since I'm having sine and cos, I can create a tan. Okay, how do I create a tan? I'm going to divide both sides by 2 cos. Okay, over 2 cos over 2 cos. So this 2 cancels that, this cancels that. So I have the tan theta is equal to a half. And then my reference angle is going to be the shift tan over half, which is 26.57. Okay, tan is positive in quadrant 1 and in quadrant 3. So in quadrant number 1, just going to have 26.57 plus k times 180. Okay, I'm using 180 because the period of tan is 180. Then in quadrant number 3, I'll have 180 plus the 26. That's going to give me 206.57 plus k times 180. K is an element of integer. So that's how this question is answered. That's how I would approach it for 6 marks. All right, then question number 6. The tree graph. So in the diagram below, f of x is given as a sine bx, and then the g of x is for cos x. Within the interval of negative 180 and positive 180, the graph passes through these 2 points. And we have that they intersect at this point A and then B, blah, blah, blah. They want us to determine the value of A. So when you look at A, this A normally represents the amplitude of the graph. So F, we're seeing that it is reaching a maximum of 5 and it's reaching a minimum of negative 5. So automatically A becomes a 5 because it's the amplitude. Then when you look at B, this B affects the period of the graph. Okay, so how many degrees do we have here regardless of the negative sign and the positive? So we have 180 degrees on the left, 180 on the right, which is a total of 360. And we can see that this is a full graph of sine. So within 360, which is the period of sine, we have one graph. So B is a 1. Alternatively, since you have your A as a 5, you can use the point 90 and 5. So that 5 is equal to 5 sine 90b. Divide both sides by 5, and then you have 90b. Then find the shift sine of 1, which is going to be 90. We have 90b. So still a B is your 1. Okay, so 6.2. The graph G, okay, the focus is shifted 30 units to the right and 2 units vertically down to form H. What is H? So H of x is going to be 4 cos of x. Since it's to the right, I'll subtract. And since they are vertically down, I'll subtract also 2. So that is how the equation should be written. Then 6.4, 1 mark. No, 6.3, 1 mark. Calculate the minimum value of 8 over g of x in the interval. Okay. So currently the minimum and maximum is 4 and negative 4. Now what if we have 8 divided by 4 cos of x? By 4, 8 divided by 4 gives us x, which is going to be 2 cos of x, which means the minimum value is going to be, is it a 2 or a negative 2? So I'm going to take it to be a 2, since I'm having the 2 there. So minimum value is a 2 for me. 6.4. If A is given as this, they want us to determine the coordinates of B. Now we're seeing that A is negative 141,34, which is in quadrant number 3. So if I plus 180 with that, negative 141,34 plus 180 I'm getting 38,66, which must be this, is in between 30 and 60. Okay, so 38,66. Y values just have to be the same. This is negative 3,12, then that has to be a positive 3,12. Then 6.5, for which values of k will this have no real solutions? Okay. Now for the graph of f to have no real solutions, it shouldn't touch the x-axis. Now since the minimum is negative 5, if we choose to increase this graph or to shift it 5 units upwards, okay, it will be now touching one point there, and we won't have any other point between this interval. Okay, so we either need to shift it more than 5 units upwards, or we need to drop it more than 5 units downwards. So I'm going to say that k has to be greater than what? Than 5 units, or k must be less than 5 units. Am I contradicting myself? Does that make sense? That k has to be greater than 5. Okay, so if that is true, which means we are shifting it more units upwards. Now let me just call it negative 5. Yeah. Okay, then 6.6, use the graph to determine values of x in the interval for which f is less than g. So where do we find the graph of f to be below g? From this point up to this point, that's where f is below. Okay, so I'm going to say negative 141, 34 is less x and is less 38,66. And then where do we find f prime? So we know that f prime simply represents the gradient. So we want the gradient of f to be either increasing as the graph is also above the x, or we want the gradient to be decreasing as the graph is also below. So that scenario can only be seen if I do this graph is above as this one is below. Okay, so I don't know which scenario. Oh, we're talking about gradient, by the way, gradient. So let me look at the first scenario. Where do we find the gradient to be increasing? Well, this one is above the x-axis. G, where is G above the x-axis? Between this and this. It's okay, I can still use this point as well. Okay, so F is increasing between this point, and G is above between still this point and this point. G is going to be above between the negative 90 and the positive 90, and F is also increasing. So I'm going to say negative 90, first of all, is less or equal to x is less or equal to a positive 90. Then, where do I find the other scenario? The graph to be decreasing as G is below. So G is below after 90. Okay. And this graph is decreasing also. Okay. So this one is decreasing, and this is also below. So even this one, negative 180 to 90. So negative 180 less or equal to x, less or equal to negative 90. Also 90 is less or equal to x, less or equal to 180. So in other words, the whole domain satisfies this whole thing. All right, then question number 7. The diagram below TQR represents 3 points in the horizontal plane. Okay, with the vertical flagpole. The angle of elevation of the top of the pole from R is theta. Okay, TQTR is Y, TQR is X, and that is alpha. Express theta in terms of alpha, show that that is that. So what I can see is that if this is a Y, this one is also a Y, which means this entire angle here is also going to be alpha. So I have alpha plus theta must give us 180. So theta is going to be alpha minus, no, theta is going to be 180 minus 2 alpha. Now, if I introduce sine on both sides, I will have sine theta is equal to the sine of 180 minus 2 alpha. When I reduce this, it's going to give me sine 2 alpha. So that is the same as that. So that's what they wanted. So this is the first statement that they wanted, because we are expressing theta in terms of alpha. And then we are showing that by introducing the sine on either sides. Then 7.2. Hence, so from what we just obtained, can we proceed and prove that PR is that? This PR is this hypotenuse of this triangle. So I can use what we call this. Let me use the cosine ratio and say the cos of theta using this triangle PQR. It's gonna be X over PR. Make PR the subject, X over cos of theta. But this expression does not have any X involved. So what I'm going to do, I'll go back to this triangle of ours and use the sine rule and see Y over the sine of alpha is the same as X over the sine of theta. And then I'll make X the subject, which is going to be Y sine theta over sine alpha. But we say that sine theta is the same as sine 2 alpha. So which means it's going to be Y sine 2 alpha over sine alpha. And then simplify this by expanding that double angle. So that's going to be Y, let me just say Y times 2 sine alpha cos alpha over the sine of alpha. So this cancels that. So which means my X is 2Y cos alpha. And then just substitute that on top where there is P. So in the PR. So PR is going to be 2Y cos alpha divided by the cos theta. I think that's what they have. Perfect. Then 7.3, if that is that and that, calculate the area of TQR. TQR. So we can just use the area rule. Which angle do I have? I have alpha. So I'm going to say area is going to be a half times TQ multiplied by QR, and then the sine of alpha. So a half, my TQ is Y, which is 15. My QR is X, which is a 20. And then the sine of 49. Okay, so when I punch this into my calculator, it's a half multiplied by 15 multiplied by 20 sine of 49. Getting 113,21. This is going to be units squared. So that is 7.3. Then that's the end of question 7. Question 8, Euclidean. The diagram below, O is the center, beautiful. A, B, D are points on the circle. BC is a tangent, okay. And DBC is a 22,5, okay. The chord showed AD. AD, where are you, AD? Here I am. Is produced such that these two sides are equal. Okay. 8.1, they want us to get the size of A1. So A1 is going to be 22,5. Reason, that's going to be the tan chord theorem, because this is a tangent, and then we're seeing that this is a chord. Angle in between the tan and chord and blah, blah, blah. So if this is a 22,5, they want us to get D1. So for you to get D1, you can start by telling us that C. Okay, C is also 22,5. Angles opposite, equal sides. Okay, which means that D1 is going to be a 45. That's going to be exterior angle of triangle BCD. We're saying this is a 22,5, but this D1 is an exterior, which must be a sum of these two. Okay, that's a 45. Then they want us to get B2. So when I see this is a radius, okay, so if that's a radius, it simply means that the tangent and the radius must be perpendicular to each other. So this B2 and this 22,5 should be complementary angles, or they are complementary angles. So what is 90 minus 22,5? What do we get? 90 minus 22,5, I'm getting a 67,5 on my calculator. Okay, so that's going to be 67,5. Reason, the tan perpendicular, the radius. Okay, so this is 67,5, the small one. Then they want us to get O1. This is an angle at the center, O1. But D1 is at the circumference. So the angle at the center is always 2 times. So O1 is going to be 90. Angle at the center must be twice angle at the circumference. All right, then 8.2. 8.2. Can we prove that OA is parallel to CB? OA is parallel to CB. Now, when you're proving parallel lines, you just have to deal with the properties of parallel lines. That's the alternate, corresponding, and co-interior. Okay. So we've seen that this is a 90 from the previous statement that we wrote. But we know that even this whole B is a 90. So we can say that these two angles are alternate. So you're going to say that CBO is the same as BOA. We've proved from above. Therefore, OA is parallel to CB. Reason, the converse of alternate angles. The converse of alternate angles. Okay, then 8.3, it's further given that the radius is 12. The radius is 12. This is a 12. This is also a 12, but we know that this is 90. They want us to get the length of BC. BC. All right, so before we even go, anyway, let's do this. As I thought, let me get BA first. Okay. Using the Pythagoras. So that's going to be square root of 12 squared plus another 12 squared, which gives me 12 root 2. That's what I'm getting, guys. 12 squared plus 12 squared, getting 12 root 2. Okay, so use the Pythagoras. Then we can you can write the Pythagoras theorem and tell us that the AB is going to be the square root of OB squared plus the OA squared. It's fine. Then Pythagoras, then do that. Then what I'm seeing is that CB is the same as AB, because if this is a 22,5, even this is a 22,5. Okay, so we can come down and say that since A1 is the same as C, which is 22,5, it simply means that AB must be the same as BC, because those are going to be sides that are opposite, equal angles. Therefore, our BC is also going to be 12 root 2, or you can write it as a decimal to be 16,97 units. Okay, then question number 9. The diagram below, we have a diameter BE of the circle O is produced to D. DA is a tangent to the circle, and CD is perpendicular to BA. AC and BC cut the circuit E and F. Beautiful. OF and EF are drawn. Okay. Just 3 parts. Okay. You can do this. 9.1. They want us to prove reasons why ABCD is a cyclic chord. I'm seeing a 90 here, and I'm seeing some bow tie, butterfly. So I'm going to say that A2 is a 90-degree angle in a semicircle, because this is a diameter, so this must be 90. And now the bow tie is matching, because I'm seeing a 90 and I'm seeing a 90. So go down and tell us that since A2 is the same as D2, therefore ABCD is a cyclic chord. And the reason is going to be the converse of angles in the same segment or angles subtended by the same chord. Angles in the same segment or angles subtended by the same chord. So that is 9.1. 9.2, we need to give reasons why AD bisects this angle B, ABC. So which means this angle must be the same as this angle according to the statement. But what's going to be the reason? How do we get there? So I can start by saying that since I've proved that this is a cyclic chord, which means there is some sort of a circle somewhere. It simply means that this angle A3 is going to be the same as B2 because of the bow tie. Angles in the same segment or angles subtended by the same arc. If that is true, I'm also seeing that A3 is the same as B1. That is the tan chord theorem, because this is a tangent and then this is a chord. It must be the same as that. So since A3 is B2, A3 is B1, therefore B1 is the same as B2, hence BD bisects ABC. Okay, that is that. And then lastly, can we prove there with reasons that EC is a tangent to the circle OEF. So if we draw a circle here, they want us to prove that EC is a tangent. Now, it's going to be a bit tough for me to prove from this perspective of E3. But rather what I'm going to do, since I know that EC is the same line as AEC, let me take it from this approach and focus on E1. So I need to prove that E1 is the same as F2. Then I use the tan code. If that is true, then EC is a tangent. Okay, so what we do? So what I'm going to start by saying that we know that F2 is the same as E2. Angles opposite, equal sides. Okay, because this is a radius, this is also a radius to the circle. So this angle is the same as that. Then if that is true, we were told about the 90 and the bisections. Let me look for E2. Let me use this triangle BEF and find B2. So since this is a 90 also, F1 and 2 is a 90 angle in a semicircle. F1 plus F2 is a 90 angle in a semicircle. Or you can tell us opposite angles of a cyclic quad, which means that E2 is going to be 90 minus B1. Is it B1 or B2? It's going to be B2, but we say B2 is the same as B1. Okay. Then I can also find E1. E1 is also going to be a 90 minus a B1. This will be angles in a triangle, or angle sum of a triangle. Now, since initially we say that this angle here, the 90 minus B1, is the same as this one, 90 minus B1. And now we found this to also be 90 minus B1. So there is a tan chord kind of correlation. And therefore, I'll say AEC is a tangent, okay, because of the converse of the tan chord. Question wanted EC. So there's no point of putting AEC. But since it's the same line, so this is still continuous. Okay, so that is question number 9. Number 10. Question number 10. They want us to prove the proportionality theorem with similar triangles. Okay, so what I'm going to do, since we've already been given that the lines are parallel and all of that, I'll start by saying that B is the same as ADE. Those are corresponding angles because DE is parallel to BC. Then I'm saying C is the same as AED. Okay, it's the same reason, corresponding angles, because DE is parallel to BC. Then we can see that the angle A is common. Okay, A is common. Therefore, or which implies that ADE is similar to ABC because of the angles. Okay, now there is a link between similar triangles and then the proportionality theorem. Okay, so if I focus on the similar triangles first, since I've proved that the triangles are similar, it's the same as me having AD, okay, divided by AB, which must give me the same ratio as AE divided by AC, which must give us the same ratio as DE divided by BC. Okay, then I can go down and say that using the proportionality, proportionality theorem of similar triangles or with similar triangles, then I can just draw the conclusion and say that my AD over DB over DB should be the same as AE over EC. There we go. That's 10.1. And then 10.2 is the application. So in the diagram below, D is the center of the circle. A, B, and AE are tangents. Okay, so these tangents are coming from a common point, which is A. So one thing I know is that the two tangents must be equal. Then at B and then at E, respectively, the diameter BG, okay, is produced to meet tangent at E, so at C. DG is the same as that. They have indicated that for us. And then these lines are parallel. All right. Find with reasons the ratio of AC over FC. AC over FC. So from the proportionality theorem, we know that if we have our AC over FC, where am I writing it? Side. Let me just do it to this side. Okay. So AC over FC is going to be the same as BC over CD. Now, we know that this is a radius. Let me just call it R or X or any letter. Let me just call it R. So if this is R, this is also R, but this is the same as that, which is also R. So which means my BC is going to be 3 times of R, which means it's 3R. Over the CD. CD is twice of R. The R's will cancel, which means the ratio is 3 over 2. Then can we prove with reasons why ABC, the big triangle, is similar to DEC? So number one, we can say that B, this angle, is going to be the same as B1. B is the same as E1, which is 90. The reason is going to be the tangent must always be perpendicular to the radius. Okay, that is statement number one. Then we can also see that which angle are they? Which angles are they? So this is a 90 and the 90. ABC. Okay, C is common to both of them, which means that D3 must be the same as A. And the reason is the remaining angles of the triangle. So therefore, ABC is similar to DEC. Reason is angle, angle, and angle. So remember to say C is common to both triangles, the small one and the big one. Then E1 is the same as B, which is a 90 turn radius. Then automatically that must be the remaining triangles. Okay, then if that is true, then we need to prove that DE squared is the same as this. Okay, let me see what I'm going to do. So if I'm to sketch my two triangles anyhow, calling this A, B, and C, and then I have the triangle. We said A is going with the D3, B is going with B1, and then C is common. Then let me apply my ratios for the similar triangles. So what I can see is that if I need a side that is having DE or ED, which is this. So I'll say AB over DE. Which other side? We have EC, which means I need to use this side. BC over CE. Okay. I'm gonna tell us that from similar triangles, or you tell us that this triangle is similar to that. Someone is asking for the reason on the 10.2.1. It's gonna be the proportionality theorem, guys, because FD is parallel to AB. Okay, no, it's fine. Let's move on. So if I do this, remember my interest is the DE. I can make DE the subject, which is going to be AB times the CE over EC. I cross multiply. But from the statement that we were given, we only have the EC and we have one DE there. The rest of the terms are not there. So let's play around and see. Okay. AB. Let's see what is our AB. We're seeing that our AB is the tangent on a common point, which is the same as this. So we can say that AB is the same as AE. Okay. So AB is the same as AE. We say tangents from a common point. So where there is AB, I can just replace it with A. Problem sorted. Now problem is gonna be the, let me do that. So AE multiplied by CE over BC. Okay, then how does BC relate with DE? Maybe I can get another DE from there. Okay, so I can see that DE is a radius. But what? BC. BC is 3 times of the radius. So since this is R, I'm just gonna say that BC is 3 times of ED from that information. So that's gonna be DE is equal to AE multiplied by CE over 3 DE. Multiply both sides by DE. So times DE multiplied by DE. So this cancels that, which means DE squared is the same as AE multiplied by CE over 3. Okay, so that is 10.2.3. Then 10.2.4. They want us to get the ratio of the area. Don't have space, but I'll squeeze it here. Okay, so our focus is area of FDC. FDC. So since this line makes 90 degrees, so it's perpendicular to this line, so I'm gonna take this to be my base for both triangles since I need ABC and FDC. So I'll say it's a half multiplied by the base, which is gonna be now FC, multiplied by the height, which is ED, divided by a half. I'm still gonna take AC to be my base, which is AC, multiplied by the height, which is still the same height, which is ED. So what I can see is that the heights are cancelling. The ED and the ED are cancelling. The half and a half is cancelling. I'm left with FC over AC. Originally in 10.2.1, I had the ratio of AC over FC. Now I'm flipping it around. So the ratio is just going to be 2 over 3. So guys, that's what was expected of this paper. And I wish you all the best, and I hope we got most of the marks. All right, for me, I'll stop there and I'll sign out till we meet again. Bye-bye. September 2025. Okay, so under this paper, all the topics will be tested as per the examination guideline. Okay, and some of the topics basically that are covered in paper 2, we know that we're going to have statistics. Okay, statistics, sample cohort data handling. Okay, so usually it's 2 questions in that case, but overall the mark allocation should be plus minus 20 combined. Okay, whereby the first question normally talks about the ungrouped data. Okay, and then the second question talks about the bivariant type of data with the correlations and all those things. Then topic number 2 that we can think of in paper 2 is analytical geometry. Okay, so analytical geometry. Number 3, we have what we call the trigonometry. And then after the trigonometry, then we can have our Euclidean geometry. So basically, these 4 topics are the backbones of paper 2. Okay, so please just follow with me as we go over this paper together. Okay, so bit by bit, I'll try to be as brief as I can, but also explain some other details, okay, just when need arises. So let's use this as our sample paper. So in this case, we have 10 questions that we're gonna be dealing with, okay? And the first question is statistics, as always. First 2 questions will always be statistics. So they're telling us that a group of learners wrote a standardized mathematics test that was recorded out of 60 marks, okay? And then the results were represented within the table. So learners that got between 0 to 10, we have a cumulative. We don't know how many they are. 10 to 20 up until 60. So we've been given the cumulatives, and then 1.1 wants us to complete the table, meaning that we need to fill in the frequency column. And so what we can notice, or what we know, is that the first cumulative must always be the first frequency. Okay, and then for us to get the next frequency, we just have to do the subtraction. So 60 minus 20, which is a 14. Then 120 minus 60, which is going to give us a 60. Then 170 minus 120, that gives us 50. Then 190 minus 170, that's a 20. And then 200 minus 190, just 10. Okay, so these represent our frequency values. Okay, so 20, 40, 60, 50, 20, and 10. Now, if we want the total here, it should be equivalent to the last cumulative, which will be 200. So how many learners wrote the test? It's basically 200. So even without adding all of this, the last cumulative value should be able to give us that answer of ours. Now they want us to draw a cumulative frequency graph. Okay, I don't have that page, but I'll try to just put it down here, just for the purpose of people having an idea, okay? So with the intervals, we have 0 up to 60. So I can use 10. So 0, that's a 10, 20, a 30, a 40, a 50, and maybe a 60. And then I know the graph is a bit skewed, but just bear with me. Then the biggest frequency that I have is 200. 200. Let me use intervals of 20. Will 20 make sense? No. Let me use 50. And so that's a 50. That's gonna be 100, 150, and 200. Okay, so when you're plotting or when you're graphing a cumulative, we normally use the upper class intervals together with the cumulative frequency. So 10 is gonna go with the 20. Okay, 10, we know 20 could be somewhere there. And then 20 is gonna go with a 60. As per our cumulative, 60 should be slightly above 15. And then 30 is gonna go with a 120. So 120, just somewhere there. I want to believe so. And then 40 is gonna go with a 170. 170 is just slightly close to halfway the mark. Oops, why does it look like it's gonna be a straight line? Okay, then 50 is going with 190. So 50 is a 190, and then 60 becomes the 200. Okay, then connect this with your points with your freehand, and then you need to extend the graph to the mean. So the starting point, that's where the graph must start from. It needs to be footed. Okay. Okay, so that is the cumulative graph that we would have in that sort of scenario. Then how many learners scored at least 20 out of 60? So when they say at least, meaning that the minimum is 20, but the maximum can be 60. So what we do in that case? So we know that between 10 up to a maximum of 20, we have 60 learners, okay, at that point. The cumulative of between 0 to up to 20 is 60, meaning that those that obtained either 20 or slightly above 20 out of 60 should be all these ones, okay? So what I can do, I can just say my 200 minus 60, which gives me 140. Because even if I were to get it from the graph itself, okay, if I'm to read off the 20, I'm gonna get a 60 here, okay? And then I have to subtract that from that, and then I get my answer. Then determine the mean estimate. So the mean for the group data, some people prefer to get the midpoint here and then create a table. Yes, it's allowed, but it's a bit lengthy. How do we get the midpoint? You add 0 plus 10 divided by 2, that's going to be a 5. Then 10 plus 20 is a 30 divided by 2, that's a 15. This is going to be a 25. That's going to be a 35. That's going to be a 45. This is going to be a 55. Then this multiplied by the frequency, okay? Because we know that the estimated mean will be given as the summation of f of x over the summation of f, whereby we know that our f is already at 200. So the f of x is what we need to add up. So meaning if I get those midpoints together with the frequencies, remember the first one is a 5 multiplied by 20. Next one is a 15 with a 40. And then we have a 25. We're going to multiply it with 60. And then a 35 by 50. Then we're going to have a 45 multiplied by 45. We say it's going to be multiplied by 20. Okay. And then the 55 with 10. And then the answer we get, divide this by a total of 200. So I believe this is the easiest. Just determine your midpoints and represent them in this format. So when I plus up everything that is on the top, I'm getting 5.4. Divide by 200, and then we get an answer of 27. Please, you can cross-check with your calculator if I'm not telling lies. No? All right, so that is question number 1. Now, this question 1 could also come in terms of, let's say, the box and whiskers, the quartiles, the standard deviation, the mean, the mode, and all those other aspects, okay? So let's just prepare and be ready for whatever might be brought. Question number 2, a group of 9 students attended a course in statistics, okay, on Saturdays of a period of 10 months. And then the number of Saturdays on which the student was absent was recorded below on the scatter plot was drawn, okay? So if the student was absent for no day, we get a 96%. For 1 day, it's a 91. So we literally seeing that the more the absenteeism, the lower the marks. Okay, so they drew the box and they drew the scatter plot for us, and then they want us to determine the equation of least square regression. So what this question tests is basically, are you able to use a calculator, okay, when you're punching these values? Remember, it's the mod, and then go look for 2VAR, okay? And then you start entering these numbers. So start with the first one, which will represent the X, and then this will represent the Y. Punch in all the numbers, and then you cancel out, you clear all, and then you go back and find whatever. So if I follow my calculator, I'm getting my A to be a 90,375. I think the next episode we should come with a live calculator and show how we're getting these answers. Okay, the now B is a negative 4,875. Okay, but the question wants the equation, meaning that our Y should be a 90,3. You can round it off to 2 decimals, okay, minus 4,88x. So that is the line that they want. And then for us to get the correlation coefficient, so remember this can also be obtained from the calculator. So my correlation is a negative 0,8. Okay, we can add a 0 since we want everything to be rounded to decimals. Then comment on the strength. So whenever you're commenting on the strength, number one, you need to talk about the weakness and the strength, meaning that is it weak, is it strong, is it moderate? And then from there, we need to go on and talk about the direction. Okay. Okay, so we're seeing that a 0,8 is really a strong correlation or relationship, okay? So what we can say, since it's a negative, we can say it's a negative strong correlation or relationship. Okay, so strong, negative, whichever way you want to put it, no problem. Then 2.4, if a student scored 52%, can we predict the number of days that the student was absent? Now, remember, the percentage is the Y, okay? X is the number of days that the learner was absent. So let's use our equation, okay? And say where there is Y, we're going to say 52 is equal to 90,38 minus 4,88x. So start by moving the 90 to that side, okay? So it's going to be 52 minus 90,38 is equivalent to negative 4,88x. Divide both sides by negative 4,88. I mean, this can be done just on the calculator without showing all these steps. So the answer we are getting is 7,86. But then predict the number of days. So since it's days that are countable, okay, so this is approximately 8 days. Okay, the learner was approximately absent for 8 days. But, okay, then is the answer calculated in 2.4 reliable? Okay. What would be our response in this case? The response would be that it's a yes. Okay. Why is it a yes? Because the correlation is negative, okay? Because of the negative correlation, meaning that if you're absent for more days, even the possible mark for you that you obtain is basically smaller. We are saying that for 7 days, the learner got a 56. Now we're saying if the learner is absent for 8 days, it should be a 52, which means it's following the trend, meaning that it is very reliable. All right, then we move on to question number 3, which is the analytical. In the diagram below, A is negative 26, B is 8, negative 4, C is negative 6K. Are 3 points in the Cartesian plane with M that is lying there. They are telling us that AM is the same as BM, meaning that this point is a midpoint. Ne? Let's baptize it there. Then also AB. Where's AB? All of this is the same as BC. So this is the same as that. Okay, then D is a point on the y-intercept of the line AB, okay? Thank you very much. Then they want us to get the coordinates of M. Now, since we say that M is the midpoint, meaning that we're gonna need to use the midpoint formula. And that formula tells us that x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, so N can be our x1, so just get -2 plus 8 divided by 2, and then 6 plus -4 divided by 2. When we simplify that, that's going to be a 6 over 2, which is a 3. Simplify this, a 2 over 2, which is a 1, meaning that M is basically 3 and 1. 3 and 1 will become our answer. And then 3.2, they want us to get the coordinates or the value of K. How many marks? 6 marks. 6 marks. What are we going to do? Are we going to use the distance formula? I think that's going to be the only reasonable thing, since they told us that AB is the same as BC. So we can get the distance of AB and then equate it to the distance. Won't this give us a quadratic? But there's nothing we can do since we're focusing on the 6 marks. So distance formula is going to be x2 minus x1 squared plus y2 minus y1. Everything is squared. Okay, when I do the substitution, that's going to be 8 minus -2, which is going to be like a 10 squared. And then -4 minus 6, which is also -10 squared. Okay, so that's 100 and 100, which gives us 200. Ne? And the root sign, which is the same as 10 root 2, not 2 root 10. It's 10 square root of 2 units. Ne? So that is our AB. Then we're going to equate this to the distance, since we already have our coordinates as 3, 1. Okay, so why don't I just write it on this other side? Okay, so we're saying that M is 3, 1. And then this point is -6K. Is that a C? Perfect. Okay, so we're saying that MC, but it's not MC. We're focusing on BC. What's our B? It's 8, -4. Okay, so BC, which is the same as AB, should be the same as, okay, we're going to have 8 minus -6 squared plus -4 minus K squared. You can arrange it in whichever way you find convenience. Okay. And then we said we're going to equate this to 10 square root of 10 square root of 2. Let's open up there. You're going to have 8 and 6, which is a 14. Is that a 14? Did I do anything wrong? Let's just erase this out and see. So this is 8 -4. Okay, so it's 8 -4 -6 and a K. Okay, when we do the substitutions, okay, when we do the substitutions, that's gonna be 14 squared plus, that's gonna be 16 plus, that's gonna be 8K plus K squared. This must be equal to 10 square root of 2. Okay, I'm just opening this square bracket. Then I need to square both sides to get rid of the root sign. So 14 squared is going to be a 196 plus 16 plus 8K plus a K squared must give me 100 times 2, which is 200. Let's move everything to one side so that we have a K squared plus 8k. Okay. Then that's going to be a -4 plus this. I think it's just going to be a 12. Né? Because I'm trying to look at 200. I'm taking away 196, which is a 4. Okay. 16 minus 4, which gives me a 12, is equal to 0. And then I need to factorize this. The two numbers of interest will be 6 and 2. So k plus 6, k plus 2. So either k is a -6 or k is a -2. K is a -6, k is a -2. So we need to confirm and see. We know that this y value is a -4 here. There is no way this k can be -2 below the -4, meaning that our k needs to be a -6. It cannot be this -2. All right, so we've decided and we got those 5 marks, then hence or otherwise they want us to get the equation of Cm if k is a -6. Thank you for confirming that. Okay, the equation, so we saw that C is that M is 3 and 1. Okay, M is 3 and 1, and then C is -6 and -6. Okay. Okay, so they want the equation. So whenever we get the equation, number one, we need to find the gradient, okay, change in y over the change in x. So we're gonna say 1 minus -6 over 3 minus -6. Meaning that we're gonna have a 7 over 9. Okay, that's the gradient. Yeah, I know it's weird, but it's fine. Then let's use this point. Okay, some people prefer to use the mx plus c. They look for the c. I prefer to use y minus y1 is equal to m into x minus x1. I'm going to use the point m. So it's saying y minus 1 is equal to our m, which is 7 over 9 into x minus 3. We open this up. So 7 over 9x minus, that's going to be a 21 over 9 plus 1. Okay, simplify this fraction, 7 over 9x. When I simplify this, it's supposed to be a 7 over 3. Means that's -7 plus 3 over 3, which is a -4 over 3. So this is what I get as my equation. All right, we move on. If A, E, B, C, if A, B, no, if A, E, B, C, A, E, meaning, before I even finish the question, trying to look for point E, I'll just locate it to be somewhere there. I don't know. A, E, B, C is a parallelogram, and K is -6. Determine the coordinates of E. So if this is our E, I'll just put XY. Okay, we have that. And then we have that. Don't mind about the shape, but we just focusing on the parallelogram part. How many marks is it? It's 2 marks. Okay. So if it is 2 marks, and we already know that our AB is a diagonal, meaning that this point M is going to be a midpoint even to this AE. Now, if this is x, this is a -6, we're going to have something like -6 plus x divided by 2 must give us a 3. Okay, cross multiply, meaning that -6 plus x is equal to a 6. Move the 6 that side, x becomes a 12. We do the same with the y. If we get k, which is a -6, plus the y value of E, divide by 2, we must get the y value here, which is a 1. Cross multiply, -6 plus y is a 2. Then y becomes 8. Okay, so that's what they wanted. I don't know why they are giving us just 2 marks. Okay, 3.5. Given that the straight line given that a straight line is defined by this. They want us to determine the value of m if the line has an inclination of this, like y. Because I don't see any big logic in this. You know why? Because we have the inclination here. But then they're telling us that if a straight line defined by this determine the value of m if it has an angle of inclination of this much. Okay, so what I'm going to do, let me start by maybe creating a standard equation, okay? 2y minus 1, okay, 2y minus 1 is equal to mx. Let's leave y on one side. So y is going to be a half m of x plus 1 over 2. So move this one that side, it will be mx plus 1. Okay, then divide through by 2. We shall get to this. What does this mean? We need the value of m. But we know that this m is the same as m over 2 times x. So this is like the gradient of interest. We know that tan of theta is equal to the gradient. Okay, just the normal gradient m. So we're going to say if we get the tan of 116,56, we should be able to get to our gradient. So punching this into the calculator, we're getting a -4. Then this is just the value m, but then this m over 2 is our gradient. Means that -4 divided by 2, the answer becomes a -2. But what was the question asking for? Determine the value of m. So I'm not sure, because if the question was asking for the gradient, then I would have gone for the -2. But if they're asking for m, then this would make a lot of sense. I don't know. Let's see what you guys have to say about that. Then calculate the coordinates of D. Where is D? We don't have D. Did they mention anything about D? So they told us this is the y-intercept. Oh, it's here. Okay, so how do we get those coordinates? How many marks? It's 2 marks. Do we need to get the equation of the, okay, we're saying that the gradient is -2. But this is a y-intercept, meaning that the x is going to be a 0. Is there anything special they mention about D? There's nothing. It's just y-intercept of AB. So 2 marks is still an understatement, unless if there's something that I'm missing for 2 marks. For 2 marks. Okay, the equation, we know we only found the distance. Did we find the gradient? Nothing, only found the midpoint. Okay, so let's try to find the gradient of AB. Maybe that will lead us to what we want. So it's going to be 6 minus -4 over -2 minus 8. That gives us 10 over -10, which is a -1. Let me use 3 and 1 and say that y minus 1 is equal to -1 into x minus 3. So y becomes a -x plus 4. Okay, so this is our equation, and the y-intercept is 4, meaning that D is going to be just 4 with a 0. So 0 and 4 becomes the D. Then they want us to get the size of B. The size of B. Now, is the B in relation to the triangle or the parallelogram? Okay, I'm just going to ignore the parallelogram and focus on the triangle here. Okay, so this angle here is what the question is asking for. So It should be a lot of marks, né? It's 5 marks. What do you think needs to be done here? What needs to be done? You see the gradient here is a -1. We got the equation of MC. And what was the equation of MC? We got the gradient to be 7/9 for MC. For us to get this, do we need to extend this line? I think that's the only logical explanation that I'm seeing now. Let me just take this out so that I can show people what I'm seeing so that I don't waste a lot of time. Okay, so what I'm saying, I'll just extend this and then extend this line. Okay. So I'm gonna treat this as my exterior angle. Let me call it theta. I'm gonna call this a beta, my angle of inclination. And then let me call this my alpha, also the angle of inclination. So that when I plus these two, I should be able to get to the theta. Now, since we say the gradient here is -1, I'll say that the shift tan of -1 is to give me alpha. And I know this is going to be like a -45. Okay, so if that's -45, technically I know that this will be the 45 and this one will also be a 45. Then what is the gradient of BC? I think that's the only tricky part. Let's look for it. BC is going to be -4 minus 6 over 8 minus 6. Okay, so when we plus this up, we're gonna have a +2 over 14, which gives us just a 1/7. Okay, so that's what I'm getting as my value. So I need to get the inclination value. Okay, let's punch this into our calculator and see. So we're going to say that the shift tan of 1/7 should give us our beta. Shift tan of 1/7 because I'm focusing on this line. Okay, so shift tan. Nope, that's not true. It's saying the shift tan. Okay, of 1/7. It's giving me a very weird answer. Very weird answer. I'm getting 8,13 as my answer. Okay. I don't know if it's my calculator, but that's what I'm getting. Then if this is 8,13, meaning that I just need to plus these two and get my value of B. So 45 plus 8,13, that gives me 50 what? That's a 53,13 degrees. Okay, so guys, that is if I'm using the triangle part. But there are also other ways, okay? We shouldn't just focus on that. Remember, we found the distance, this one to be 10 square root of 2. This is a 10 square root of 2. You can even find this distance, okay? And then we use the cosine rule. That is also one other quick way to get the answer. Okay, so nevertheless, it's all about the approach that we are interested in, for as long as you get an idea of how to go about this. So cosine rule could also be applied in this case. There is no problem with that. All right, so someone's saying there's an issue with our gradient for AB. Is it not -1? So you say 6 minus -4 over -2 minus 8. No, it's a -1, okay? So I believe even if you use the cosine rule, we should be able to get the same answer. Then determine the area of the triangle ABC. So I'm going to use this angle that I found, okay? I'm going to use 53,13. So we know that area of a triangle will be given as a half AB sine of C. But now since we have angle B, okay, it's just gonna be a half times A times C, the sine of B. Okay, so that's a half times 10 root 2 times 10 root 2, the sine of 53,13. So I'm just using the angle that I got. Okay, so if ever you get a different angle, is just use the same steps and then use that same angle that you got. So when I punch this into the calculator, that's gonna be the sine of 53,13. Okay, I'm multiplying it by 100. It's giving me, because this and this is gonna be 200 divided by 2, that's like 100. So I'm getting 79,9998, which is approximately 80 units squared. All right, so that is how we would have gone about with that, okay? Alternatively, if you feel there is a 90 degree somewhere, then go ahead and use it and find the distance. Okay, that is question number 3, 29 marks. Question number 4, which is also analytical, but this focuses more on the circle geometry. In the figure below, circle A has this equation. Line BC is a tangent at D. That's the point. Okay, everything is included. Determine the coordinates of A, which will be the center for 4 marks. So in this case, we need to complete the squares. So it's going to be x squared plus y squared plus 6x. Let's bring everything that side, plus 6y. Is equal to -1. Okay. So when you look at the x's, it's just x squared and 6x. Same story with the y squared and 6y. So how do we complete the squares in this case? So we can see that one value is negative, the other is a positive. I'm missing something here. This is supposed to be -6y. Sorry about that. Okay, so open the brackets. We square that, open the brackets, we square that, that's a -1. So I'll put my x there, I'll put my y there. What is a half of 6? It's going to be a 3. Keep the sign, plus. And then I'll plus a 3 squared. And then half of 6 is a 3. Keep the sign to negative. And then we said I'll plus a 3 squared. Meaning that the general equation is x plus 3 squared plus y minus 3 squared is equivalent to, that's a 9. That's 18 minus 1, which is a 17. All right, so these are our center points. They are not interested in the radius. They are only interested in the center point. So we're saying A is going to be a -3 for x, a +3 for y. Perfect. Then they were asking for the radius of the circle, which is just going to be the square root of 17, because this represents r squared. So if r squared is 17, which means r alone will be the square root of 17. All right, then determine the equation of the tangent. Okay, so if this is a -3 and a 3, we need to draw that sort of a line. We know that tan radius will be perpendicular, okay? We know the coordinates of D to be negative 28/5 and then 31/5, okay? So let's get the gradient and then multiply it by -1, and then we get our answer. Okay, so gradient of the radius, we're saying is a 31/5 minus 3 over -28/5, we shall say plus 3. Okay, so when you punch all this in the calculator, we end up with a -16/13, meaning that the gradient of the tangent is just the reciprocal of this, which is a 13/16. Do we have a point that we're using? Because they want the equation. So we can use the same point, the 28 and so on. Mean that it's going to be y minus 35, no, it's a 31/5 is equal to 13/16 into x minus minus, which is a plus 28/5. Open the brackets and collect the like terms. I don't know why this paper, they used fractions too much, but not a problem. Okay, so I'm getting the C as a 43/4, meaning that the equation is going to be 13/16x plus a 43/4. So that is what we get. Then they want the area of BCO. B, C, and O. Okay, so what this asks for us, we need the coordinates of C, we need the coordinates of A, which are basically the intercepts, okay? So meaning if X is a 0, Y is going to be a 43/4. If Y is a 0, okay, we're going to get X to be a -172/13. Then substitute that into the equation of the area of a triangle, it's a half, 172/13. The height, we said 43/4. Simplify that. You can give your answers in decimals, but I prefer to leave them as fractions. So it's going to be 1849 divided by 26, that's units squared. Then 4.5, the circle with this equation is reflected about the line y is equal to 0. And which line is that where y is 0? So that is the x-axis. Okay, so this circle is reflected about the x-axis. Can we write the equation of the new circle? So if it's reflected about the x-axis, meaning that it's only, okay, so we're keeping the x. It's only the sign on the y that's going to change. So the new coordinates of the center will be -3 and a -3. Okay, so the new equation, I prefer to write it in a simplified version. It's going to be x plus 3 squared, and then y plus 3 squared is equal to 17. Nothing is going to change. That has to be the equation. And then hence, calculate the length of the common chord of the two circles. Write your answer in simplest form. So if we have the same circle reflected, meaning that the two would be, no, that is a lie. That is a lie. So if that is our center there, this is our center. So we can have something like that. So the common chord, this one, is what they're asking for, the line that connects the two meeting points. So you need to equate the two equations and solve them simultaneously because that chord is along the x-axis. Okay, sorry, yeah, along the x-axis where y is a 0. So with the first equation, if your y is a 0, your y is a 0, meaning that x squared plus 6x plus 1 gives you a 0. Okay, when you punch this into your calculator, using the quadratic formula, obviously, we're going to get our x to be something weird. We have -3 minus 2 square root of 2, or x is a -3 plus 2 square root of 2. So we already have the 2 points, this one and that one. Then we just need to get the distance between the two answers. Okay, so I'll start with a -3 plus 2 root 2 minus the smallest value, -3 minus 2 square root of 2. So this gives me 4 square root 2 units. Okay, so I've used just one circle, but you could also use the other circle. Alternatively, you can solve the two simultaneously, whichever way makes you get the marks. Question 5, which is the trig. Okay, they're telling us we are given the cos of A being this compound angle formula or identity. Use the identity for cos A minus B to derive one for sine. So this thing is quite easy. The only thing you have to do is, how do I obtain a sine A minus B from a cos? So it's all about using a 90 formula or the complementaries. So I'll say A minus B is going to be the same as the cos of 90 plus A minus B, something like this. Okay, is it a minus or a plus? I think it has to be a minus, no? For it to make more sense. Because if I have it this way, then I'm going to get a negative. So meaning I have to use a negative so that I end up with a positive. Perfect. Then I'm going to snatch this A and keep it to the 90 so that I have the cos of 90 minus A and then minus B, something like that. And then I can open this using this identity that I was given. So I have a cos of 90 minus A and then the cos of B. And then I'm going to have a plus sine of 90 minus A and then the sine of B. So cos of 90 minus from our complementary reductions, that's going to give us a positive sine of A and then the cos of B, plus the sine of 90 minus gives us a cos of A, and then that is the sine of B. So that is what the question wanted. So the trick is just with the 90, and then you merge this A together with that 90. Okay, then on 5.2, if sine of theta is this, and cos theta is greater than 0, calculate without a calculator and with the aid of a diagram. So this is the Cartesian. It has been simplified for us. We can see that sine is negative when cos is positive. So we need to find the quadrant. Okay, so the cast, and we are saying the sine is negative in quadrant 3 and 4, but cos is positive in quadrant 4. So meaning that our sketch needs to be somewhere here. Okay, that's the 19. They told us 12 over 13. So this is the 13. This is the 12, which is a negative. Then use your Pythagoras to find the missing side. Okay, so when we do that, so it's going to be like 13 squared minus 12 squared under root sine, which gives us a 5, ne? Positive 5. So remember, the hypotenuse is always positive, cannot be negative. They want us to find the sine 2 theta. So this is the same as 2 sine of theta, cos of theta. Let's now substitute. So it's going to be 2 times the sine is negative 12 over 13. The cos is 5 over 13. So this is a 10. So it's a negative 120 over 169. That is what I'm getting as my answer for 5.2.1. Then cos of theta plus 30, this is a compound angle. We just need to open it up. 30 is a special angle. So it's going to be cos of theta cos of 30 minus sine of theta, sine of 30. Okay, let's use just a different color. So cos of theta is going to be adjacent, which is 5 over 13. The cos of 30 is going to be a root 3 over 2, if I'm not mistaken. Then we are subtracting the sine. They gave us negative 12 over 13. And then the sine of 30 is a half. Remember, they said without a calculator. But can really this one be simplified without a calculator? That's like being unfair. But anyway, we can do it because denominators are the same. So I'll have a 26. So it's a 5 root 3 plus a 12. That should be our answer. Don't give us decimals, otherwise they will get you there. Evaluate again without a calculator. So cos of 35, sine of 35, we have 225, we have 200. Let me write it this side. Okay, so it's saying sine of 35, cos of 35, tan of 225, and then cos of 200. Okay, so these ones, I believe they are shorting something to give us the double angle. And that is basically their half that I can introduce. Then 225 is a special angle, which is more like 180 plus 45. We can find it on the quad in the Cartesian. 200 is 180 plus a 20, which is in the third quadrant. Okay, so I'll start by saying it's a half sine of 70, because 2 times 35 is 70, over, we said 180 plus 45 gives us the 225, that's quadrant 3. It's the same as the tan of 45. And then this one, cos is in the third quadrant, cos is negative. Cos, so it's a negative cos 20. Then we know that sine of 70 is the same as the 90 minus 20, which gives us a cos. So it's going to be a half multiplied by the cos of 20 over tan of 45 is a 1, and then negative cos of 20. So this cancels that, which means our answer is just negative a half. I don't know. I believe that's what I would have done to get those sweet 5 marks. Okay, then they want us to get 1 minus sine squared of 22,5. So we know that 22,5 is just the half angle of 45. Okay, so how do we express this? We can say that 1 minus, let's change this to a cos. It's going to be 1 minus cos squared of 22,5. The 1 and the 1, they're going to cancel out. And then we're going to be just left with the cos squared of 22,5. They want us to get the value of this. Okay, so I'm going to go back to the double angle and half angle. Okay, so we have cos squared of 22,5. But we know that cos 2 of 22,5 gives us a 45, meaning that we, as well as dealing with the cos of 45. So the double angle of cos that has cos squared, what is it going to look like? Did we do the right thing here? We said 1 minus. Isn't that wrong? Because we said sine squared is the same as 1 minus. And then that is cos squared. It's fine. It's okay. It's okay. It's okay. Meaning that we have 2 cos squared of 22,5 minus 1. this needs to be the cos of 45. Okay, the question is asking for the cos of what? They're asking for the value of this. So I'm going to move this one that side. So it's a cos of 45 plus 1 divided by 2. So cos of 45 is 1 over root 2, or root 2 over 2 plus 1 divided by 2. Can simplify this further, which will give you root 2 plus 2 over 4. That becomes our final answer. All right, 5.4, we have 3 sine p plus 4 cos q is equal to 6. 4 sine q plus 3 cos p equals to 1. Can we prove that the sine of p plus q is a half? 6 marks. What are you going to do there? Okay, so what I'm going to do, because it's a bit tricky, né? I'm going to start by squaring here, and also squaring this side, because that's the only way to sort this out. So I'm going to get 9 sine squared p plus 24 sine p cos q plus 16 cos squared q is equal to 36. Let me do the same there. I'm going to get 16 sine squared q plus 24 sine q cos p plus 9 cos squared p is equal to 1. That is equation number 2. Then I'm going to plus the two equations together and see if I can get some like terms. Are there any like terms really? Okay, so cos squared q, sine squared q, there seems to be no like terms. Let's see. 9 sine squared p. Okay, this is different because it's a sine q and then a cos p. Is there anything common? So if I get the 9 and the 9, will that make sense? Let's say when I'm doing the addition. So it's a sine squared p plus cos squared p. Oh, this and that. Let's do the same with the 16. 16 cos squared q plus sine squared q. And then these ones, I mean, they have the same 24. And then we have sine p cos q plus sine q cos p. This is equivalent to just a 37. Okay, so we know that sine squared cos squared is a 1. That's a 1. Means a 9 plus 16 plus, this is now going to give us a compound. Sine p cos q is the same as now 24. Sine of p plus q is equal to 37. Okay, we know that 9 and 16 is a 25. Let's move everything that side. So 24 sine of p plus q is equal to, so 37 minus 25 gives us just a 12. And then divide both sides by 24. Being that the sine of p plus q gives us a half. Yo. This is dangerous, ne? If it's further given that PQR are interior angles of a triangle, R is acute, they want us to get the size of R. Okay, now we know that P plus Q is equal to a half, meaning that if we can get, is it gonna make sense if we have to look at it that way? because we know that P plus Q plus R must give us 180 degrees, meaning that if we can get R, it's going to be 180 minus the sum of P plus Q minus the sum of. Alternatively, we can just have P plus Q being 180 minus R. Either way, so I prefer to use the latter, okay? Meaning that I can use this here. So the sign of 180 minus R is equal to a half. Then the shift sign of a half gives us 180 minus R. Does that make sense though? Does that make sense? If we reduce, because we cannot just say that is 180 minus R. Oh, that would be a lie. Okay, so this is going to be just sine of R is equal to a half. And then shift sine of a half is going to be just a 30 degrees. Yeah, that would make sense. All right, question 6, the trig graphs. Okay, f of x is that, g of x is that. Between that domain, determine the value of q if f touches the x-axis at the origin. What is q? Q is the shift of the cos graph. So if it's a -1, which means, wait a minute, we're focusing on f. Find the value of q if f touches the x-axis at the origin. Is there a number before that? No. So we know that originally the graph is just supposed to pass through 1 and then up until -1. But now it has been dropped down. It's been dropped down. So y or q is going to be a -1. The graph has been shifted 1 unit down. Okay. Then the amplitude of f. Okay, so amplitude is going to be 1 because the maximum displacement, because the maximum minus minimum divided by 2. Then the value of b, if the period of g is half the period of f. So what is the period of g? The period of g is 360. The period of f is also, no. If that's 360, then it's going to be 180, which means b is a 2. Okay, so it's like 360 divided by 180, it's going to be a 2. Then the coordinates of the x-intercepts of g, where is g? This is g. So we already have now the equation to say cos 2x. Where do we find the y to be? A 0. So the shift cos of 0 is going to be a 90. Then, so 2x is a 90, meaning that x needs to be a 45. So that's a 45, and then that needs to be a -45. But the question is asking for the coordinates. So it's -45 and 0, and then we're going to have 45 and 0. Then use the graphs to determine the values of x in this interval for which x times the gradient to be negative. Okay, so when you look at the negative side, I think it satisfies all the values. Okay, means that there's a -90 is less or equal to x less than 0, or we can have 0 less x less or equal to 90. As x, so x is negative, the graph or the gradient is positive for f, which is on this side. Okay, and then when f is positive, the other one must be negative. So that is either sides of the domain. Question number 7, which is the 3D trig. They are telling us that a telephone cable is to be created between two cliff sides, AD and BE. An engineer stands at a point C in the same horizontal plane as the foot. All right. Then they are telling us to show that the length of the cable is given by that. So the cable is created between two cliffs, AD and BE. So this is our cable. I want to believe so. Is that what they say? They didn't even tell us which side they are focusing on, but that is the DE, that's the cable of interest. Okay, so they want us to get the length. How many marks is it? So it must have a tan theta and a sine alpha. It's some sense here to find that. And then the sine, we're gonna find that distance. And then from there, we can use the sine also. Okay, so let's start with this one. So from triangle DEF, we're saying that the tan of alpha, should I use the tan? Yeah, it's given as the adjacent, but we don't know what DF is. Okay, so tan is going to be a bit weird. That would be my last triangle, maybe. Let me start from BEC. So he's saying that the tan of theta is the opposite, which is EB over the X, meaning that EB is X tan of theta. Then I can now proceed and use the sign and say that the sine of alpha is going to be the opposite, which is EF over DE. But we want the DE, which is going to be the EF over the sine of alpha. Now, for us to get the the EF, we need to get the EB minus the FB. Okay, they told us that this is a Y, meaning that this is a Y here, which makes life easy now. So it's gonna be X tan of theta minus the FB, which is a Y. So let's punch that to the top, meaning that we're gonna have X tan of theta minus Y over the sine of alpha. Oh, that was a quick 5 marks. Then if X is that, Y is that, and theta alpha 45, what's the distance between the cliffs? So we can use because they want the distance AB. Is that true? No, not AB. Yeah, it's the same as AB because they are focusing on DF, this distance. But we already have our DF. Is there anything that combines DF here? No, we didn't look at it, but it's fine. Let's do the substitution and find DF. But we're gonna use DF, DE, because we now have our Y, we have the missing parts, and we can do just the substitution. So I would prefer to use the tan alpha, which is EF over DF, and then make DF the subject, which is going to be the EF over tan alpha. And we found our EF to be X tan this minus Y. Okay, we say tan alpha minus Y. We are dividing it by the tan alpha. Let's do the substitution. So 1000 tan of 45 minus 250 divided by the tan of 45. So this gives me 750 millimeters. Okay, so that is what we would have done with that. Question number 8, which is the Euclidean. Okay, so in the diagram, AD is a triangle that is having BC parallel to ED and AE parallel to that. It's also given that AB to BE is 1:3. Okay, and then AC is 3 units, EF is 6 units, and then CG is X units. They want us to get the length of CD. So these are parallel lines, okay? If they are parallel lines, then basically we must follow the same proportions, okay? So what we say is that if CD divided by CA should be the same as BE divided by AB. Reason is going to be the proportionality theorem, because BC is parallel to ED. So it's saying that if our CD divided by 3 should be equivalent to 3 over 1. Cross multiply, CD becomes 9 units. Okay. Then they want us to get the value of X. Okay, this X here. So which lines are we focusing on? We can focus on this other section of parallel lines, these ones. Okay, because we said the whole of this is 9. If that is X, then this is going to be 9 minus X. I don't know. Yes, that's what I'm seeing. Okay, so the whole of that is 9. So we're going to focus on this over that whole part. So we still use the same proportionality theorem. So we're going to say if we have GD divided by the total distance, which is AD, this should give us the same as DF over the entire distance, which is ED. We're going to still use the same proportionality theorem. GF is parallel to AE. So let's substitute that, and we have our 9 minus X over the total distance, which is 12, is equal to 3 over 9. Cross multiply, and let's see what we get. So that's going to be, why must I multiply? So that's going to be like a 36 over 9, which is a 4. Okay, so meaning it's going to be 9 minus X is a 4, which means X is 5 units. Then they want us to get the length of BC. Okay, this length here. So one thing we need to do is just try to compare the sides. Okay, compare the triangles. So if this is a 1, and then this is 4 units, this is 3, and then that is what? That is 12. So we can see that the ratios are the same, 1 over 4, 1 over 4. Okay, so we can say that AB over AE. So AB over AE is equivalent to AC over AD, AC over AE, which must also be the same as BC over ED. BC over ED. This is going to be sides in proportion because the triangles are similar, okay? So that is one approach. Alternatively, one would start by proving that the triangles are similar. So we are saying it's 1 over 4 because the marks are really too much. Okay, so if we have 1 over 4, okay, it's equivalent to BC divided by, we know that this is a 6, this is a 3, which is a 9. Meaning that our BC is going to be 9 over 4, which is 2.25 units. Then 8.4, the area of ABC, FD. Okay, this one 4 times 3 over 3 times 4, meaning that we have 9 over 16. All right, question number 9. They want us to prove angle N. Let's call it N. Okay, so even this one, we can call it a 2 if we so wish. Then go on and tell us that number 1, we know that T1 and T2, T1 plus T2 is a 90. The reason, they turn perpendicular to the radius. So you can tell us that, will it be angles in a semicircle? Now, it doesn't make sense for angles to be the same. I would prefer the tan radius, T1 and T2. That makes sense. Then S1 and S2 is the one that's going to be angle in a semicircle. Angle in a semicircle. So if that is true, meaning that S1, okay, is going to be the same as T1. How is that possible? Because that's a 90 and 90, meaning that our T2 is going to be 90 minus T1. Okay, and then when you look at S1, it's going to be 90 minus S2. But we know that S2 is the same as, is it S2? Yes, S2 is the same as T2. And if S2 is the same as T2, therefore S1 is the same as T1. I think that is just enough for that particular part. Just that. Okay, question number 10, which is the last one. We get out of here. Okay, they're telling us that in a diagram, M is the center of the circle, and the diameter AB is produced to C. M is drawn perpendicular to AC, and then that is a tangent. Okay. Then, if that is a chord intersecting that, MB is twice BC. If D4 is X, okay, our D4 is X, they want us two other angles that are equal to X. Okay, so this is a tangent, this is that, so meaning that the angle A is going to be X. Okay, so A is X, we're gonna say it's a tan chord. And then, which other information were we given? Nothing, okay. So we're calling this X. If that is X, which means even D2 is going to be X. Angles that are opposite equal sides, because this is a radius, this is also a radius. If that is true, do we have any other X? I think that's all. That's all. Then can we prove that CM is a tangent at M to a circle passing through MED? MED. So for us to prove that something is a tangent, it's always the tan chord that must play the role. Okay, that is just one. Two, even the perpendicular can also help us in deciding that. So what we can start with is that if this is X, meaning that M1 is going to be twice X, exterior angle of a triangle. Okay, exterior angle of a triangle. Then from there, we could go on and say that our M2, this M2 here, is going to be a 90 minus the 2x. Okay, 90 minus the 2x. And we can say that that's basically tan radius. Okay, because this is a radius. Oop, does that even make sense? No, that can't be a reason. That could be probably the last part. We can say adjacent supplementary angles, because this is a straight line, this is a 90, all of that will be a 90, that's a 2x, okay? Then if that is a 90 minus 2x, okay, we know that this angle is going to be a 90, because definitely those are angles on angles in a semicircle. So if that is true, then where is our E? This angle here is going to be 2x. Because when you focus on the triangle MED, If this is a 90 minus 2x, which means this is 2x. And this 2x is the same as the 2x that we found there. Okay, so since E is the same as M1, therefore CM is a tangent. And the reason is going to be the converse of the tan chord. Okay, so that is how we would have proved that. Then can we prove that FMBD is a cyclic chord? Okay. So number one, we can start with the D3 and D4, or D3 and D2. I think that would be better. D3 and D2 to give us the 90. Okay. So we're saying D3 and D4. Let me just write it somewhere here. So D3 plus D4 is going to be a 90 angle in a semicircle. Okay, remember our target is FMBD. Okay, FMBD. So that's a 90. Then we also know that M1 plus M2 is a 90. Okay, so what does that mean? I want to use just the exterior, the opposite angles, okay, being supplementary. So we say adjacent supplementary angles. So therefore, FMBD is a cyclic chord. Reason being, opposite angles are supplementary. So the converse of opposite angles being supplementary. So this is a 90, and that's a 90. Alternatively, you could say this is a 90, and then M3 is a 90, and then you use the property of the exterior angles. Either way, okay? Then prove that DC squared is the same as 5BC. Okay. So what you need to do in this case, let me just erase this part here so that I can write it where people can see. I see. Okay, so we're going to focus on triangle DBC and DFM. Okay, so DBC as well as DFM. So we say that B1 is the same as F2 because of exterior angle of a cyclic chord. Okay, why can't I remove all of this? So DBC and DFM. Okay, so we're saying B1 is going to be the same as F2 because of the exterior angle of the cyclic chord. We agree with that. Then D4 is the same as D2. We proved that earlier on, that everything was X. Then we know, wait a minute, am I answering the correct? No, I'm answering 10.5, which is incorrect. It's fine. Let's finish with the 10.5, then you can go back, okay? Then lastly, so those are two, which means the other one is just going to be the third angle, means C is supposed to be M2, which is the remaining angle. So therefore, DBC is similar to DFM. Okay, so to prove that D squared is the same as that, we're going to need to use some bit of Pythagoras here, okay? So if I use triangle MDC, okay, because that is the triangle that's going to lead me to what I need. This is MDC, this entire triangle here. Okay, I know that the whole of this is a 90. We saw that, no? The tan radius. Okay, so if that is true, then I can come down and say that my MC squared should be the same as the MD squared plus the DC squared. The reason that is basically the Pythagoras. Then what is our MC? They told us it is twice of they said MB is twice BC. Okay, so if this is a K, this must also be a K, so it's twice, so it's the same thing, meaning that my MC, wait a minute, MB alone is twice BC. If this is a K, this is gonna be twice K. That's the meaning, eh? So we're gonna have 3 BC squared. Our MB is this, which is twice BC squared. Okay, because this is a radius and this is also a radius, so they have to be the same. Then our DC, we can keep it because it's part of our solution. Then this is gonna be a 9 BC squared is equal to 4 BC squared plus DC squared. Let's move everything that side. So it's gonna be 5 BC squared, meaning that DC squared is 5 BC squared. Okay, that's fine. And then lastly, we proved that the triangles are similar. So this should be just a walk in the park. So you can say that DM over FM should be the same as DC over BC. Remember, we already proved that the triangles are similar. So if we do that, the reason is going to be similar triangles. So when you do your substitution, you're going to have √5 of BC over BC, which gives us 2025. Okay. Now, with this paper, we have 3 hours for 150 marks, and then the paper has 11 questions. Wow, why so many questions? Okay, so the others are just basic instructions of paper 2. Then question 1, which is the statistics. Now, for some provinces are not including statistics within their scope for their own reasons, okay? But in Limpopo, we had statistics there. But of course, statistics, that will be just the grade 11 and grade 10 statistics, and not necessarily the grade 12 statistics. Okay, so with the first question, they're telling us that a certain grocery store's delivery service has grown over the past 2 years. And then the store owner did a survey on a specific day to improve their delivery performance. And then the following table represents this. Okay. All right. So we have the delivery time and then the performance, the number of deliveries. And they want us to complete the cumulative in the answer book. So I'll just put the cumulative just down here. So the first cumulative will always be the first frequency. Then 8 plus 5 is a 13. 13 and 12 is a 25. 25 and that is a 40. It's a 43. 43 and 22, that is a 65. 65 and that's going to be a 90. That is 110. 125, 135, and then 140. That's my last cumulative. How many deliveries did we have altogether? Let's see. They never told us. That's weird. But it's fine. Let's take the 140 to be our last cumulative that we're getting. Then 1.2, they want us to draw an ogive to represent the information. How many classes do we have here? How many classes do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, 10. Okay, so I'll just try to sketch an ogive this side and see. Okay, so if we have this as our, let's use this color. Perfect. That is our cumulative. And then we can have the time in this format. Okay, so we know that the deliveries started at 8. Okay, so we can have this as 8. And then we can have 9, 10, 11, 12, 13, 14, 15, 16, 17. The last delivery was 18. 1, 2, 3, 4, 5. I don't need to count them. Yeah. Okay, so whenever we are plotting, okay, let me indicate this side. Our maximum cumulative is 140. So I can use 20, 40, 60, 80, 100, 120, and probably 140. All right. I'm sorry if the intervals are not that clear. It's just that it's a sketch. So we just need to have the shape. So whenever we are plotting, we said we only use the upper class intervals. Okay. So 9, 10, 11 up to 18. So 9 is going with 5. So I'll say 9 is 5, which is somewhere there. And then 10. Okay, 10, we're going to take a 13. And 13 is still below 20, which could be somewhere there. And then we have 11, which is a 25, slightly above 20. Okay, and then we have 12, which is a 43, slightly above 40, somewhere there. Why does it look like a line for me? Okay, then we have 65, slightly above 60. Let's have it somewhere there. Okay. And then we have 90, 90, 90, 90, 80. And then this is our 90 with a 14 somewhere there. And then we have 110. This is 100. 110 must be just in the middle there. For the 15, somewhere there. Okay, I hope it comes out. Then we have 125, 135. 125 is somewhere here. Okay. Then we have 135, slightly above that. And then lastly, we have 140. Guys, please forgive my graph, the way it is looking. Okay, then I'll connect this using the freehand. Okay, up to somewhere there. And then we just need to extend this to the starting class, which is the 8. So that is the OGIF for the cumulative frequency graph that the question is basically looking for. All right, then determine the 5-number summary of the delivery times from the OGIF. Why? Okay, so we know that from the OGIF, we need to get the minimum, okay? We need to get the maximum. We need to get the Q1, we need to get the Q2, we need to get the Q3. So we know that our minimum is 8 o'clock, no? Our maximum, we say that is 8. Our maximum is 1800. Okay, so the median, we know that half of 40 or half of 140 is 70. And 70 is somewhere around here. So if I draw a line and then it meets somewhere there, you can see that it is somewhere around the 13,5 or 13, something. Not so accurate, but that is the kind of time I'm ending up with. So I can say that my Q2 is a 13, let me just take 15 to be precise, but it's around 13, something. Then Q1, which is a quarter of 140. Okay, so 140 divided by, saying 140 divided by 4, which is a 35. Did we have a 35 in our cumulatives? 35? No. Let's just look at the graph and then we'll see. So 35 is somewhere around here. You draw the line up until it meets that. We're seeing that it is going to be after 11, okay? So we can say maybe that is 11, maybe 36 or 11, 30 something. Then now Q3, what is 3/4 of 140? Okay, so it's saying 140 times 0, that, which is 100. Eh? So where do we find 100? Is 100. You draw a line, miss the graph, and then you're getting it after the 14th mark or the 14th hour. So meaning that it's around 14 something. I'll say 1430 or sub, depending on how the graph will look like, okay? But remember, I mean, I don't have a graph. That's why I'm taking just estimates. Then they want us to draw the box and whisker. Okay, so let's see. My lines need to be investigated. I mean, why are they so skewed? Okay. Okay, let's have that. So if this is our minimum, which is 8, this is our maximum, which is 18. Okay. It's not going to make sense. Not making sense. So let's have 8. We have 10, 12, 14, 16, 18, and maybe 20. You say the minimum, this is the maximum. Our Q1 is 11, something, which is somewhere there. Our Q2 is 13 something, which is somewhere there. I'll put it somewhere there. Our Q3 is a 1430, which is also somewhere there. Then I'll just have my box drawn, and then I'll connect this. Then I'll connect that. So this is our box and whisker. Now, from my box and whisker, because I know the question is asking to comment on the skewness. So we can say that there is more space between the Q1 and the Q2. So it is skewed to the left. Okay, skewed to the left. Or it's negatively skewed. Then they're telling us if the store owner appoints 2 more drivers, the number of deliveries increase by 4 every hour. What influence will this have on the standard deviation? So for as long as the effect is uniformly distributed, the standard deviation will stay the same, okay? Can say stay the same, or we can say it's not affected, as long as it is uniformly done. But if it's done for just some others and left out for others, then they'll definitely have an effect. All right, then question number 2, which is the box and whisker. So they're telling us the number of push-ups that can be made in 1 minute by the first team rugby players of a certain high school will be recorded. Box and whisker given below. So this is the minimum, this is the median, this is the Q3. So if the range of the data is 36, determine the maximum number of push-ups. So we know that range is given as the maximum minus the minimum. So if we want the maximum, we must get the range plus the minimum. So our range is a 36 plus the minimum, which is a 49. So what is a 36 plus 49? 36 plus 49, we're getting 8 what? That is 85. Okay, so this is 85 there. And then determine the lower quartile value if the interquartile range is 20. So we know that interquartile range, IQR, is the same as Q3 minus Q1. So if that is a 20, our Q3 is 75 minus the Q1, which we don't know. So switch positions, meaning that Q1 is going to be 75 minus 20, which is a 50 what? It looks like a 55. Okay, then 2.3, we have 2 players. Okay, 2 players that had the same number of push-ups. They did 8 more push-ups than the median value. Determine the number of push-ups that they did. Okay, 8 more push-ups than the median. So we know that the median is having a value of 64 push-ups. So what is 64 plus 8? Does it make sense? It is 72. This question is giving Metzlit vibes, ne? Yes. Okay, then 2.4, the average number of push-ups is 65. Comment on the skewness. The average. So average, I mean, how does it connect with the skewness? Okay. Unless if we look at how the median relates with the mode, but that's not important for this particular question. Okay. But let's see. If the 65 is greater than the median. But we said our Q1 is a 55. I don't know. Let's see. What is 64 minus 55? Because I don't need to use that whole thing. This is going to be a 9. And then this is going to be 11. So there's more space to the right. No? So I'll just say it is skewed to the right. The reason someone will say that the mean is greater than the median, which is the Q2. All right, then 2.5, the standard deviation is this. Determine the number of players whose push-ups was less than 1 standard deviation. So to be less, we need to get the mean, okay? And then you subtract the standard deviation. So the mean is 65 minus 10.91 or 10.91. So 65 minus 10.91, which gives us 54.09. Is that what the question is asking for? No, that's not what the question is asking for. The question is asking us how many players will have that. But we have the push-ups of the players. In a certain high school, the box and whisker is given below. The range is 36. Do we know how many players are there? Nope. 2 players have the same push-ups, they did that. Well, we don't have the number. I don't know. Is there something that I'm missing? Any annexure? Nothing. So it doesn't make sense for them to ask us about the number of push-ups if they never gave us the push-ups in the first place, because this box and whisker simply represents a summarized sort of version. So this is what I'm getting, but I cannot draw a conclusion as into how many was determine the number of players whose number of push-ups. This question is kind of vague for me. Okay. We move on to question number 3. Okay, so the Gauteng people, this is probably where your paper is going to start from, the Euclidean. There's no statistics. Hallelujah. Okay, question 3 in the diagram below. A is -10 and -2, B is 10, 8, and then C is 11, -9 at the vertices of our triangle ABC. Answer the following questions. All right. Can we show that the equation of the altitude? Wow, now they're using big English. The altitude from C, okay, to AB, or from C on to AB is given as this. How many marks is this for the big English? It's 4 marks. Okay, so we know that altitude is basically height above something, yeah? So if, let's say we have our distance, which distance must make a 90-degree with whatever the question is asking for. So they want the altitude from C onto AB. These people. They want the height, technically. Remember, altitude must make 90 degrees with the base. So if this is the base, this is the height, which is the altitude. Okay, so we know that these two must be bisecting perpendicularly, and yes, there's trouble. Way in paradise. All right, so let's see. At least we have the answer. We cannot fail to get the answer if you've already given a hint. So let's get the gradient of AB first of all. Okay, it's going to be the change in Y over the change in X. So that's going to be 8 minus -2 over 10 minus -10. All right, so that is a 10 over 20, meaning that the gradient is what? A half for that. But we know that these two are going to be perpendicular. So we can say that gradient of the altitude is going to be -2, because we know that M1 times M2 must always give us -1. So if that is true, then we can use the point C and say that Y minus Y1 is equal to M into X minus X1. So that's going to be Y minus -9 is equal to -2 into X minus 11. We open that up. It's going to be -2X plus 22 minus 9. So it's a negative 2x plus, what's 22 minus 9? Is it 13? This is what I'm ending up with. Isn't that what the question wanted? Correct. So the question just wanted us to interpret the perpendicular lines, yeah? Eish. Hence, determine the coordinates of D, the point of intersection of the altitude, and they keep on using the word altitude. It's examiners, no? It's not fair. Big English for small learners, no man. All right, so let's get the points of intersection. So the equation of this line, we need to find it. And then also the equation of this line, we already have it. So the only thing we need is the y-intercept, and then we have the equation. So we're going to say if we have y minus 8 is equal to a half into x minus 10. Let's open this up. It's going to be a half of x minus 5 plus 8, meaning that's a half of x plus 3. So this is the equation of that line. So a half of x plus 3. Now, when I solve these two simultaneously, I'll have a half of x plus 3 is equal to negative 2x plus 13. Let's move the 2 that side. Let's move the 3 that side. So what's a half plus 2? It's 5 over 2x. When you move that side, we're going to have just a 10. So that's a 20. So 5x is a 20, meaning that x is going to be a 4. Then we substitute this 4 back into this equation and see that y is going to be a half of 4, which is 2 plus 3, which is 5. So these are the coordinates of D, 4 and 5. This question. Okay, so we move on. 3.2, they want us to get the area of ABC. So we know that area of a triangle is given as a half multiplied by the base multiplied by the height. So the only thing we need is to get the distance AB, okay, using the distance formula. Okay, so we had our beautiful coordinates, which was a 10 and 8, then a negative 10 and negative 2. Negative 10, negative 2. This was 10 and 8. We got D as 4 and 5. We have C as 11 and something, 11 and negative 9. So let me get the distances for those two, and then I'll find the area. So it's going to be x squared. That's going to be 10 minus 10 squared plus 8 minus 2 squared. Okay, so that's going to be root of 20 squared. I will say 20 squared plus another 10 squared, which gives us 10 root 5. And then the CD, okay, it's going to be square root of 11 minus 4 squared plus, can I say 5 minus 9 squared? It's the same thing. That's going to be square root of 7 squared plus, that's 9, which is a 14 squared, which is 7 root 5. So 10 root 5, 7 root 5, and then you just need to substitute into the formula of the area. Okay, so we know that the area is going to be a half times 10 root 5 multiplied by 7 root 5. So half of 10 is 5. 5 times 7, that's going to be a 35 multiplied by 5 again. That's 15 and 2, which is 17, which means it's 175. This is units squared. All right, then 3.3, they want us to get the size of A. These people. We're saying this is 10 root 5. They want us to get this angle here. So there are two ways to getting this. It's either we get the distances BC and then AC, and then we use the cosine rule. Okay. Alternatively, since we already have this as a 10 root 5, I think this would be the quickest. No? We know that this is a 7 root 5. We can divide this into 2. So that this is a 5 root 5. And then remember this is a 90. So we can use our tan. Yeah, I think that's the quickest. Let's not use the cosine rule. So you're going to say that the tan of A is equal to the opposite, which is the 7 root 5, over the adjacent, which is 5 root 5. Those 10 divided by 2 is 5. So root 5 and root 5 will cancel, meaning that the tan of A is basically 7 over 5. So A is going to be the uptan of 7 over 5. Okay. So shift tan, 7 over 5. I'm getting 54,46. Okay, so if I use this kind of approach, it might give some sort of misleading information. Okay, so let me rather not use it, because for me to use it, it simply draws an indication to say that D is a midpoint of AB, and yet the question never mentioned anything of the sort. Okay, yes, we can have a perpendicular, but at a different, not necessarily the midpoint way. Okay, so I'm going to discard that. Okay, I'm going to throw away that. So rather, what I'll do, if I use, because I need to find a distance, because that's the only way out for me to make life easy for myself. So let's get the distance BC. Okay, so if we find the distance BC, do we need a BC or just AC? Let's get AC. It's going to be easier for us. So when you substitute this AC, I should get something like a 7 square root of 10. Okay, that is the AC. 7 square root of 10. Now we have this, we have that. We need the distance BC again. Nope, we don't need the BC. We can use the area rule, whereby we know that the area, if we're focusing on the side of A, it's going to be area being a half multiplied by the AC multiplied by the AB, the sine of A. So we got 175 is equal to a half, or AC 7 root 10, multiplied by the AB, which we got as a 10 root 5, the sine of A. Okay, so when you do your magic, simply means that our sine of A is equal to 0,707, and then the shift sign will give us a 45. I think this is more reliable than the first one. All right, then we move on to question number 4. Question number 4, they're telling us a circle that has a midpoint, which is like the center. What are these people? Why are they like, no, man. It's inscribed in a triangle. AB is a tangent, P is that. A and B are the x and the y-intercepts of the tangent. O is the origin. Okay. It's examiners. It's like they had an agenda. Inscribed. Midpoint. All right, they want the equation in the form of that. So what we need to do is just determine the radius, okay, using the distance formula. So what we're going to do is, okay, so we need to get the distance PM. So under root sign, we shall have negative 18 over 5. We are subtracting a negative 2 squared. Plus 16 over 5, you're subtracting a 2 squared. So you punch that into your machine, you're getting just 2 units, okay? Then we just have to say that it's x plus 2 squared, plus we have y minus 2 squared, must give us the squared, which is like a 4. That's what the question wanted. And then 4.2. What is the mighty paper saying about 4.2? Okay, they want us to get the equation of the tangent. Now, whenever we find the equation of the tangent, we need the gradient. Okay, so we're going to say that the gradient of PM or MP, so change in Y over change in X, which is 2 minus the 16 over 5 over negative 2 minus minus, this is negative what? 18 over 5. Okay, so when you simplify this, punch this, we're going to get a negative 3 over 4. So that is the gradient of the radius. Né? So gradient of the tangent is going to be the reciprocal of this with the negative sign, so which is a 4 over 3. Then we can say that Y minus the 16 over 5 should give us the 4 over 3 into X minus minus the 18 over 5. Open up, make Y the subject. So I'll end up with something like Y minus 16 over that is equal to 4 over 3X plus probably that's going to be 6, which is like a 24 over 5. Okay, simplify further, we shall have a 4 over 3X. Okay, then this is plus 8. So that is my answer for 4.2. 4.3, circle A is shifted 3 units up and then 1 unit to the right. And the radius is halved. So that we get a new circle. Can we write down the equation? Okay, so let's start by the 3 units up, 1 unit down, meaning that the X is gonna, because if it's moved 3 units up, meaning that we're starting from here. So you're gonna subtract. We're gonna subtract, or we're gonna plus a 3, which is like a 5 here. And then this one, if you move it 1 unit to the right, it's going to be a negative 1. So meaning it's gonna be X plus 1 squared. And then this is gonna be Y minus 5 squared. We say the radius is half. If it was 2, then it's a 1. So 1 squared is 1. Okay, so that is what we end up with. Then circle N touches the tangent AB at R. We want to get the coordinates of that. So we have the equation. We have the equation of the tangent. So let's solve the two simultaneously. So where there is Y, we just substitute this. Let me come this side and say that the equation of our circle, we said it was X plus 1 squared, and then Y minus 5 squared is equal to 1. But the tangent was 4 over 3X plus 8. So where there is Y, let's replace it with that. Okay, so you're gonna have X plus 1 squared plus, this is 4 over 3X plus 8 minus 5 squared is equal to 1. Let's open this up. It's going to be X squared plus 2X plus 1. We open this up, it's gonna be 16 over 9X squared, because this is gonna be a 3, né? Then 3 multiplied by this is gonna be 4 times 2, which is gonna be like 8X. And then 3 squared is gonna be 9 minus 1 is gonna be a 0. Let's get rid of the denominator, or let's collect the like terms first before we get rid of the denominators. Okay, so when we collect the like terms, this and that's gonna be 25 over 9X squared. That and that is gonna be a 10X. And then this one cancels that, we have a plus 9 is equal to 0. Multiply through by 9, 25X squared plus 90X plus 81 is a 0. Okay. And then factors, we're gonna have a 5X plus 9. And then we're also gonna have a 5X plus 9 equal to 0. So the roots here are equal, meaning that the value is gonna be negative 9 over 5. So that is the X value. The question is asking us coordinates of R. So if that is your X, we just need to substitute into the equation of Y, meaning that it's gonna be 4 over 3 multiplied by negative 9 over 5 plus 8. And what does that give us? It gives us a 28 over 5, meaning that our R is a negative 9 over 5 and then 28 over 5. So that's what the question technically wanted. Okay, then we move on to 4.5, determine the ratio of BR to BP. Where is BR? So they told us there's another circle that is touching that. So BR. So let me just extend this. I don't know if it is just in the same, because we say the coordinates are basically -1, 5. So let's assume it is somewhere here. And then this is R. Okay. It could be even over passing that side, no stress, no problem. Okay, so they want us to get BR to BP. BR and then BP. So meaning that these are more like similar triangles. Okay, so what are the coordinates of BP? Or coordinates of B? Because we got this as our equation 4/3, we got that as 8. Ne? So if that is 8, we need to find this distance, and then we also need to find the total distance. All right, so first things first, we need to get the distance BR, ne? Using the distance formula. So with BR, we're going to have a 0 minus 9/5 squared plus 8 minus 28/5 squared. And then for BP, 0 minus 18/5 squared plus we have 8 minus 16/5 squared. This is all under the root sign. So with the BR, we have a 3, and then with this, we have a 6. So when you talk of BR over that, it is 3/6, which becomes just 1/2. Then what conclusion can we be made about the ratio BN to BM? We must give the answer. And so we know that if this is 1/2, automatically we know that NR and MP, okay, NR, because this is N, saying NR and MP will also be 1/2. So it's saying Rn over MP must also be 1/2, because those are basically radii of the same circle. And we can see that the two triangles are technically similar. Okay, so we can use that sort of conclusion, and then we can say that BN over BM is also going to be 1/2 because of similar triangles. Okay, that is question number 4. Wow, what a question. Question number 5, which is trig. If tan 41 is t, write down the value of the following in terms of t. We need to reduce this. If possible, we can even draw a sketch. I prefer drawing a sketch, even if the question sometimes doesn't need one. Okay, so if that is a 41, we know that tan is opposite of adjacent, meaning that this hypotenuse must be 1 plus t squared under the root sign. All right. So 319, where do we find 319? Which quadrant is that? That is quadrant number 4. So 319 is the same as 360 minus 41. 360 minus 41. Good. It's the same as tan of 360 minus 41. And then the fourth quadrant, tan is negative. So it's the same as negative tan 41, which gives us a negative t. And then 82. So 82 is twice of 41, meaning that this is the sign of 41, but twice. So it's a double angle, meaning that's 2 sine 41 cos 41. But we know that the sine 41 is okay, then I'm multiplying it by the cos of 41, which is 1 over that, 1 plus t squared. Okay, so by the top, we shall have just a 2t over, when these two multiply, we just have something like a 1 plus t squared. So this is what the question basically wanted. And then lastly, they want us to get cos of 19 for 4 marks. Okay, so for us to get the cos of 19, we could look at some special angles. Which special angles can I look at, especially when I'm maybe focusing on the subtraction? Okay, what is 60 minus 41? Could be 19, yeah. So let me say that the cos of 60 minus 41, then I can use the compound angles and say that this is the cos of 60, cos of 41, plus the sine of 60, and the sine of 41. So we know that the cos of 60 is 1 over 2, and the cos of 41 is 1 over the square root of that. So 1 over root of 1 plus t squared, plus the sine of 60 is root 3 over 2. And then the sine of 41 is t over that beautiful 1 plus t squared. All right, so we can see that the denominators are basically the same, meaning that I'm only going to have 1 plus root 3t. I'm dividing it by 2, 1 plus t squared. So that is what I end up with as my final answer for that. Then question number 6. Question number 6, simplify the following. So reduction here. So let's see. 6.1. If it's doable. 6 out of 11. So 4 over 3. Saying 4 over 3. Okay, so 4 over 3 cos squared of 330 minus 1 over 2 cos squared of negative 45. We are subtracting 1 over 3, the sine of negative 30. So reductions of special angles. So where do we find 330? That's the fourth quadrant, which is 360 minus 30. But in that quadrant, the cos is positive, no? So meaning that this is going to be 4 over 3 cos squared of 30 minus, you know that the cos of a negative is the same as the cos of a positive. So this is not going to have any effect on that. So it's 1 over 2 cos squared of 45. And then pull out this negative. So it's going to be positive 1 over 3 sine of 30. Remember? Oh, they never told us that because they always say without using a calculator. Yeah. All right, so that's 4 over 3. We know that the cos of 30 is basically root 3 over 2. But this will be squared. Minus 1 over 2. We know that the cos of 45 is supposed to be 1 over root 2. But then when you square that, it's going to give us a half. Or you can say it's root 2 over 2. But it's just the same thing. 1 over root 2 squared plus 1 over 3. The sine of 30 is just a half. Okay, let's simplify with the squares. So it's a 4 over 3 multiplied by 3 over 4. Now, this is going to be a half. The 2 cancels the 2, which means it's just the 1 left. Plus, this is, we said, a half, not a third. It's going to be 1 over 6. Now, this cancels that cancels it. So 1 minus 1 plus 1 over 6, meaning that our answer should be just the 1 over 6. All right, so 6 marks done. Then 6.2, we need to prove that the sine squared of 1 minus cos is equal to that. You can do this very fast for 3 marks. Why can't we do it here? So we know that cos, let's use the identity, is the same as 1 minus cos squared theta over 1 minus cos theta. So we're starting from the left-hand side. So difference of 2 squares, 1 minus cos theta into 1 plus cos theta. Everything is divided by 1 minus cos theta. So this cancels that. Oh, there's a minus 1 there. Okay. Then we have 1 plus cos theta minus 1, which gives us what? Cos theta, which is equal to the right-hand side. All right, I was worried because I'd left out that negative 1. Okay, then 6.3. 6.3, what are we doing? We are solving for A, general solution. So we have sine 2, no, it's 2 sine squared A. Okay, this is 6.3. So 2 sine squared A plus sine A minus cos A must give us sine 2A. And then you're telling us that A must be, or sine of A must be greater than 0. In other words, it should be positive. Okay, so what can we see here? What can we see here? Let's move this on this side. So 2 sine squared A plus sine of A minus cos of A minus, let's just simplify that, 2 sine A cos A is equal to 0. Okay, so I'll push, I don't know which one to push and which one to, but it's just the same thing. I'll do the grouping. Okay, I can do the grouping here, this and that, and then all of this and that. So what's common? What is common there is going to be the sine of A. I have 2 sine A plus 1. What's common here, I'm going to take out the negative cos of A. I'll be left with 1 plus 2 sine A. So meaning that this bracket is common, which is 1 plus 2 sine A into sine A minus cos A is equal to 0. Okay, so how many marks? Should be like 6 marks, this question. Oh, it's 7. Hallelujah. Okay, so let's solve this. So with the first one, it simply tells us that sine A is going to be negative a half. In this case, we're going to say that the sine of A is equal to the cos of A, meaning that the tan of A is just a 1, okay? Now, after identifying something like that, since they told us that sine of A must be greater than 0, this is less than 0, so this is a not applicable kind of situation, or we're not going to use any solutions from it. Our focus is going to be this side. So let's get the reference angle by saying the shift tan of 1 should give us the A, which is like a 45. Okay, so we know that when the angle is 45, the sign is positive. That is quadrant number 1. In the second quadrant, we can have 180 minus 45, which is giving us 135. So in the first quadrant, we're saying A is going to be 45 plus 180 times K. K is an element of integers. Okay. And then with the second quadrant, it's going to be 135 plus 180 times K. K is an element of integers. But did the question want the exact values? We just said solve for A. Okay, so we can stop at it. We can stop at this, where we have the general solutions. All right, 6.4. Now they are twisting questions again. P is X and Y is a point on AB, whereby that angle is theta, the norm P is a rectangle, express BP in terms of Y and theta. BP, this one, in terms of Y and theta. So this is X, then this is Y. BP. Okay, so we can, which they want it in terms of Y. So we're looking at the opposite and we're looking at the hypotenuse, which is the sine. So 6.4.1, we're going to say that the sine of theta is equal to the opposite, which is Y, over the hypotenuse, which is BP or PB. Then just switch or cross multiply, meaning that BP is going to be Y over the sine of theta. I don't know, that's what I'm getting. 6.4.2, hence can we prove that AB, where is AB? So this is Y over sine of theta. AB, this entire thing, must be given as Y over sine plus X over cos. Hello? Okay, so what I can see is that if this is a theta, even this will be a theta in a way. But now we're focusing on the bigger picture there. Okay? If this is a rectangle, if that's a y, this must also be a y. If this is x, then this is going to be probably m minus x. So what do we do here? What do we do here? So we know that this line is going to be parallel to that line, technically. So if this is a theta, we could also look at just this triangle alone and say that the sine of theta is equal to the opposite, which is AN over the hypotenuse, which is AP. Okay, meaning that our AP is going to be the AN over the sine of theta. But the question is focusing on the cos. I don't know, why am I using sine again? That sine is not going to help me. Let me use the cos pattern C. Let me use the focusing on ANP. Let's use the cos. So cos of theta is the adjacent, which is NP, over the hypotenuse, which is AP, meaning that your AP is NP over the cos of theta. Okay. But they told us P is what? X. So meaning that my interpretation of this X was wrong. The all of this is X. So it's going to be X over cos of theta. So for me to get the AB is going to be the AP plus the PB. So the AP that we found was X over cos of theta plus the PB that we found was Y over sine of theta. Okay, question number 7. Question number 7. Telling us in a quadrilateral ABCD, these two lines are parallel, beautiful. AC bisects BCD. If our X is a B and then the C is 2Y. Now, if it's being bisected, simply means this is a Y. That's also a Y. Now, they want us to express DAC. DAC in terms of Y. So we know that DAC is going to be a Y. Okay. DAC is going to be a Y. Why? Because those are alternate angles. No? And then ADC. So if this is a Y, that's a Y, meaning that the ADC is going to be 180 minus 2Y, the angles in a triangle. So 180 minus 2Y. All right, then 7.2. Are we able to show, okay, that AC, this one, is given as this? So let's use they say A, this is A. So let's use the sine rule and say that A over sine of Y should give us AC over the sine of 180 minus 2Y. Our focus is the AC, so we're going to multiply that side. So our AC is going to be A. When we simplify that, that's going to be sine 2Y over sine Y. I think that's what the question wanted. You don't need to break that down further to give us A equals Y. Then can we show that AC will be given as this? So we're seeing sines all over. Okay. AC is having a BC. So we already found our AC to be A sine of 2Y over sine Y. Now, if this is a Y and then this is X, meaning that this angle here is going to be 180 minus X plus Y. Okay, because you add that and that to give us, okay. They want us to show that AC is still that. So what I can do, we have a BC of interest. and then that. Okay, perfect. So I'll say that AC over we have the sine of x is equal to the BC over the sine of 180 minus x plus y. So make AC the subject. So you're going to have a BC sine of x over, when you reduce this again, we're going to have just the sine of x plus y. Okay, perfect. Then can we show that BC is giving us that? So let's equate the two equations of AC. So BC sine of x over sine of x plus y is equal to our AC that we found as 2. We got it as A, not 2. It's A sine 2y divided by, we got the sine of y. Okay, let's do the cross multiplication and leave this on one side. So you're going to have A. Let's break this down, which is going to be like a 2 sine y cos y. And now I'm multiplying it by the sine of x plus y. And then I'm dividing it by the sine of y and the sine of x, because this must go down, this must go up. So this cancels that, meaning that we have our 2a cos y, the sine of x plus y, and then we're dividing this by the sine of x. Okay, so that is what we have for that particular question. All right, question number 8, which is the trig functions, and telling us that the diagram below represents two graphs of trig between 0 and then 180. Then can we identify these functions by writing it in the form of ... So we know that 8.1, when you look at the f, between 0 up to 180, it's just in this format. So this looks to be like a sine graph, because it must just finish up this up to 360 loop, then you're done. The maximum is the 1 at 90, and then that. So what I'm going to end up with, it should be just a simple sine x. Okay. Then with the g, from 1 to -1, it's 180. That's going to be -180. Oh, so it's a negative, meaning that it should be a negative cos of x, no? By the look of things, because it is flipping. So if I have to extend this, it should be in that sort of format. So negative cos x. Then the range of g. So range is basically the y values for which the graph is valid. So it's going to tell us that -1 is less or equal to y, less or equal to +1. Then the period of f is just going to be a 360. Then the amplitude of g is just a 1. That's the maximum displacement that we can ever get. And then for which graphs will this and that be less than 0? So between 0 and 90, okay, we're saying that if this is a positive and this is a negative, so the graph of f is decreasing while g is above. Graph of f is decreasing in this section while g is above. So from 90 up to 180, okay, so we're seeing that, that's number 1. So 90 up to 180, okay? And then if this is a negative and this is a positive, so the gradient is increasing while this one is below. Increasing while the other one is below. F is increasing while below. So between 0, okay, so we can see that even between 0 up to 90. So it's the same as the entire thing actually, between 0 to 180. I don't know why we should break it down. So 0 to 90, 9 to 180. So even if somebody says 0 is less x and less 180, it will still be perfect. It would still make sense, okay? It would still make sense. Okay, so that is what we're going to say. But then remember at 90, both graphs are equal. Is that true? No, it's way far away. It's not. Okay, so that is 8.5 and question 8. Then question 9, we have our, does it look like Euclidean? Yes. A is a tangent to the circuit O, or circle OD. AC is a straight line. BD or DCD are drawn. Okay, there we go. 9.1, what do they want? If B1, okay, is a 5, 7, can we give reasons for ODE? ODE. So we know that this is a 90. Tangent perpendicular to the radius. So ODE is a 90. Reason, radius perpendicular to the tangent. 9.2. 9.2. They want us to get D3, this angle here. So for us to get D3, we know that this is a 57. We know that the whole of this is a 90. Then we can get this to be a 33. So start by getting C2. So tell us that C2 is a 33. Those are basically angles in a triangle. Okay. And then we're going to say that D3 is going to also be a 33. The angles that are opposite, equal sides. Okay, so that is what we have with that 9.2. Okay. Then someone could also look at it in a different way. What do we mean in a different way? If they can find D1, then they have found C1, which is the same as the D3. Okay, so if that is a 57 for D4 here, using the turn code. Okay, so D4, someone could say that D4 is a 57, meaning that 90 minus 57 gives us that. So either way, we'll get the same answer. Then they want us to get C2. So this is a 33. Must get C2. Oops, this other angle. Oops. So we're going to say that our C2 is going to be 180 minus 33 angles on a line, or adjacent supplementary angles. So 180 minus 33 is giving me 147. So that is how quick I would have obtained that for 4 marks. Because one, I've already clarified that my C1 was a 33. Who said C2, man? We said C1, not C2. We're saying something else, we're writing something else. Okay, C1 is a 33, then yeah, so you get the 4 marks for that. Alternatively, somebody could find D2. Then after getting that, you focus on the exterior angle. You plus this 57 together with this 90. Does it make sense? Yes. 57 plus 90, we should get 147. And then you focus on the exterior angles of a triangle. Okay, so that is another way to kill this question. Question number 10, you must prove the angle at the center being twice angle or the circumference. Can we prove that theorem? So step number 1, construct. Okay, construct a line in that matter. So tell us that draw the line KO. Draw the line KO produced to a letter maybe T. Produced to T. So what that does is it breaks this into 2. So if that is 1 and 2, okay, then we're going to say that O1 is the same as if I also break this down into 1 and 2. It's going to be K1 plus L. Okay, reason, those are exterior angles of the triangle. So this and that will be the same. But, okay, we know that but K1 is the same as L. Those are angles that are opposite. equal sides, meaning that our O1 is going to be twice of K1. We do the same using that other triangle and say that our O2 is the same as K2 plus M, exterior angle of the triangle. But we know that our K2 is the same as M, angles opposite, equal sides, okay? Because we know that this is the same as that already, meaning that our O2 is going to be twice K2. All right, then we know that O1 plus O2 should be the same as 2K1 plus 2K2. So twice K1 plus K2 is the same as this angle, LOM, okay? Which means that LOM is the same as twice. K1 and K2 is the same as LKM. So that is what we get for that particular question. All right. So those are the 5 marks for that question. And then 10.2, O is the center of the circle. So whenever they give us the proof question, chances are high, whatever follows should be an application, okay? So then, if XY is a tangent, okay, the circle Y, X, P, Q, U, and Y is still straight lines at that. Let me just do this. Okay, and then Y1 is M. Okay, this is M. All right, so 10.2.1. Did I skip a question? No, I haven't. I haven't skipped a question, not at all. Okay, so the first question, can we write down with reasons the other angles that are equal to M for 3 good marks? Wow. Wow, let's get these 3 marks. Okay, they want 3 angles with reasons. Ne? Okay, so I'll say this is 10.2.1. So which other angles are the same as M? Number 1, we have T1, because that is like a turn chord. Okay, this is M. Then, which other angle do we see? What did they tell us? XY is a tangent. They told us that PX and PY are the same. So this and that will be the same. So if that is true, meaning that the angle X is also M. Angles opposite, equal sides. So this is also M. So we have this one, then which other angle can we look at? Do we have a butterfly somewhere? I guess so, because I'm seeing this and that and that and that. Meaning that if we have this, that's not coming out the way I want it. It's not coming out the way I want it. Okay, so let's look at the circumference. Let's look at the circumference, because this one is at the circumference. This one is at the center, which is going to be like 2M. We need another angle. They said 3 or 2. I might be doing a whole lot of things yet. Oh, they said 2. Oh, thank goodness, because we're going to sleep here looking for another M. Okay, write down with reasons 3 other angles that are equal to 2M. Oh, we've already found one. So O1 is 2M. Hallelujah. So it's 2M. Reason is going to be angle at the center. Must be twice angle at the circumference. So if that is 2M, okay. Tangents and what? Do they make sense? We need to look for another angle. We need to look for another angle. So if this is that and that is that, so what is T? No, that's not going to make sense for me because T is not going to work for me. Let's look at P3 and see. P3, would that make sense? Where I look at this angle. Yeah, it would make sense because it is exterior to these two. So we're saying P3 is going to be 2M. That is exterior angle of triangle XYP. Okay, so this is a 2M. Do we have any parallel lines? No, we don't have parallel lines. So we need to look for the last one, which now brings me to the bow tie. It is this and that, same coordinate or angles in the same segment. So it means T2, this angle in this one will be the butterfly or the bow tie. So T2 is 2M, angles in the same segment or angles subtended by the same chord. So that is what we needed for 6 months. Hallelujah. We move on. Question number, last one. ABC. Okay. ABC is acute angled, that is inscribed. Again, big English. No? CF and BE are perpendicular. CF and BE are perpendicular. Oh, wait a minute. What did I do? They said CF and BE are perpendicular to BA. Where is BA? CF, okay, and BE. This one. They're perpendicular to that and perpendicular to that. Okay, CD is the same as DB. Okay, already given. OA is produced, custard, the circle, G is drawn. Beautiful. Let's see. What do you want now? Question, what do you want? Can we prove that AFDC is a cyclic chord? AFDC. Okay, so if this is a 19, this is also 19. I want us to prove that this thing is a cyclic chord. So remember, with the cyclic chord, only thing we need to prove is that opposite angles are supplementary. We need to also look at the exterior aspect and also focus on the bow tie. Okay. So 11.1, we're going to say that D3, okay, this is going to be a 19. Why? So D3 is a 19. Where can I write that? Let's put it here. D3 is a 19. Line from the center bisecting the chord must be perpendicular to the chord. So line from the center, or we can say the perpendicular bisect. Oh, is that correct? No. It's a line from the center bisecting the chord. That's perpendicular to the chord. Okay, so if that's a 19, are we going somewhere? Then we know that F3 is a 19, which is given to us. And if that is true, so if this is a 19, this is also a 19, then we have the bow tie. Hallelujah, that is done. That is done. And we're saying that since D3 is equal to F3, therefore AFDC is a cyclic chord. We're using the converse of angles in the same segment. Okay, so that is that. And then can we prove that C2 is the same as C3? Can we prove that C2 is the same as C3? So in other words, they want us to prove that this line bisects those two. Okay. So what we need to do is, what is C2? We know that C2 is going to be the same as A1. Okay, since we've just proved the bow tie kind of approach. So C2, let me just use this. Okay, C2 is the same as A1. Okay, because of that. Then, in the same respect, we can say that A1 is the same as C3 because of, again, the bow tie. There's another bow tie, this one, this, and that. That since we proved that this is a cyclical, then this and that will be. So now, since we've seen that the both of them are that, then C2 will be the same as C3. Oh, we need to give reasons now. It's going to be angles in the same segment. Same story, angles in the same segment. And then we move on. We move on to 11.3. Can we prove that ABD will be similar to CGD? Let's see. ABD. Where is ABD? ABD. ABD, this one is similar to CGD. To CGD. Similar to that. Okay, so let's highlight what we see from the two triangles. Let me just put it in. So one thing I know is that all of this D4 is the same as D2 and D1. Those are vertically opposite. We know, because when you are proving this, you need to use angles, strictly angles. Now we saw that this is the same as this, meaning that this should be the same as this entire thing, B1 and B2. Okay, so we're saying that B1 plus B2 must give us G. Those are angles in the same segment. Then we're saying that D1 plus D2 must give us a D4 vert op angles. And then we say C3 is equal to C1. We've proved that in the previous question. Therefore, CGD is similar to ABD because of angles. All right, so that is how we prove that. And then lastly, 11.4, can we just sort that out? So we know that in the triangle OCD, GCD, because these are the triangles we're focusing on, okay? We're saying OCD, how is OCD a triangle? It is, Malumi, because we're focusing on this. Because this is also similar to those two. Okay, there's a 90, this is also a 90, this is a 90, those are the certain. This was the same as that, and then which means this will also be the same as that. So we know that those two triangles are similar. So what we're gonna say? What are we gonna do? What are we gonna say? Because it is 6 marks. Can say that C2 is the same as C3. We've proved that. We've proven that one, okay? Then D3 is the same as D4. Okay, what is the reason for that? Say D3 is the same as D4, angles on a line, which is also a 90. Okay, angles on a line. Then CD will be also CD, which is common, meaning that the two triangles are congruent. Therefore, we're saying OCD is congruent to CGD. So the same thing. So if that is true, we're going to say that AB over CG should be the same as BD over DO. Okay, so that is what they needed, because if the two triangles are congruent, then these two sides are equal. Boom. Okay, guys, out of 100, I can rate this paper to H because of the big English and, let's give it a 95, guys. It wasn't that bad, but it was fair. Okay, so guys, I'll stop there. I wish you all the best in your preparation. Let's meet when we look at the memo of other provinces for paper 2. Bye-bye. Hello, welcome you to this episode where we shall be looking at the proposed memorandum of Limpopo Grade 12 Mathematics Paper 2 for June 2025. Okay. Now, with this paper, we have 3 hours for 150 marks, and then the paper has 11 questions. Wow. Why so many questions? Okay, so the others are just basic instructions of paper 2. Then question 1, which is the statistics. Now, for some provinces are not including statistics within their scope for their own reasons, okay? But in Limpopo, we had statistics there. But of course, statistics that will be just the grade 11 and grade 10 statistics are not necessarily the grade 12 statistics. Okay, so with the first question, they're telling us that a certain grocery store's delivery service has grown over the past 2 years. And then the store owner did a survey on a specific day to improve their delivery performance. And then the following table represents this. Okay. All right. So we have the delivery time and then the performance, the number of deliveries. And they want us to complete the cumulative in the answer book. So I'll just put the cumulative just down here. So the first cumulative will always be the first frequency. Then 8 plus 5 is a 13. 13 and 12 is a 25. 25 and that is a 40. It's a 43. 43 and 22, that is a 65. 65 and that's going to be 90. That is 110. 125. 135. And then 140. That's my last cumulative. How many deliveries did we have altogether? Let's see. They never told us. That's weird. But it's fine. Let's take the 140 to be our last cumulative that we're getting. Then 1.2, they want us to draw an ogive to represent the information. How many classes do we have here? How many classes do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, 10. Okay, so I'll just try to sketch an ogive this side and see. Okay, so if we have this as our, let's use this color, perfect. That is our cumulative. And then we can have the time in this format. Okay, so we know that the deliveries started at 8. Okay, so we can have this as 8. And then we can have 9, 10, 11, 12, 13, 14, 15, 16, 17. The last delivery was 18. 1, 2, 3, 4, 5. I don't need to count them. Yeah. Okay, so whenever we are plotting, okay, let me indicate this side. Our maximum cumulative is 140. So I can use 20, 40, 60, 80, 100, 120, and probably 140. All right. I'm sorry if the intervals are not that clear. It's just that it's a sketch. So we just need to have the shape. So whenever we are plotting, we said we only use the upper class intervals. Okay, so 9, 10, 11 up to 18. So 9 is going with 5. So I'll say 9 is 5, which is somewhere there. And then 10. Okay, 10, we're going to take a 13. And 13 is still below 20, which could be somewhere there. And then we have 11, which is a 25, slightly above 20. Okay, and then we have 12, which is a 43, slightly above 40, somewhere there. Why does it look like a line for me? Okay, then we have 65, slightly above 60. Let's have it somewhere there. Okay. In this paper, we're going to be looking at the proposed preparation, okay, for the mathematics paper 2 for grade 12 for the June of this year, okay? And so I have a paper that is out of 150 for 3 hours, and let's just use it for our reviewing purposes. So they're telling us that we have a total of 9 questions, and there's a special answer book, okay, which is that side. And so if I'm to look at it, it has everything that is needed. Okay, it's not a big deal. Then show all calculations, diagrams, okay, answers only. It's just the usual instructions. We need to read them and understand. And then question number 1, which is data handling, or some people call it statistics. Okay, so they're telling us that a researcher observed the number of liters of fuel that were purchased by motorists on a certain Saturday. The data collected on that Saturday is represented on the histogram. Okay, so between 0 to 10 is 1 person. And then between 10 to 20 is 4, 6, 12, 18. We have 7. Okay, let me just, it's a 1, it's a 4, it's a 6, it's a 12, 18. We have 7. And then we have 2. And then 1.1, they want us to write down the total number of motorists that purchased. So by looking at all the totals, this is a 30, that's a 40, and then we're going to have 50. If you add up everything, we are getting 50 motorists. And then write down the modal class. So modal class on a histogram is the tallest bar. Okay, or the class with the highest number of clients or motorists. So it's going to be 40 is less or equal to X is less 50. So that is the model. Then 1.3, they want us to complete the frequency table that was provided. Okay, let's see what the frequency table is offered. Okay, so between 0 to 10, we said we have 1 for the frequency. And then the next one was a 4. So 4, 6, 12. And then we have 18. We have a 7, then a 2. Then we are getting cumulative. The first frequency will be the first cumulative, meaning that it's a 1. 1 and 4 is 5, 5 and 6 is 11, 11 and 12 is 23, 23 and 18 is 41, 41 and 7 is going to be 48, and then we're going to have a 50. Okay, so that is our cumulative frequency. Then 1.4, they want us to draw the ogive. Okay. Ogive, remember, it's a cumulative frequency graph. Let's see. So we have 1. We said we have 5. So 1, 5, 11. 23, 41, 48, and then 50. Okay, so whenever you're drawing the cumulative frequency graph, you look at the upper intervals. In other words, we're going to plot these 10, 20, 30 up to 70 against the cumulative values. Okay, so we're saying that 10 is going to go with the 1 because it is our first frequency. Okay, these are intervals of 2, 2, which means 1 is going to be somewhere then. And then 20 will take on the 5, 2, 4, which is somewhere there. And then 30 will take on 11, which is just slightly above there. And then we have 23, 22, this is a 23 somewhere there. And then 50, we have a 41, which is somewhere there. And then next we have a 48, which is somewhere there. And then 70, we have a 50 on the dot. Is the last interval 70? Yes, perfect. So if that is correct, then we just have to join the points using our freehand. Okay, so it's something of that nature. Okay, but then we need to ground this to the origin, which is 0. Okay, so that sort of graph will give us the 3 marks that the question is awarding. And then 1.5, they want us to estimate, okay, the lower quartile. Now remember, lower quartile is the same as 1/4 into n plus 1. Okay, that is the approach. So we know that we have a total of 50. What is a quarter of 50? Because I'm trying to get the position which I'm going to use to locate it. So 1/4 into, let's say 51, okay? So 51 divided by 4 gives me 12.75. If I used 50 on the dot, I was going to get a 12.5. So let me just check around that. 12.5, 12.75, okay? So if this is a 10, this is a 12. Okay, let's just check somewhere there. Okay, we'll follow this. Sorry, I'm not having a ruler, but I'll just try to follow that. Okay, so that is where I'm ending up. For now, this is going to give me a 32 as my Q1, which might be slightly bigger, because if I'm to look at necessarily the 12.5, remember halfway is going to be 13. So literally we can take 31 to be the most accurate answer of it. Okay, so Q1 is a 31, but in this case we got a 32. We cannot give anything different compared to what we got. So 32 is what I'm going with, but 31 would also make some bit of sense. Okay, and then 1.6, the question wants us to get the estimate mean. So when you're getting the estimated mean, remember, it's the midpoint multiplied by the frequency. Okay, midpoint is like we're going to get the halfway of these intervals. So it's going to be a 5. This is going to be a 10. No, that's a lie. That is a lie. It's a 15 because it is 20 plus 10 divided by 2, which is 15. And then this is going to be a 50 divided by 2, which is going to be a 25, a 35, a 45, a 55, and then a 65. And then I'm going to use this against the frequencies that I see there. Okay, so we are saying the first one was a 5 multiplied by the frequency 1. The second one was a 15 multiplied by the frequency of 4, followed by 25 with a frequency of 6. And then 35 with a frequency of 12, 45 with 18, 55 with 7, and then 65 with just a frequency of 2. All of this is going to be divided by a total of 50. So this gives me 39,2. All right, then 1.7, they want me to determine the 70th percentile. So 70th percentile, that's like the Q3, which is 3/4 of 50 plus 1, or 3/4 of 50. So punching this into the calculator, I'll get a 37,5 just as the position. Let's use 50. So 3/4 of 50 is 37,5. Then come to your cumulative, look for your 37,5. So this is 32,406. 37,5 is just close to 38. If you draw your line that is next to 38 there, I think we can use just a line of 38 and we just estimate it. So somewhere below there. Okay, so when I drop this line down, this could be a 48 or it could be a 49. It's 48 or 49. I don't know which one we're going to go with, but it's okay. Let's go with the 48. I think that would make sense, because we're just saying slightly below. So 48, 49 there. So I'll take that reading as a 48. So start by getting the position and then use the graph. Okay, then 1.8, determine the interquartile range. Now with the interquartile range, remember we said it's Q3 minus the Q1. So our Q3 is 48, our Q1 we said it was a 32, which should give us, is it a 16 or a 26? 48 minus 32, that's a 6 and 1. So it is a 16. Okay, then 1.9. 1.9. Determine the number of motorists at 75 percentile or above and calculate the total reward spent by the petrol station if each of these motorists are the 75th or above, about 60 liters each, with a reward of 0.4 rands per liter. So we need to find out how many people are above the 75th percentile mark. Now from our graph, or from our OGIF, we saw that it was, how much? It was 37,5, ne? I think so. We saw it from this side. It was 37,5. So if we have a total of 50 motorists, and we're talking of 37,5, or roughly let's talk about 38. So 50 minus 38 gives us 12 people that are just above the Q3 level. So from here up to there, there's just like 12 motorists. Okay. Now, the question is telling us that every motorist is going to get a 40 cents for each liter that was bought, and they bought 60 liters in total. So we can say that 12, determine the number, okay, calculate the total reward spent by the church. Okay, 12 multiplied by 60 multiplied by 0.4. I think this would make more sense now. So we are getting 2 comma. It cannot be a 2 comma because that's going to be 72 times 4, which is 8. So it's 288 rands that the petrol station would spend. All right, so that brings us to the end of question number 1. Then question number 2, they are telling us that in the diagram below, S is negative 48, T is that, and M and U lie on the same straight line. R is this much, T is that much. We also lie on another line, RV and SU intersect each other at T. M is the x-intercept of the line at -8. SM is the same as MU. So this is the same as that, which makes this a midpoint. Okay. And then they want us to get the gradient of RV. So 2.1. So with RV, we have R, we have T. In as much as we don't know the coordinates of V, so we can use RT. So gradient of RV will be the change in Y over the change in X. Or someone can say Y2 minus Y1 over X2 minus X1. They said calculate the gradient. Yeah. Meaning that, but the question is not realistic. Why do I say that? Because they never specify whether they want the gradient in terms of age or just the gradient in general. So if we are to follow just the paper the way it is, they want the gradient, meaning that either someone can give it in terms of A, or someone can give it with just a normal number, which makes sense. Ne? So I'll say 6 minus 4 over -12 minus -6. That's going to be 2 over -6, which becomes -1 over 3. If someone was using the A's, then there will be an alternative to say that it says, okay, A minus 12 minus 6, which will be A minus 18 over A plus 2 minus 12, which becomes A minus 10. So this would also be a gradient in that case. And it would be correct because we know that the point T, point V, and point R, they are all lying on the same straight line. Okay, alternatively, someone would also look at the A2, A minus 12 with a T, which would also now bring another scenario to say it's A minus 16 over A minus 4. Ne? Is it minus 4 or plus 4? It's a plus, so it's A2 and that, which is a plus 8. Something like that. I believe that would also be another approach. Okay, find the length RT, so we're gonna use the distance formula. So with the distance formula, we know that with the square root of x1 minus x2 squared, and then y1 minus y2 squared. When you substitute, it's going to be minus 12 minus -6 squared plus, that's going to be 6 minus 4 squared. Okay, so punching that into the calculator. Okay, punching it into the calculator, I'm ending up with 2 square root of 10 units. And then they want us to get the value of A. Now for the value of A, we've already seen the assumptions because we're treating these RT and V as collinear points, meaning that if I get the -1 over 3 and then equate it either to this or to that, I should be able to get my answers. So I'll use A minus 18 over A minus 10. Is it 18 or 14? Nice, because it is A plus 2 minus -12, which is supposed to be a plus 14. Okay, so if it's a plus 14, do your cross multiplication, meaning that your negative A minus 14 is equivalent to 3A minus, that's 54. If I move this one that side, it's going to be minus 3a minus 54 plus a 14. What does it give us? Okay, so you have a minus a minus 3a is equal to minus 54 plus 14. So minus 4a gives us a minus 40. Divide both sides by minus 4, meaning that a becomes just a 10. Okay, then if Sm is the same as m, you determine the coordinates of u. Remember we said m is going to be a midpoint. Ne? So if our u is xy, our m is negative 8, 0. And then what are the coordinates of s? We have negative 4 and 8. Okay. Then let's apply the midpoint formula. Meaning that if we get the negative 4 plus x divided by 2, we must get negative 8. And then if we get negative, is that negative or it's the positive 8? Plus y divided by 2, it should give us a 0. Okay, so when we cross multiply, that's going to be negative 16 plus 4, meaning that x is negative 12. Okay. If x is negative 12, and then when you look at the y is going to be just a negative 8. So meaning that u is going to be negative 12 and negative 8. Okay, then they want us to get the equation of the line SU. So for us to get the equation, remember we need to always get the gradient first. Okay, so you can say that the gradient of SU is change in y over change in x. We can use just these 2 points and say 8 minus 0 over minus 4 minus minus 8, which is just going to be 8 over 4, which is a positive 2. And then we can still use this negative 8 and 0 and say y minus 0 is equal to 2 into x minus minus 8. So y becomes 2x plus 16. Okay, and then next they want us to get the size of UTV. UTV. In other words, we must find the angle, this angle here. So what we need to know is that we found the gradient of this line to be a 2. We found the gradient of this to be negative 1 over 3. If we focus on this sort of triangle here, we can use the inclination method. We find this angle, then we subtract the 2. Okay, so if I call this my theta, call that your alpha, I'll say that my alpha is going to be the shift tan of negative 1 over 3. Is that correct? Yes. Okay, so shift tan of negative 1 over 3 is going to give me a negative answer. And remember, we said whenever you get a negative, you must always subtract from 180 so that you get the positive answer. So shift tan 1 over 3 is giving me 18, but it's negative now. So negative 18,43, and then I must plus 180. Okay. When I plus 180, I'm getting 161,57. And then my theta, it will be the shift tan of 2. Okay, shift tan of 2 gives me 63,43. Okay, then I need to subtract the 2 because we said alpha minus theta gives us the UTV because of the exterior angle. This one minus this gives us that. Okay, so it's going to be 161,57. You subtract 63,43. And that gives me a 98,14. Okay, 98,14 degrees. And then 2.7. If TV is 4RT, if TV is 4RT, okay, remember our RT was 2 root 10, meaning that if we multiply this by 4, which becomes 8 root 10. Okay. Can we determine the area of TUV? TUV. Now, since we got this angle to be the 98,14, the only thing that is missing is the distance TU. That's the only thing we need to calculate. And if we can get that distance, then we need to go with the area. Okay, so I'll write it aside and say that our distance TU, this is 2.7. Remember the coordinates of T are just -6 and 4. And then the coordinates of U, we got -8. And then there was another negative. Which number was that? -12. So it's -12 and -8. Okay, and then we just punch this into the distance formula with the calculator. So -6 minus -12 squared, 4 minus -8 squared. And then this gives us 6 root of 65. Okay. And then when I use the area rule to say it's going to be a half TU multiplied by the distance that we got first, which was the TV or the V. Wait a minute. Oh, we need the TV, which we just got now. And then the sine of UTV. So it's a half multiplied by 6 root 65 multiplied by, we say that's going to be 8 root 10. Okay, and then the sine of 98,14. Okay, so when we punch this, I'm ending up with 168. This is units squared. All right, guys, so that brings us to the end of question number 2. Then question number 3. In the diagram, T is the center of the circle, x squared plus y squared. Okay, minus 12x minus 2y minus 8 gives us a 0. It's the equation of the circle. BC is the diameter. Okay. AB is a tangent to the circle at point B. S is the point AB. And then the equation of the line ST is given as that. The inclination is 172, this much. AC. It's very big now. If this is extended to the x-axis, this angle here is 172,875. It's almost a straight line. Okay, so, and that's what we have. Then they want us to get the coordinates of T. Remember, T is the center. And what we do, we just have to complete the squares, whereby we look at half of this, half of that. Okay, they don't want the radius in this case. So it's not a big deal for us. Okay, so it's either we express it in the form of completed squares, or we can just go ahead and get what is needed. Okay, so that's going to be x, said minus 6 squared. This is y minus 1 squared. I'm going to say is equal to, that's going to be 8 plus a 36 plus a 1. So it's x minus 6 squared plus y minus 1 squared is equal to 45. I'm squaring 6 to give me the 36. I'm squaring the 1 to give me that plus the 8. So meaning that the coordinates of t will be 6 and a positive 1. Okay, then determine the coordinates of b, which is the y-intercept of the circle. So for y-intercept, we know that x must be a 0. So from this equation, now why not use the summarized format? Okay, we're saying x minus 6 squared. This is y minus 1 squared is 45. So if x is a 0, which means we have just a 36, y minus 1 squared is equal to 45. Move the 36 that side, which makes it a 9. So y minus 1 equals a 9. Then let's find the square root here. So y minus 1 is plus or minus 3. So if I use a plus, y is going to be a 4. If I use a minus, y is going to be a negative 2. So meaning that b, since it's at the bottom, is going to be 0 and negative 2. Okay, so this 4 is just for the top part, where the graph, where the circle is touching the y-axis. Then show that ST is parallel to AC. Must round off answers to 3 decimal places. We need to prove that ST is parallel. Okay, so how would we approach this kind of question? Did they give us the equation of ST? Yes, they told us it's this. Meaning that the 8y is going to be the same as negative x plus 7. Divide through by 8. Y is going to be negative 1 over 8x plus 7 over 8. And then let's see. If I extend this line to the x, if I get the same angle as this one, then we're good to go. So let me call this angle theta. We are seeing that our gradient is negative 1 over 8. So I'll say the arctan of negative 1 over 8 plus 180. Okay, let's punch this in the calculator and we see, so 180 plus the shift tan of negative 1 over 8. It's giving me 172,8749, which is 5. So the angles are the same, meaning that the lines are parallel. The reason is going to be corresponding angles. So that is how you would have showed that. So since the angles are the same, therefore ST must be parallel to AC. Okay. Then next we have 3.4. It is further given that ST squared is 65. In other words, if we square this distance, we must get a 65. They want us, and the coordinates of A are negative 4 and K. Okay. They want us to determine the length of AC. Now, we know that if this is if these lines are parallel and T is a midpoint across this side, which means S should also be a midpoint. So we're going to use the midpoint theorem, which means the distance ST must be twice or must be half of AC. So AC is going to be twice ST. But we given ST squared is 65, meaning that ST alone is going to be the square root of 65. And then AC will be twice root of 65. Okay. The reason we are saying it's a midpoint theorem. So twice root 65 because of the midpoint theorem. Then 3.4.2, they want us to get the coordinates of C. Coordinates of C. Okay, what do we notice? This line is parallel to that one. We do not have, okay. I think we have this, we have that. If this is XY, then we can use the midpoint. I think that's quicker. Okay, so we're going to say X plus 0 over 2 should give us a 6, meaning that X is a 12. And then Y plus minus 2 over 2 should give us a 1, meaning that Y is going to be a 4. So 12 and 4 becomes the answer of interest. And then 3.4.3, they want the value of K if K is greater than 4. So we've already obtained the coordinates of C, okay, which means we can now use our distance formula to determine what is needed. Okay, so distance formula is going to be one approach. Alternatively, what we can think of is that since this is a tangent and the radius or diameter, the lines must be perpendicular. Okay, we could just find the gradient of BC and automatically we have the gradient of this together with the y-intercept, and then we substitute into that. I think that is quicker. Let's put it this side. That's 3.4.3. Okay, we're saying the gradient of BC, remember it was 0 minus 2, we have 6, 1. So 1 minus 2 is going to be 3 over 6 minus 0 is 6, which is a half. So then the gradient of the line AB is going to be negative 2. Okay. And then the equation of AB is going to be negative 2x minus 2. Y is minus 2x minus 2. Then at a point A, where x is negative 4, we're going to say k is minus 2 into minus 4 minus plus 8 minus 2, which is a 6. Okay, that's one way of also doing that. And then 3.4.4, they're telling us that equation of a circle, they want us to determine the equation of a circle that is passing through A, B, C in that form. Okay, so when you look at A, B, and C, then here there's another circle between A, B, and C. So if this is a 90, then automatically AC becomes a diameter. Okay, we've already seen the distance to be twice 65, meaning that the radius is just going to be a 65, and then that's also going to be a 65. So the only thing we need will be the midpoints. So here I have negative 4 plus 12 over 2. That's going to be 8 over 2, which is a 4. With the y, remember we got the k as a 6. So 6 plus 4 is 10, 10 over 2, which is 5. So it's going to be a 4 as well as a 5. Ne? Then my equation will be x minus 4 squared. Then y minus 5 squared is equal to, the r is square root of 65, which is just going to be a 65. So that becomes the equation. But the first things first, you need to get the radius and then you also find the midpoints. Question number 4, which is the trick. They're telling us that if the sine of 14 degrees is t, determine the values of the following in terms of t. So questions of this nature, we always advise learners to draw up a sketch. Okay, this sketch does not need to be in any quadrant. So 14 sine is opposite over hypotenuse. Then this is going to be 1 minus t squared if we use the theorem of Pythagoras. Then the one the cos 14 is adjacent over hypotenuse. So it's the square root of 1 minus t squared. Okay, I think that is correct. Or you can say over 1, but it's not a big deal. And then they want the sine of 38. So if this is 14, what angle is that going to be? It's going to be a 76. No? But we know that 38 is a half of 76. I don't know if that makes sense. It makes sense, no? So if ever I'm talking of a sine of 76, which will be the same as the sine, I think it's better I use the cos. I think cos is going to be much more quicker. If I look at the cos of 76, this is more like cos of 2 38. And then I can change this into a sine format, which is going to end up being 1 minus 2 sine squared of 38. Then I have to transpose so that I have a cos of 76 minus 1. Okay. But then I'm going to divide it again. Why don't I just shift everything to that side so that we avoid the negative parts? So it's 2 sine squared of 38 is 1 minus cos of 76. Divide both sides by 2 and then find the square root. So sine 38 will be the square root of 1 minus cos 76 divided by 2. Okay, we know that the cos of 76 is going to be t over 1. So mean that's going to be the square root 1 minus t over 2. Okay, and then the sine of 59. So how does 59 relate to any of these? Okay, it could be a special, we can create special angles from here that can connect with the 14. I think 45 and 14 will give us a 59, meaning that it's a sine of 45 plus 14. This is 4.1.3. Okay, so if I say the sine of 45 plus 14, and then I expand this, sine 45 cos 14, sine 14 cos of 45. So we know that the sine of 45 is 1 over root 2. And then the cos of 14 will be this root 1 minus t squared. And then the sine of 14, we got a t, 1 over root 2. So same denominator, so t plus 1 minus t squared over square root of 2. That is how I would have obtained that. You feel free to also rationalize and root 2 over 2, but I would leave it at that. Then 4.2, simplify into a single trig ratio. Okay, so when I look at this term, what does it give us? What is it showing us? 4.2. Okay, so I'm going to break it down into a single trig ratio of A. Let's put it aside. We have the sine. Okay, it's a sine of A multiplied by the tan over half A minus 360 minus 1. Okay, that is the question. But they want us to give it just as a single trig ratio. So what would be the options available in this case? Anybody? What would we do? Okay, I would start by changing this around so that I have a negative out. So it's a tan negative, that's 360 minus a half of 8. Then I apply my reductions. Okay. 360 minus is in the fourth quadrant and tan is negative. So this negative and the negative is going to give us just a positive. So sine A, this is going to be tan over half A minus 1. But now if I use the double angle identity of sine, because we know that a half and a half gives us just 1. Okay, so it's going to be 2 sine over half A cos over half A multiplied by, we know that tan is the same as sine over half A over cos over half A. We are subtracting a 1. Okay. And then I can cancel this and that because this is just a product of one thing. So we're left with twice sine squared over half A minus 1. From our double angle of cos, remember we have 2 cos squared of A minus 1, or 1 minus 2 sine squared A. So it's more like in this format. So take out the negative. Do we need to take out the negative? I think we can. 1 minus 2 sine squared half of A. And what will this become? To be a cos of A. To be cos of A. So, but since the question wanted one trig ratio, I have a feeling this is a +1, not a minus. Oh Lord, so now how things are changing. It's a +1. If it's a +1, then there's nothing we can do. Because I thought it was a -1 initially. If it's a +1, then it must stay as a 1. There's nothing we can do. It's a single trig ratio or a head. Okay, so that is that with that question. And then 4.3, we're given this function. And then they want us to prove that if we reduce this, we get to the tan of 2x. Okay, so let's see. Let's see. Remember, tan 2x is the same as sine 2x over cos 2x. So top, we must have that. Bottom must get to that. So let's reduce and see. So that is 2 cos x. Cos of 90 minus is going to give us a sine x over, that's cos squared. And then plus 180 plus, that's going to be a negative sine. And then this is going to be a positive cos. Now we are multiplying with the tan, which is sine x over cos x. So this cancels that. We're left with minus sine. So it's 2. Okay, let's simplify the top part, which is sine 2x over cos squared minus sine squared, which gives us cos 2x. And then that becomes tan 2x. Okay, and then 4.3.2, write down the values of x in the interval where this is undefined. So the graph of tan 2x will be undefined in a few cases, okay, where we have the asymptotes. And in this case, normally it's at 45. And then we could also have one at negative 45. Okay. 45 or negative 45. Because normally it's undefined at 90, but since we have a 2, then we're going to divide it by 2. Okay, x 45, x negative 45. And then 4.4, given cos theta plus 30 is a half sine theta. They want us to find the general solution. Okay. So with the general solution here, it's either we open up and get a single trig ratio. Okay, so opening here, we're going to have the cos of theta, cos of 30, minus sine of theta, sine of 30 is equal to a half sine of theta. We know that the cos of 30 is a root 3 over 2 minus a half sine theta is equal to 1 over 2 sine of theta. So we know that if I move this a half to that side, I'll have a root 3 over 2 cos of theta. Let me just move it that side so that I get a 1 sine theta. And then if I divide by cos theta and cos theta, I'll get a tan, meaning that tan theta is a root 3 over 2. And then I have to get my reference angle, shift tan of root 3 over 2 plus k times 180. But I need to look at both quadrants. So the first quadrant is going to be a 48,89 plus k times 180. K is an element of integer. So we know that tan is positive in quadrant 1, but also in quadrant number 3. So 180 plus 48, that gives us 228. Is it 228 or 2? No, man. This is a 40,89. Okay, then that's going to be 220,89 plus k times 180. K is an element of integers. Okay, so that is question number 4. And then question number 5, which is the trig functions. We are given the following. Okay, the graph of course between those intervals. Then they want us to write the period of f of x over 2. So meaning if it's the cos x over 2. We know that the period of a normal cos is 360. Then if you divide it by 1 over 2, it becomes 720. And then write down the range of this. Okay, so now since the coefficient, the coefficient is 1, which means it will go maximum 1, minimum 1. But they want the range after they have shifted the graph 1 unit downwards, which means it's going to be here and at a -2. So we're going to say 0 is less or equal to y, less or equal to, it's -2 actually. Less or equal to y, less or equal to 0. Because the smaller number first. Then draw the graph of a half sine 2x on the same set of axes. So if you use your calculator, okay, with a table and that method of drawing from the table. So mod the table, we type in our a half sine 2x. Okay. There is no gx, so we're gonna skip that. We're starting from -90. We are ending at 180. Our step is 45. Okay, so when x is -90, it's a 0. And x is -45, it's -1/2. When x is a 0, it's going to be a 0. When x is 45, it's a +1/2. And the 90 is going to be a 0. The -1/2. And then a 0. So we have something like that. Okay, so that's the kind of graph that we are getting. Okay, then 5.4, write down the minimum value of g of x minus 25. When they talk of the minimum, remember this minus 25 is a shift horizontally. Okay, it doesn't affect the maximum and the minimum, which is the vertical distance. So meaning that our minimum is still going to be -1/2. And then use the graph to determine the values of x, where sine x cos x minus this is equal to 0. So how do we relate this to what was given? Remember, the first graph was just cos x. And then the graph we were told to draw is a half sine 2x, and of which we know that half sine 2x is the same as 2 sine x cos x multiplied by a half, which gives us just the first part. Meaning that if we move this one that side, sine x cos x is the same as cos x. Graph of f is the same as the graph of g. So where do the two graphs intersect? Okay. So they're intersecting at 90. Okay. Then they're also intersecting at 90, which is positive. I think those are the only two values we have. So x is a -90, x is a 90. And then our question number 6, which is the 2D, 3D trick. Diagram below, Kn is a vertical tower, Lnm are points on the same horizontal plane. The angle of elevation is theta. We have the 30 and all of that. Then they want us to write down the size of MLN, this angle here. So if you get your 150 minus theta plus the 30 plus the MLN, we must get 180. So this and this is already 180. So mean that MLN is going to be a theta. Okay. MLN is just a theta. And then determine the length Ln in terms of sine theta and cos of theta. So since we're looking at sine and cos, how is that going to work? Okay. Ln. So we can use the sine rule and say that Ln, we are dividing it by the sine of 150 minus theta, should give us 24 over the sine of theta. But we know that 150 is the same as 90 plus 60. Okay, but we're going to subtract theta. I mean, that's the same as 90. Alternatively, someone would have said 180 minus 30, which would also make sense, because I really want to open this up, but I'm going to be left with no choice. Mm-hmm. 90 plus 60 minus theta. But it's fine, we can open it up here. So Ln is 24. That's going to be sine 150 cos of theta. Okay. Minus cos of 150 sine of theta. Everything is over sine of theta. We know that 150 is the same as 180 minus 30, so it's a 24. That's a sine of 30 cos theta. And then this is going to be cos of 180 minus, going to be negative with that negative, which is a plus. Cos of 30 sine of theta over the sine of theta. Okay, so we know that sine of theta is a half. Okay, 24, that's a half cos of theta. We know that the cos of 30 is a root 3 over 2 sine of theta over the sine of theta. Then we introduce the 24, which means the 12 cos theta minus, it's a plus 12 root 3 sine of theta. Everything is over the sine of theta. So this is what we end up with. And then hence, so otherwise, can we show that the height of the tower? Okay, this one. So we have this, we have that, so we can use the tan and say that the tan of theta is equal to Kn over Ln. We already have our Ln. So meaning Kn is going to be the Ln, which is the 12 cos theta plus 12 root 3 sine theta. Everything is over the sine of theta times the times tan of theta, which tan theta is sine theta over cos. So this cancels that. And then we're going to have a 12 cos divided by the cos. 12 root 3 sine over the cos. This cancels, so it's a 12 plus 12 root 3 tan of theta. And then 6.4, they want us to get the size of theta if the elevation angle, if Kn is 46. So let's just do the substitution and say 46 is equal to 12 plus 12 root 3 tan of theta. Move the 12 that side, then we divide by 12 root 3. So that's going to be a 34. We're dividing it by 12 root 3 is equal to the tan of theta. And then you must find the arctan of this angle. which should give us 58,56. All right, question number 7. In the diagram below, O is the center. Okay. With the circle passing through ABC, BD is a tangent to the circle B. Prove the theorem which states that the angle between the tangent BD and the chord BC is equivalent to the angle in the alternate segment, which is this. So they want us to prove the tan chord theorem. Step number 1, we start with the construction. Through the center, we have the diameter. You can label this maybe a T, because we don't have any other T. And then this must be connected. So what does that mean? I'll break this down into a 1 and a 2. And then I'll also break this into a 1 and a 2. So I'll say that B1 plus B2 is going to be a 90. Okay. Reason being, this is tan perpendicular to the radius. So what does B2 become? It's a 90 minus B1. Then I'm also going to do the same thing and say A1 plus A2 is a 90 because this is a diameter. So this will be angle in a semicircle. And then what does A1 become? A1 is the same as 90 minus A2. But from our angles in the same segment, we know that B2 is the same as A2. Is that true? We're saying B2 is the same as A2. Okay, where we see B2, we're gonna no, we're supposed to show this. This is wrong. It's supposed to be B1 and B2. Okay, so if that is the case, but even that approach was gonna make sense. Where we're saying B2 is the same as that. No, it's fine, no problem, no problem. Okay, so if B2 is the same as A2, we can replace that, meaning that A1 is going to be 90 minus B2. And now A1 and B1 are just showing us the same results. Therefore, A1 is the same as B1. Okay, so that is all you have to say. Remember, we said this and this angles in the same segment. Okay, then 7.2. In the diagram, where is the center of the circle? PSQ are points on the circumference of the circle. SRQ is a 54. SR and QR are tangents the circle from a common point. Okay, so we know that tangents from a common point will be equal to each other. So meaning that Q3 and S1 are the same. They want us to get the size of Q3. If that is X, that is X. Mean that twice X plus 54 should give us 180. But we were supposed to start by telling ourselves that SR is the same as QR. Tangents from a common point. And then what is 180 minus 54? That's going to be 126. And then divide by 2. Okay, so if you divide it by 2, you're going to get a 63. So I'm having that as 63, and I'm getting that also as a 63. And then they want us to get a size of P. Now, P is going to be a 63. Because of the tan chord theorem. Okay, can be this to that or this to that. So if this is a 63, then they want us to get O1. O1 is the angle at the center, which must be twice that 63. So which is 126. Angle at the center is twice angle at the circumference. Okay. And then question number 8, they're telling us that in the diagram below, O is the center, BCD is a cyclic quadrilateral, BCDE, okay. G is the midpoint of the chord EC. AB is a tangent, and then they're telling us that GD to OG is 3 to 2. So GD to OG, and then ED is 2 units. Okay. And then they want us to prove that AB is parallel to EC. Okay, so number 1, for us to have parallel lines, we can use alternate, corresponding, and co-interior. So one thing we need to know is that ABD is a 90. Reason being, tangent must be perpendicular to the radius or diameter. But also, we're saying G2 or G1 should be a 90, because this is a line from the center, and bisecting the chord should be perpendicular. So line from the center, or we can say perpendicular bisector. Line from the center to the midpoint. And if that is the case, then you just draw the conclusion that the angle ABD is the same as G2 or G1. Therefore, AB will be parallel to EC because of the converse of the corresponding angles. Okay. And then 8.2, can we prove that BE is the same as BC? Can we prove that those two are the same? So what we can do, we can try to use congruency. Okay. If I look at the triangle BEG and then BCG, we see that CG is the same as GE. It's given. And then we see that BGC is the same as G1, which is a 90, because angles on a line. And then we can also see that BG is the same as BG, because that is common, meaning that BGE is congruent to BGC. Therefore, BE should be the same as BC. Okay, so we can do it that way. Or you can also just compare the angles alone. Because if this is a 90, that is a 90. Okay. And then we also, what do we see? Because B is the same as D. B is the same as BC. Yeah, I think that approach is fine. It's better. If you look at the remaining angles and all those aspects, I think it's fine. Then if it's further given that FO is parallel to EC, determine the ratio of EF is to FA. So one thing we need to know is that GD plus GO gives us the total radius, which is OB, okay, which is the same thing. But then, from our proportionality theorem, if we get the HE divided by the HB, okay, it should give us just the same as someone that uses OG over OB. So meaning that HE is a 2 over 5. We are saying line is parallel to one side of a triangle. Or someone can say proportionality theorem because of the lines that are parallel. Okay, that's the first kind of aspect, and we need to bring in the EF and OR. So if we get the FE, okay, we're getting the FE, and then we are dividing it by the FA. It should give us the same thing as OG, which is the same as EH. Over the HB, which is still also 2 over 5 because of the proportionality theorem. Okay, so that is that. Then 8.4 determine the length of BC if the diameter is 20 units. The length of BC from here up to there. Okay, we say this is parallel to that, and we have a 90. Which one is the 20? BD is a 20. Okay, so we can find BE using the theorem of Pythagoras, because if all of this is 20, we have this as a 4, then we can find that. And say that our BE squared is going to be 20 squared minus the 2 squared, because they said ED is, okay, so minus 2 squared. And then we must put this under the square root. So punching this into the calculator, it's going to be square root, oops. Okay, 20 squared minus 2 squared, which gives us 6 root 11 units. But we say BE is the same as BC, which means it's 6 root 11. Okay, then move on to question number 9. In the diagram below, O is the center of the circle, DEC are points on the circumference, and then DB is also tangent at point D. We have a chord CD that is extended to point A, and C is also extended to point F. Okay, B2 is X, and then DE is parallel to AB. Okay, then DE bisects the angle CDB. CDB, meaning that this angle is the same as that angle. All right, then the first question is asking us to prove that CDFB Okay, prove that CDFB is a cyclic chord. So I can see an element of angles in the same segment. I think I can use that. Okay, so if this is X, I need to just prove that C2 is also X. And then if I can do that, then I'm good to go. So one thing I know for sure is that C3 is going to be X because of alternate angles. Because DE is parallel to AB. And then since this is a tangent to the circle, meaning that C2 is going to be X because of the tan chord. And then since C2 is the same as B2, which is X, therefore CDFB is a cyclic chord. Okay, because of angles the same segment. So converse of angles in the same segment. Okay, so that is how 9.1 would have been answered. And the 9.2, they want us to prove that triangle ADF, okay, that this triangle is similar to CBF, CDF. So something of that nature. Okay, so if this is a cyclic chord, simply means that C3 is going to be the same as that entire angle. Will it make sense? Okay, let's see. What we can start by saying is that the angle FBC is the same as angle D1. Okay, so this, we're equating it to the whole of this. Because remember we said this is a cyclic chord. So it's going to be exterior angle of a cyclic chord. So exterior angle of a cyclic chord. Okay, that is one. And then two, we are saying that C1, this angle, which is a tan chord, because this is going to be like in a circle. C1 is the same as D4 because of the tan chord. But we say this was X. Okay, meaning that A is the same as D4. Reason being, those are corresponding angles. Because DE is parallel to AB. So we are left with one more angle to go. Then automatically it will be the remaining angles. So we're going to say that D, no, it's F3, is equivalent to F1 because of the third angle, the triangle. So therefore, ADF will be similar to CBF. The 9.3. 9.3, they want us to prove that AD is the same as that. So what's going to happen is that when we look at our proof in the previous question of the similar triangles, we could say that AD divided by CB will be the same as DF over BF. Now that's according to the sides that are corresponding to each other. So AD over the CD and so on. So when I make the AD the subject, it's going to be the DF multiplied by the CB over the BF. Okay. So that is how we would have done that, because DF over BF and then all of that. Then 9.4, I want us to prove that this is that. So still, from where we stopped, if we can also use the proportionality theorem, since we have the parallel lines, we could say that AC divided by AD is the same as CF over AE. If you make AD the subject, it's going to be AC times AE over CF. Okay. Now we are saying that this is that. And then this is what we had previously. Okay. We know that AD is the same as. Now these two are the same because it's AD and AD, which means we just have to equate. Okay, so guys, that's what we had to do in this particular paper. I wish you guys all the best in your preparations and also in your forthcoming examinations. Bye-bye.
Welcome to Thundereduc, an online learning platform powered by professional, highly skilled and qualified educators.
We deliver structured CAPS aligned lessons for high school subjects, including mathematics, physical sciences, life sciences, geography, business studies, history, accounting, English, Afrikaans, and others.
For the intermediate and senior phases, we offer expert teaching in natural sciences, mathematics, social sciences, English, and EMS, designed to build strong academic foundations.
Access the distinction material books by clicking join button on our YouTube channel or download Thundereduc app on Google Play Store for all our study material and past exam papers.
Thundereduc offers extra classes for rewrites, old curriculum, and other students from grade 4 to grade 12 through online and physical classes.
Subscribe to our YouTube channel, Thundereduc, for reliable curriculum-focused learning and stay updated with the latest educational content.
Please like, share, and turn on notifications so you never miss a lesson.
Visit us at www.thundereduc.com
or call 0786 636 613 or 084 833 1738 for more details.
Thundereduc, we focus on quality.
Post memorandum of the paper 2 mathematics June examination for grade 12 2025. Okay, so within this paper we have a well-structured paper whereby the answer book is also merged with the question paper. So the paper had 9 questions. We apologize for the quality of the paper today, but we shall work with it, okay? So only answers will not be given full marks, meaning that we have to show our calculations and workings, okay? Information page with the formula will be included at the end, necessary round of 2 decimals. Okay, and then candidates may not retain a question paper or remove one from the exam room. Okay, all right. Then we have a lot of instructions here, but that's not the business of the day. Question number 1. We've been told that in the diagram below, ADQC, okay, and DPB are straight lines. Okay, so this and then this are straight lines. Okay, this is a point on the y-axis. A and B are points on the x-axis. The equation of BC is given as this. And then the equation of AC is given as this. It's further given that P is that, Q is that, and then T is that. Then the distance TP is given as that. Okay, then 1.1, they want us to get the gradient of PQ. So whenever a question asks us for the gradient, we know that gradient is given as the change in y over the change in x. Alternatively, you can tell us the y2 minus y1 over x2 minus x1. Okay. So what I'll do, I'll say 3 minus 1, okay, over 7 minus 6. So 3 minus 2, sorry, 3 minus 1 is a 2 over 1, which is the same as a 2. That should be 2 marks, okay? Then they're asking us, why is PQ parallel to BC? Why is this line parallel to that one? Now, since we found the gradient here to be 2, we know that when lines are parallel, the gradients must be the same. So we're going to say that the gradient of BC is a 2 from the equation, meaning that the gradient of BC is also the same as the gradient of PQ. That's the kind of explanation. We must give a reason. So we're going to say that they have the same gradients. Okay. The lines have the same gradient or equal gradients. Okay, so that is 1.2. Then 1.3. They're telling us that if Q is the midpoint of DC, we must get the coordinates of C. If Q, this line, this point, is the midpoint of DC, then we need to find the coordinates of C. So we don't know the coordinates here. So that is X and Y. We can get the coordinates here from this equation, whereby we know at D, X is a 0. If X is a 0, then Y is going to be a 2. Alternatively, what we can do is break down or rewrite this, meaning that 7y is going to be x plus a 14. Let's divide through by 7. We have 1 over 7x plus 14 over 7, which is a 2. So meaning that D is going to be 0 and 2. Okay, with our midpoint, so we're saying that D is 0 and 2. And then we see Q is 7 and 3. We're seeing C as X and Y. Let's use the midpoint formula that talks about X1 plus X2 divided by 2 must give us the midpoint, which is a 7. Okay. Same story with Y1 plus Y2 divided by 2. We must get the Y coordinate of the midpoint. 3. So let me do the substitution. So X plus 0 divided by 2 must give me a 7. When I cross multiply, meaning that our X is a 14. And then Y plus 2, this Y and this 2. Divide by 2 must give us this 3. Cross multiply, Y plus 2 is a 6, meaning that Y is a 4. So the coordinates of C are 14 and 4. Okay, and then 1.4, they want the size of ACB. Where is ACB? So A, C, and B. So this angle here. So with that, I can use the angle of inclination, okay? I can find the size of beta since I have my gradient as 2. Then I can find the size of theta since I have my gradient as 1 over 7 from here. All right, so we know from that inclination method to say that M is equal to the tan of theta, okay? So for us to get theta, we said it's 1 over 7 equals the tan of theta, meaning that theta is the arctan of 1 over 7. All right, so let's punch that shift tan, 1 over 7, getting a small answer, which is 8,13 degrees. Then for beta, we're going to do the same thing. M is equal to the tan of beta. So our M was a 2, because the tan of beta, meaning that beta is going to be the shift tan of 2. Beta becomes 63, 43 when I punch this into my calculator. All right, so for us to get the angle of interest, we know that this beta is an exterior angle, which must be the sum of this angle C and then that angle A. So we're saying that A plus C must give us beta. Okay, A plus C must give us beta, meaning that the C of interest will be 63,43 minus 8,13. When I do the subtraction, I'm getting 55,3 degrees. So that is what we had to do for 5 marks. But why do they give a lot of space? To give people an impression that there's a lot of work to be written. Okay, but we understand they are being generous so that if, let's say, learners make any errors and mistakes, can just cross out and write in some extra space. Okay, then 1.5, they want us to get the area of BODC. Let's see, BODC. So when you talk of B, O, D, and C, looking at this entire shape here, this quadrilateral. So there are two ways to it. One, we can use what we just calculated, the 55, it's 3 degrees, because that's what we got. Whereby we can get the distance CD, get the distance CB, use your area rule for this triangle, and then get the area of this right angle triangle, and then you plus them together, you're gonna get an answer. What I believe is the quickest way. Okay, I'm trying to avoid decimals. I'm going to look at this entire big triangle ABC. So if I get the area of ABC, I subtract the area of ADO. Okay, whatever I get will be the area of the quadrilateral. But this approach of mine comes with some conditions whereby I need to get the coordinates of A and I also need to get the coordinates of B. So with A, we know that this is the x-intercept and we have this. If we replace x with a 0, no, y with a 0, y is with a 0, meaning that our x is going to be negative 14. Okay, so we shall come down here and say that if y is 1 over 7x plus 2, we said y is a 0. 1 over 7x plus 2, move the 2 that side, so negative 14 is going to be x, meaning that a is negative 14 and 0. Same story with the b, coordinates of b. It was a 2x minus 4, if I'm to remember correctly. Let's not guess here. It's 2x minus 24, sorry. So 2x minus 24. So if it's a minus 24, I'll equate it to 0, move the 24 that side, 2x is 24, meaning that x is 12, meaning that our coordinates of b are going to be 12 and 0. So if that is true, I'll go back and say that if that's a 14, and then this is a 12, so the total distance for my base is going to be a 14 plus a 12, okay? And then my height is going to be the y value of the C, which we got as what? As 4. So I'll say that the area of ABC, okay, is going to be a half. The base is 20, is it 14 and 12 is a 26 multiplied by the height, which is 4. What does this give us? It gives us a 52 units squared, okay? So that is the entire big triangle. Then when I come and look at this small triangle here, it's right angled because this y-axis here. And since this is the y-intercept, this will be 2 units. This will be 14. So a half of 14 times 2, which gives me 14 units squared. Then I need to do the subtraction. So area of BODC is going to be my 52 minus 14. Okay, 52 minus 14, we must get something like 38 units squared. Okay, so that is how I would have approached this. But you can use your quick way or the shorter way of finding the distance CD, find the distance CB, and then use the area rule, and then you plus this, okay? But with that approach, you're going to get an answer which is in decimals, but it should be very close to the 38. Okay, so that is 1.5. Okay, then 1.6, if TP is square root of 293, they want us to get the value of K. So we can use the distance formula, whereby we know that our K is bordered by which coordinates? It's K and -1, not so. K and -1. Then we have P, which is 6 and 1. 6 and 1. So P is saying the 6 and 1, and then T is basically K and -1. So let's use the distance formula, whereby we know that our TP is going to be the square root of x1 plus x2 squared. It's not a plus, it's supposed to be a minus. Okay, x1 minus plus y1 minus y2, we square that. Let's do the substitution. So that's going to be root 293 is equal to the square root. I'll say K minus 6 squared plus -1 minus 1 squared. Then I need to square both sides so that I get rid of the root sign. Okay, so 293 is equal to, open this, K squared minus 12K plus 36 plus, when I simplify that, I will get a 2, which is giving me a 4. So let's move everything to one side so that we get a quadratic. So minus 12K, this is a plus 40. And then 293, we're subtracting a 40, we're getting 253 negative, okay? Minus 253 is equal to 0. You can use your quadratic formula, or you can just use your factors. So this is going to be plus 11. And then this is going to be minus a 23. Okay, if I'm to really do that. But quadratic formula would make life a little bit easier, okay? Meaning that K should be a -1 or K should be a 23. But looking at the position of K on the Cartesian, we're seeing it on the negative side, meaning that K cannot be a 23, but rather a -11. So this is out. Okay, so that is what we would have done for that. Then 1.7, we must get the coordinates of E, whereby E is in the second quadrant, such that ABCE is a parallelogram for 2 marks. Now, one thing we know is that whenever they ask us about a parallelogram, ABCE, and we need missing coordinates, the approach to use is going to be the midpoint. Okay, so with the midpoint, we know that the midpoint of this diagonal must be the same as the midpoint of the other diagonal. So for AC, since we say this was a 14 and a 4, 14, -14, meaning that the midpoint is at a 0. When you look at 0 and 4 divided by 2, so D is our midpoint. So this midpoint must be shared between B, E, and also A, C. So I'll put my X and Y here and then apply the midpoint. So we say this was a 12 and 0. Okay, so what we're going to do is this format. Have to flip right and back and so on. So we said B is a 12 and 0. We're looking for our midpoint D is 0 and 2. And then we're looking for the coordinates of E, which is A and B. So let's apply the midpoint formula and say that 12 plus A divided by 2 must give us a 0. Cross multiply, meaning that our A is going to be -12. Then if we get 0 plus B divided by 2 must give us a 2. Our B should be a 4. That's all they needed. And then at 1.8, determine the equation of the line that is perpendicular to AC and passing through this point. So the only thing that we need will be the gradient of AC. Okay, what are the coordinates of AC? Let's see, okay, we have AC, which is this, and we have the equation, okay? So the gradient of AC is 1/7. Okay, so we're saying the gradient of AC is 1/7, meaning that the gradient of the perpendicular should be -7, because we know that the product of gradients of lines that are perpendicular should give us -1. Okay, so if we have this, we have that point, then we can just substitute y minus y1 is equal to m into x minus x1. We simplify that, we shall say y minus 3 is equal to -7 into x minus 7. Open that bracket and see. So y is going to be -7x. That's going to be a plus 49 plus 3. So it's a -7x plus 52. This becomes our final answer. Okay, so that is to do with question number 1, 25 marks, done. We move on to question number 2. Question number 2, they're telling us that the diagram below, in the diagram below, we have a line that is a tangent to the circle. Okay, so I always prefer rewriting this line to something that is easier to work with. Okay, I'll write it as 2x plus 1 because I'm moving the y that side. Okay, so it's a tangent. Then Q, we have M, which is A and B. We have G, which is 2 and 5. And then the center of the circle lies on this other line. X plus y is equal to 9. Okay, then what do they need? They want us to get the gradient of GM. Now we're seeing that GM is perpendicular to this line, but we know that this line is having a gradient of 2. Remember what we said was that M1, like I'll say gradient of GM multiplied by 2 should give us a -1. So gradient of GM must be a -1/2. I mean, you don't even need that working out for as long as you identify the gradient of the tangent. Okay, so that is done. Then they want the equation of GM. So we have the coordinates. Yes, let's use 2 and 5. Okay, we're using G, which is 2 and 5. So you're going to say y minus 5 is equal to -1/2 into x minus 2. Open up as you transpose. So -1/2, that's going to be a plus 1 plus 5. What will this become? It's -1/2 x plus 6. There we go. So that is 2.1.2. Then 2.1.3, they want us to get the coordinates of M. We know that M represents the center coordinates, okay? Now, we have the equation of this one. We said -1/2 x plus 6. We have the equation of this one, which is x plus y is that. Meaning that we need to solve the two simultaneously to determine the x and the y, since the two lines are meeting just at one point. So I'm going to say that from the x plus y is equal to 9. Y is -1/2 x plus 6. So where there is y, I'll replace that. Okay, equation 1, equation 2, we can say substitute 1 into 2. So it's going to be x plus -1/2 x plus 6 must give us a 9. Let's move the 6 that side. What's 1 minus 1/2? We're going to get just 1/2 of x. Then 9 minus 6 is a 3. Cross multiply, it means that our x is what? A 6. So if x is a 6, y will definitely be a 3, because x plus y must give us 9. So 6 plus 3 should definitely give us a 9. So since they want the coordinates, we're going to say that M is going to be 6 and 3. All right, then hence or otherwise calculate the length of the radius. So with the radius, we know that we have our coordinates AM 6 and 3. We have G, which is 2 and 5. So let's get the distance GM. Okay, I'll omit the formula and just say x minus x1, so 6 minus 2 squared plus 3 minus 5 squared. Okay, so when I punch this into the calculator, that's gonna be 4 squared plus plus 4, which gives me 2 root 5. Okay, so the radius is basically 2 root 5 units, since it is a measurement. Then write down the equation of the circle in this form. So we need to start by rewriting the general expression. So x minus a squared plus y minus b squared must give us r squared. So we know that our m was a 6 and what? 6 and 3. So it's going to be x minus 6 squared plus y minus 3 squared, and then is equal to, you said 2 root 5. This is squared. Okay, we open this up. It's going to be x squared minus 12x plus a 36. That's going to be y squared minus 6x plus a 9. It should give us 5 and 4, which is a 20. Okay. Then I'll just regroup into the format they want. So I have my x squared